Let's move on now to Maria, if you'd like to introduce yourself.
Start this over. I like seeing this intro. Screw it. This makes me think of Game of Thrones, honestly.
One fish, two fish, red fish, blue fish.
Straight up Dr. Seuss, dude.
Congratulations. Today is your day.
Oh my
You're
God.
off to great places. You're off and away.
It was a bright, cold day in April, and the clocks were striking 13. Winston Smith, his chin nuzzled into his breast in an effort to escape the vile wind, slipped quickly through the glass doors of Victory Mansions, though not quickly enough to prevent a swirl of gritty dust from entering along with him.
All right, this is CS50, and this is week 2. And if we could,
Interesting.
after this dramatic reading, a round of applause for our volunteers.
Oh, hey, what's up, dude?
So
this is what I do when I'm
from week 1 that we now have a new
I'm
way
trying to
express some of the
occupy my
ideas that we
daytime
first
with.
explored in week 0, like functions and conditionals and variables and the like, and now we're doing in
I was doing great at Rocket League
Scratch.
yesterday.
Today what we're going to start to focus on is some real-world problems so that we can take for granted that we have
Oh,
that
most of the
expressiveness.
time.
We have some tools in our toolkit
I was on a
and
win
actually
streak
start
for
to
a
solve
while.
some real-world problems if representative thereof. In particular, the real-world problem that we're going to start today and this week with is that of reading levels. Odds are when growing up, you read at a certain level based
I
on the
feel so
age at
cold.
which you were at. Maybe it was first grade level or 5th grade level or 10th grade level or the like, and that was a function of just how comfortable you were with the words in the book or words on the screen that you were reading. What you've just
The last
heard,
game
thanks
you
to our
played, I was
volunteers,
there.
are 3
Oh, you were the
different
one
reading levels
that
that
you were
each
like,
of
I'm
the
gonna
3
win this one for you.
volunteers at. And in fact, why don't we go ahead and hear them again?
That was
And be a little more
amazing.
thoughtful this time as to assess.
I was
at
like,
what
man, I'm gonna
reading
feel
level
bad if we
your
lose now.
classmate is reading. So let's start with Leah, if you'd like to introduce yourself first.
Hi, I'm Leah. I'm a first year in Holworthy.
Because I wasn't playing very good that last game. I was
One
playing
fish,
so sloppy.
two
I was like,
fish,
man, I gotta
red
go to
fish,
sleep.
Blue fish.
So at what reading level would you say Leah reads based on her recitation thereof? Yeah, in the front. Kindergarten. Okay, so a fairly young age. And what makes you say kindergarten? Okay, very short phrases without much complexity, and indeed, according to one scientific measure that we'll explore in this week's problem set, indeed, we would say that Leah reads before grade 1, so kindergarten would indeed be apt. But welcome to the stage here. Let's move on now to Maria, if you'd like to introduce yourself.
Yeah, hi, I'm Maria. I'm in Stoughton thinking of applied math. Congratulations. Today is your day. You're off to great places. You're off and away.
Another familiar phrase, perhaps. At what reading level would you say Maria is? Well, yeah, over here. And what makes you say 2nd or 3rd grade? Okay. So now we're starting to introduce complexities like rhyming and a bit more substance to the quote. And indeed, based on that that same measure that I described earlier, which will involve a mathematical function that somehow analyzes what it is Maria just said, indeed we would conclude that she read at a 3rd grade level or grade 3. Finally, Omar, if you'd like to introduce yourself and read once more yours.
Okay. So, hi everyone, I'm Omar. I'm a freshman at Hurlbut thinking of doing Comp Sci, and this is my reading. It was a bright, cold day in April, and the clocks were striking 13. Winston Smith, his chin nuzzled into his breast in an effort to escape the vile wind, slipped quickly through the glass doors of Victory Mansions, though not quickly enough to prevent a swirl of gritty dust from entering along with him.
All right, sort of escalated quickly. What reading level is Omar at, would you say? Someone else.
I don't know, 6th grade or something. Fuck off.
Yes, right here in the front. Okay, 8th grade, and what made you say that? more complex sentences, more complex words, and indeed, according to that same measure, this full paragraph of text now, which indeed has even more grammar when you see it there on the screen, would be said to be at grade 10 because of that added complexity.
Grade 10,
so
god
said,
dang, that's like sophomore,
to be able to
Jesus.
somehow sort of crunch these numbers to determine, given a body of text, at what reading level someone is. But in order to do that and apply any metrics to a body of text, we're going to need to represent that text in memory using something like strings from last week. But last week with strings, we could really just print them out or display them wholesale on the screen. But I think we're going to need to break down these various texts and others like it at a finer grained level. And indeed, among the goals for today is to explore exactly that, and also to take the proverbial hood off the car,
I see you,
to take
man.
a look underneath.
I know
and
this ain't
how
super, it's
the
pretty
computer is
boring, but
actually working, how these things
I
like
gotta do
strings
it.
are
I got
actually
to do
functioning.
it.
So if you could join me one last time in a round of applause for our volunteers. Thank you so much for helping out. Thank you, guys. Thank you. Thank you to Maria as well. So among the goals for today, beyond exploring a representative problem like this of reading levels, is going to be another one which is even more important and more omnipresent than reading levels, namely cryptography, the art of scrambling information, or specifically encrypting it so you can send secure communications. Now, you sort of take this for granted increasingly nowadays, that when you send a text message or perhaps an email or check out online with a credit card, that somehow or other your information is secure. And over the coming weeks, we're going to explore to what extent that is actually true and why or why not. Now, with cryptography, similarly too, if we want to be able to send messages securely, such that if I want to send a message to you, I don't want anyone else in the room to be able to figure out what it is I have said, even if they physically intercept that message, which is all too possible in a digital world, we're going to need to come up with metrics and mechanisms for actually scrambling information in a reversible way, so that I can write my message, somehow scramble it, you can receive that message, even if after it's passed through many other hands, and you can descramble or decrypt that same message. So for instance, here on the screen is a message, a fairly simplistic one, that has somehow been encrypted, and we'll see by the end of today and by the end of this week that this encrypted message, and there's a bit of a tell on the end there, actually will be said to decrypt to this is CS50. But why is going to be the underlying question, and what additional tools do we need in our toolkit in order to do that? Another word on tools. So up until now, you've probably experienced some bugs, whether it was in Scratch or ever more so in C. In fact, don't feel too bad if like the very first program you wrote in C didn't even work. You couldn't even make it or compile it until you went back and fixed some of the code that you had written. Well, it turns out that bugs, mistakes in programs are ever so commonplace, and even though we've already provided you with tools like the virtual rubber duck at CS50.ai, also embedded into VS Code at CS50.dev, of whom you can ask questions along the way, among the goals today are to give you some lifelong tools at how you can actually debug software yourself when you don't have a duck nearby, when you don't have a TA nearby, let alone any humans at all. So with debugging, there's going to be a number of techniques that we can use, all toward an end of finding and removing bugs or mistakes from our software. And perhaps the person best known for having popularized this term of bugs is that of Dr. Grace Hopper, pictured here, who was a Rear Admiral in the Navy and was one of the original programmers of the so-called Harvard Mark I, a very early mainframe computer that if you wander across the Charles River over to the Science and Engineering Complex here at Harvard, you can actually see part of this on display still in the lobby. It was succeeded by the Harvard Mark II, and on the Harvard Mark II, Dr. Hopper and her team were known for having put this note in their logbook after having done some number crunching on the system there. And if we zoom in, they found a problem with the computer this one day whereby there was literally a bug, a moth, inside of the circuitry of the computer. And as was written here, first actual case of bug being found. And ever since then, do we say ever more so the phrase bug in debugging
oh
when it
my
comes
God,
to
that's where it came from as well.
Problems in our code. So let's start with just that. In fact, let me go over to VS Code and let's deliberately make some mistakes together that might very well be reminiscent of some of the mistakes you've accidentally made thus far, but along the way give you all the more tools for solving those problems, as opposed to sort of having to ask someone else, be it virtual or physical, for help and actually find these mistakes in your own code. Let me go ahead and consciously, in VS Code, create a program known to be buggy called buggy.c. And in this program, let's go ahead and do some fairly familiar code initially. I'm going to go ahead and start, just like we did last week, with int main void. More on that today before long. Inside of my curly braces, I'm going to say printf hello comma, world.
Might as well
That's
work
it.
on my
Now I'm
time.
going to go back to my terminal window here. I'm going to go ahead and do make buggy to make a program from that source code. But before I do, odds are, even after just a week of this stuff, you can probably spot a few mistakes I've made, a few bugs. What do you see wrong already? Yeah.
I ain't got nothing included, bro.
I didn't include standard io.h, that so-called header file, which is important because it tells the compiler that I plan to use functions therein, like printf, which clearly I'm doing. So let me go in and include standard io.h. What else seems to be wrong here? Yeah. I'm missing a semicolon at the end of line 5 here, so I'm going to go ahead and add that in. And this is subtle and arguably not a bug, but maybe an aesthetic detail. What else have I done arguably wrong? Yeah, back.
Oh, at the end. Oh, I forgot
Yeah, I
to do
forgot my \n, the new line character, just to move the cursor to the next line so that when I get a new prompt, it's on a fresh line of its own. Again, more of an aesthetic, but certainly a pretty reasonable thing to do. So let me go ahead now and actually, in my terminal window, run make buggy, and it indeed compiled. But up until then, had I not fixed those mistakes, I would have triggered a whole bunch of bugs, a whole bunch of error messages as a result. In fact, let's rewind in time and undo the fixes I just made, and go back to the original form here and try running again, make buggy, enter, and we'll see some scary looking messages up here. Let me scroll up to the top of the output here, where we see buggy.c:3, which means line 3. That's where the problem is right now. Error, call to undeclared library function, printf with type, and then it starts to get a little more complicated, but I do see clearly that it's calling my attention to printf. So hopefully at some point, if not last week, hopefully this week onward, your instinct will be, oh, all right, I'm an idiot, I forgot the header file in which printf is actually declared. It's not a huge deal, it's gonna come with practice, so that's how I might know more intuitively what, in fact, the solution here might be. Now here's another common mistake that I've just gone in and fixed, but I did do something wrong, and hopefully none of you actually did this because it's an annual FAQ. What did I just do accidentally wrong? So it's not studio.h, it's standard io.h, so do kind of ingrain that one for standard input-output. The next, though, bug that I haven't yet fixed is that semicolon. So let me clear my screen and rerun make buggy. I should no longer see that first error message anymore, but I now do see another error message on line 5, expected semicolon after expression. Right, that one's pretty explicit, so I'm going to go ahead and fix this. But notice that up until now, my code wouldn't have been able to compile because of those 2 error messages. It stopped showing me by showing me these errors. But at this point, if I run make buggy enter, it did in fact compile, and yet it's arguably still buggy because when I run /buggy, I get my prompt on the wrong line. So this is a distinction now between a syntax error, something that, or a programming error that outright stops my program from compiling. It's sort of a deal breaker, versus something that's maybe more of a logical error. I actually meant to move the cursor to the next line, and so there's different types of errors in the world as we're seeing here. Of course, if I rerun make buggy again, /buggy, now we're back in business, hopefully with the intention of having this display exactly that. All right, well, let's modify it to look a little more like something else from last week. Recall that last week I started to get someone's name more dynamically. So I said something like name equals get string, and that was a function we introduced, and I might have said something like this, what's your name, question mark, with a space just to move the cursor over. I know now I definitely need to end my thought with a semicolon. I could try and compile this, make buggy now, and I'm seeing a different error message altogether that you might not have seen yet. So on buggy.c line 5, error, use of undeclared identifier name. What now is the mistake that I've made? Why does it not know?
You gotta
Yeah, I forgot to declare the type of this variable, which for those of you with the prior programming experience is not something you have to do in some languages like Python, for instance, but in languages like C, C++, Java, and others, you do in fact need to explicitly tell the compiler that you want to instantiate a variable, create a variable in the computer's memory by telling it its type. And it's not going to be an int, because I don't want an integer, of course, in this case. I want text, which we now know to be called string instead.
No, I need to put it there.
All right, I think this fixes that bug, so let me do make buggy again, and hopefully, a fatal error this time, again indicating that my code did not recompile. On line 5 still,
because this doesn't provide the string.
It says,
you need to
include use of undeclared identifier string.
Include
did
something
I mean standard in?
Can support
so this
string.
is a bit of a red herring. The compiler's trying to be helpful and saying, did I mean standard in? but I don't think I actually do. That just is the most similar
There we
looking
go.
word in the compiler's own memory. What's the actual mistake that I've made here? Yeah.
CS50.
Yeah, I didn't include the CS50 header file because string, recall, is a feature of the CS50 library, as is getString and getInt and others. So the solution here is indeed to go up here, and just to be nitpicky, I tend to alphabetize my header files. It's not strictly required technically, but stylistically, I find it nice to be able to skim the header files alphabetically to see if something is there,
There we
or
go,
not.
there
I
we
can
go.
include CS50.h in addition to standard
Got
IO.h.
it.
And it's in that file, CS50.h, that not
then
only
we
is
wanna make a
getString
name.
declared so that the compiler
I'm
knows
sure
that
he's
it
gonna
exists. It turns out
probably
so
touch
is the
this
word
topic.
string. So this is a bit of a
God
white
dang,
lie.
what
This
a
is something we do in the
string.
early weeks of the class. We dug up these old training wheels from a
don't
bicycle.
remember
The whole
a bit.
idea being to sort of keep you up and avoid you having to do too much complexity early on. The point of these training wheels in the form of the CS50 library is to let us kind of ignore what a string really is for just another week or two, after which we will then peel back that layer, take off those training wheels, and reveal to you what is actually going on. So for now, strings exist,
Oops.
but they exist because of the CS50 library. In a couple of weeks, they're still
Nope,
going to
let's
exist,
see what's
but
extra.
we're going to call them by a different name, as we'll eventually see. But everyone in the real world, every software developer uses the phrase string, so this is a concept that exists. It is not CS50 specific at all. It's just that in C, the word string doesn't typically exist unless you make it so, as we have. All right, so I think now, if I clear my terminal window and rerun make buggy, now it should in fact compile, and if I run /buggy, enter, I should be able to type in my name, and now, voila, hello. So this is now not a syntax error, because I didn't screw up my code per se, like it compiled. Everything is grammatically correct, so to speak, but logically, intellectually, this is not what I wanted, right? I wanted it presumably to say hello, comma, David. So let's fix one final bug here. How do I fix this? On what line?
On
Do I get
line
it to say, yeah,
7.
hello, David. Yeah, on line 7, I need to do the string placeholder, the format code, so to speak, %s, and then one more thing, someone else. What do I do after this? Yeah, and back.
Gotta put the variable name.
Yeah, a comma, and then add the variable name that contains the value I want to substitute in there, which is indeed name, though I could have called it anything I want. All right, so now make buggy, enter, seems to have compiled again, /buggy. Now I type in my name once more, and now we're back in business. So over the course of these few exercises, I meant to make most of all of these bugs, these mistakes, but they demonstrate not only syntax errors, which are just going to stop the compiler in its tracks, like you won't even be able to compile your code until you fix those things, but even after that, there could be these latent bugs that seem to not be there until you actually provide input and see what's actually happening at so-called runtime when you're
Man, I'm
running
getting
the
tired
actual
of this
code.
goddamn
And
headache.
so here's where it's no longer as easy as just reading the error message and figuring out what it means, because there is no error message that appeared on the screen when it said hello, comma, world. We had to use our own human intellect and realize, okay, that's clearly not what I wanted. Had you run CS50's own check50 program on something like that, we could have told you that that's not correct by automatically assessing the correctness of it, but the compiler has no idea what you are trying to achieve logically. It only knows about the language C itself and the requisite syntax for actually writing and compiling code. So how could we go about solving logical problems in code? So I would propose that we start to consider this here list, whereby when you want to find a logical problem in your code and better understand what's going on, or really what's going wrong, printf is going to be your friend. Up until now, we've used printf to literally print on the screen, hello David, hello Kelly, or anything else on the screen. But you can certainly use printf temporarily to just print stuff out inside of your program that you might want to better understand.
Yep.
And then once you understand it, and once you've solved some problem, fine, then you can delete those temporary lines of code, recompile, and move on. So let's use printf as a debugging tool in that sense. Let me go back over to VS Code here, and let me, in this same program, buggy.c, sort of delete everything and start over with a different sort of bug.
Okay.
I'm going to include standard io.h at the top. I'm going to do int main void after that. And then inside main, I'm going to do a simple for loop that just prints out like a stack of 3 bricks. Like we saw in the world of Mario, when Mario needed to, we claimed, sort of jump over a stack of bricks. We want to print out just 3 of those at the moment. So I'm going to go ahead and say for int I equals 0, I is less than or equal to 3, because I want 3 of these, I plus plus. Then inside of this for loop, I'm going to go ahead and quite simply do printf hash symbol to represent the brick, followed by a new line to move the cursor to the next line, semicolon to complete the thought. Now, I've deliberately made a stupid mistake here, but in the context of a simple enough program that we can focus on the debugging technique, not on the obscurity of the bug in question. Hopefully you'll spot the bug in just a moment, if not already. When I do make buggy now and do /buggy, I don't get 3 bricks.
Okay.
I, of course, get 1, 2, 3, 4 total. So there's a logical bug in this program, and odds are you can already spot what it is.
Did I get everything?
But let me propose that this program is representative of a type of problem that you can solve a little
There's
more
a logical
diagnostically
bug in
by
the
poking
program.
around and really asking the computer via printf to show you what's really going on.
0,
And I would
I is
propose that
less
one of the
or
most
equal
helpful
to 3
techniques
I
in a
plus
situation
plus.
like this, if you're trying to wrap your mind around why are there 4 bricks instead of 3, well, clearly this is related to the loop somehow. So let's look a little more thoughtfully at what the value of I is.
It's
before
less
we
than
print
or
out
equal to.
each of those bricks. And I might literally do something like this temporarily. Printf, quote unquote, I is %I \n, close quote, and then I could just print right here and now the value of I.
Yeah,
just so
because
that I
it'll
can
show you the
actually see it.
value
Let me now
before,
go down into my terminal window,
and then you'll
make
know
buggy
why.
again, /buggy, and now, and I'll full screen my terminal, I'll get some diagnostic information at the same time. So when I is 1, I get a brick. When I is 0, I get a brick. When I is 1, I get another brick. When I is 2, I get another brick. When I is 3, I get a 4th brick. So now I
it's
can
equal
kind of
to,
see
bro.
that, okay, my loop is working, but I'm going too far.
What is it?
I'm going too long. Now I can do this even more succinctly
Uh-oh.
for what it's worth. I don't need a whole new printf statement. I could just go into my existing printf, put my %I there,
Your burnt-
and then
what?
maybe just space, just to scooch
Your
things
car?
over.
Oh,
and
the
then print
seatbelt?
out I in that same line. If I now do
Okay.
make buggy /buggy, okay. Now
Okay,
I'm seeing that
okay,
I'm
I'll
printing
fix
a
it.
hash, a brick, for each value of I from I equals 0, 1,
I think
2,
I'll fix it.
and also 3. So
don't
the
know how
solution,
to-
of course, is that I shouldn't be starting at 0
How do you
and
get it
iterating less than or equal to 3. The solution is like, oh, I'm an idiot. I should have said less than 3. Or if I prefer to count starting
Can
at
you
1,
get
like a
it
normal
out?
person, I could have set I equal to 1 and then go up to and through 3. But as I claimed last week, the canonical
think it
way,
comes
the
out.
most common way to do this is start counting at 0 and go up to, but not through the total value that you have
Are you
in
sure?
mind. But there's
I
going
don't
to be
think it
another
comes out.
technique that's worth knowing here. Let me go ahead and sort of abstract this away by whipping up a
doesn't-
slightly better variant of
I don't
this as
think it
follows.
does.
Let me go ahead and delete this for loop. Let me assume for the moment that inside of main, I'm going to ask the user now for the height of a pyramid, and I'm going to do something like this.
I don't
Int
know, it
h
doesn't do
equals
anything.
get int, and let's prompt the user
know,
for the
I don't
height
break
value
it.
of this pyramid, or this wall. And then let's go ahead and assume there exists a function called print column, who takes as
Okay, yeah.
input
I
a
did it.
number h, which is how many bricks you want to print. Now, this function does not exist
Oh,
yet,
man, I'm
print
missing out.
column. GetInt does exist, but I don't have access to it. So let me not make the same mistake twice. What do I need to add at the top of this file? Yeah. I need the CS50 header file because I'm using the getInt function now, which again
Oh, yeah.
comes from our library, not C. So let me go ahead and include CS50.h. But now print column, I can invent this function myself. So let me go ahead
There you
and
go.
say
I fixed it.
void print column int height in parentheses. More on that in just a moment. And then I'm going to recreate the loop from before. For int I equals 0, I is less than or equal to the height. So I'm going to deliberately for now make that same mistake as before. I++, and then inside of this for loop, I'm going to go ahead and print out a single hash and a new line to represent that there brick. So now, main can use a function called print column. This is just kind of stylistically bad to put anything other than your main function at the top, but recall that if I move my helper function, print column, and it's a helper function insofar as I made it to help me solve another problem, I can't recompile and run my code now. Why? The compiler won't let me.
Because
Yeah.
you got to put it at the top, man. You can make it down here, but you gotta tell the computer you're gonna put it up here.
7 of my code, it's going to abort compilation because it doesn't know what print column is. Why?
You gotta be like,
Because
you
I
gotta
don't
tell it like, hey
what
man,
is
it's all
until
good.
line
I'm gonna
10.
make it.
And this
Don't
is
worry
the only
about it.
time I propose that copy paste is
Put it up
reasonable.
here.
Is to highlight and copy the very first line of that function.
Don't be
paste it
lazy,
above
just
main
type it
with a
out.
Semicolon, and that's a
It don't even
so-called
take that
function
long.
prototype. It specifies what the name of it
Also
is,
stupid.
what its inputs are, if any, and what its output is, if any. And more on these inputs and outputs later on. But now, this is just a more complicated, but more modularized version of this same program. Let me do make buggy, still compiles, /buggy, type in 3, and I still have that same bug. But the catch now is that my code has gotten more complicated. And the point of my having abstracted away this idea of printing a column into a new function is that there's just more code now to debug. I could certainly go in there and start adding printfs, but at some point printf is going to be a very primitive tool, and you're going to waste more time adding printfs, recompiling your code, running your code, changing the printf, recompiling your code, running your code. It's going to get very tedious quickly when you have lots of lines of code on the screen. So can I actually step through my code line by line, maybe like your TA would in a section or a small class, line by line walking through the code? You can, because another tool that you have access to is that called debug50. So this is a CS50 command that will start an industry standard debugger. And a debugger is a piece of software that is used in the real world that literally lets you do that. Debug your code by letting you slow down or even pause execution and walk through execution of your code line by line. The only reason we call it debug50 is because in VS Code, it's a little annoying to start the debugger, and so we automated the process of starting the debugger, but everything thereafter has nothing to do with CS50 and everything to do with real-world software engineering techniques. So how do we use this? Let me go back to VS Code here, and let me propose that I want to step through this code line by line, just like we might at a whiteboard in a smaller class, to figure out why I'm getting 4 instead of 3 hashes. Well, in my terminal window, what I'm going to go ahead and do is this. Debug50 space /buggy. So debug50 is the command. It needs to know what program I want to debug, so I'm specifying /buggy, which is the name of the program I just compiled. I'm going to get an error, though, the first time I run this, as will you if you make the same mistake. I'm about to see this message here. Looks like you haven't set any breakpoints. Set at least one breakpoint by clicking to the left of a line number and then rerun debug50. So what is this really telling me? Well, the debugger has no idea when and where I want to pause execution so as to start walking through my code line by line. It wants me to tell it where to break, that is, where to pause, by clicking on a line number. So let me hide my terminal for just a moment, and you've probably never done this intentionally, but if you hover over the space to the left of your program's line numbers, you'll see a little red dot, a little stop sign of sorts. If you actually click on a line number, that red dot will stay there, and you can see the hover here saying click to add breakpoint. What I'm going to go ahead and do is say click to add a breakpoint at main. Main is the entry point to my program. It's the default function that gets called. Let's break right away so I can step through this code line by line. All right, let me reopen my terminal window and clear it, and then run debug50 again with /buggy enter. And now a whole bunch of stuff is going to happen quickly on the screen, and then it's going to clean itself up, because once the debugger is running and ready to go, it's going to allow me to start stepping through my code line by line. So what is going on? Well, notice nothing has happened in the terminal yet. Why? Because my code has been paused inside of main. In particular, it's been paused in the first real line of code. So the curly brace is uninteresting. The first line is just the function's name, essentially. So line 8 is the first juicy line of code that could possibly do anything useful. It's been highlighted here in yellow, and the fact that this cursor is here means that we have broken execution on this line, but we have not yet executed this line, which is why in the terminal, I don't see anything yet. I definitely don't see height followed by colon. Notice what else has happened here. All of a sudden, on the left-hand side of the screen, where your File Explorer typically is, or where the CS50 duck typically is, we see mention of variables. You can actually see inside of the debugger what the value of any variable in the computer's memory happens to be. Now, I don't quite understand this right now. We'll come back to this over time. But weirdly, before line 8 even executes, it seems that H has a default value of 32,764, which seems to have come from nowhere. As an aside, this is going to be what's called a garbage value. And this is actually why we have Oscar so omnipresently here. A garbage value tends to be a default value inside of a variable that's the result of that memory having been used previously for something else. Inside of your computer, you've got all of this memory, random access memory, or RAM, more on that today, and it stands to reason that my computer, or whatever cloud server we're using, has been running for some time, so the bits that H is going to use might already have some random switches on and off, some random pattern of bits that happens to give me 32,764. But the moment this line of code executes, that value is going to get changed to what I actually want it to be, which is what the human is going to type in. Meanwhile, at the bottom here, you'll see a so-called call stack. More on this too in the weeks to come, but you'll see that we've paused on the function called main in the file called buggy.c. So how do I do something useful? Well, at the very top of the debugger, you'll see a whole bunch of color-coded icons. One looks like a play button, and if I click that, it's just going to continue execution of my code as though I don't want to step through it anymore. So I'm not going to click that just yet. The second arrow, which is a little curved arrow over a dot, is the so-called step over line, which will mean step over this line and execute it, but only one line at a time. Let's go ahead and do exactly that. So I'm going to click the step over icon, the second one, which is the curved arrow with the dot under it. Click. Now I see in my terminal window height being prompted. All right, let's go ahead and type in 3, just like I did before, and hit enter. Now notice what happens. Execution has paused on line 9 instead of 8, and you'll see that my variable, a so-called local variable, has the value of 3 as intended. All right, so far this isn't all that enlightening other than demonstrative of the fact that I can pause execution of my program anytime I want. So let's now click that step over button again so that we actually print this column. Click, and there we have it, 4 hashes at the bottom of the screen. Now execution is paused at the end of the function. This is just my opportunity to either stop or restart or continue. I'm just going to go ahead and click the play button and let it finish executing. Unfortunately, that wasn't really at all enlightening, except to confirm for me that I typed in 3, and 3 is what is in the computer's memory. Not that interesting, though, yet. So let's do this. Let's leave the breakpoint on line 6 as before. Let's rerun the debugger by running debug50 space /buggy. Let's let it do its startup thing, which looks a little messy at first, but now we've highlighted line 8 again. I'm going to go ahead and step over this line because I do want to get an int. I'm going to type in 3 again, enter. But this time, instead of stepping over line 9 and just letting print column happen, this is where the debugger gets powerful. Let me step into line 9 and walk through the print column function itself line by line. So let me go ahead and click not this button, which is the curved arrow over the dot, but the next one, which is the step into button. Click. And now you'll see that execution has jumped inside of print column and paused on line 14, at which point I can see at top left what the default value of I is. And this is some crazy garbage value because whatever bits are being used to store I's value have some random garbage from some previous use of that memory. But as soon as line 14 executes once, I bet I is going to take on a value of 0. So let's do that. I'm going to go ahead and click step over, because I don't need to step into this because there's no other functions there. Step over it, and immediately at top left, I is now 0. Now, line 16 is highlighted. Let's step over this. Okay, and notice in the terminal window, what do you see? The first of our hashes. Let's step over, second hash, and I is now 1. Step over, now we see a third hash, and I is now 2. Step over, okay, there's the symptom of the bug. 4 hashes, and yet I is 3, but wait a minute, this is going to draw my attention now to line 14 before I continue onward. Wait a minute, 3 is of course less than or equal to 3, which is why I got that 4th hash on the screen. So at the end of the day, like, you still need to exercise some of your own human intellect to figure out and understand what's going on, but the value of this here debugger is that you can pause and work through things at your own pace and poke around inside of your own code and better understand what's happening, as opposed to compiling the program, running it, and just now having to infer from the symptoms alone what the source of the problem might be. So that was a lot. Let me go ahead here and just let it continue to the end, because I know what the problem is now. I need to change the less than or equal to sign to a simple less than instead. Questions, though, on debug 50 or any of these steps? Yeah. Sure.
Now I gotta go back over this.
Debugger,
This is,
and so we automated the process
a
of
lot.
starting the debugger, but everything thereafter has nothing to do with CS50 and everything to do with real-world software engineering techniques. So how do we use this? Let me go back to VS Code here, and let me propose that I want to step through this code line by line, just like we might at a whiteboard in a smaller class, to figure out why I'm getting 4 instead of 3 hashes. Well, in my terminal window, what I'm going to go ahead and do is this. debug50 space /buggy. So debug50 is the command. It needs to know what program I want to debug, so I'm specifying /buggy, which is the name of the program I just compiled. I'm going to get an error, though, the first time I run this, as will you if you make this same mistake. I'm about to see this message here. Looks like you haven't set any breakpoints. Set at least one breakpoint by clicking to the left of the line number and then rerun debug50. So what is this really telling me? Well, the debugger has no idea when and where I want to pause execution so as to start walking through my code line by line. It wants me to tell it where to break, that is, where to pause by clicking on a line number. So let me hide my terminal for just a moment, and you've probably never done this intentionally, but if you hover over the space to the left of your program's line number, you'll see a little red dot, a little stop sign of sorts. If you actually click on a line number, that red dot will stay there, and you can see the hover here saying click to add breakpoint. What I'm going to go ahead and do is say click to add a breakpoint at main. Main is the entry point to my program. It's the default function that gets called. Let's break right away so I can step through this code line by line. All right, let me reopen my terminal window and clear it, and then run debug50 again with /buggy enter. And now a whole bunch of stuff is going to happen quickly on the screen, and then it's going to clean itself up, because once the debugger is running and ready to go, it's going to allow me to start stepping through my code line by line. So what is going on? Well, notice nothing has happened in the terminal yet. Why? Because my code has been paused inside of main. In particular, it's been paused in the first real line of code. So the curly brace is uninteresting. The first line is just the function's name, essentially. So line 8 is the first juicy line of code that could possibly do anything useful. It's been highlighted here in yellow. And that the fact that this cursor is here means that we have broken execution on this line, but we have not yet executed this line, which is why in the terminal, I don't see anything yet. I definitely don't see height followed by colon. Notice what else has happened here. All of a sudden, in the left-hand side of the screen, where your File Explorer typically is, or where the CS50 duck typically is, we see mention of variables. You can actually see inside of the debugger what the value of any variable in the computer's memory happens to be. Now, I don't quite understand this right now. We'll come back to this over time. But weirdly, before line 8 even executes, it seems that H has a default value of 32,764, which seems to have come from nowhere. As an aside, this is going to be what's called a garbage value. And this is actually why we have Oscar so omnipresently here. A garbage value tends to be a default value inside of a variable. That's the result of that memory having been used previously for something else. Inside of your computer, you've got all of this memory, random access memory, or RAM, more on that today, and it stands to reason that my computer, or whatever cloud server we're using, has been running for some time, so the bits that H is going to use might already have some random switches on and off, some random pattern of bits that happens to give me 32,764. But the moment this line of code executes, that value is going to get changed to what I actually want it to be, which is what the human is going to type in. Meanwhile, at the bottom here, you'll see a so-called call stack. More on this, too, in the weeks to come. But you'll see that we've paused on the function called main in the file called buggy.c. So how do I do something useful? Well, at the very top of the debugger, you'll see a whole bunch of color-coded icons. One looks like a play button, and if I click that, it's just going to continue execution of my code as though I don't want to step through it anymore. So I'm not going to click that just yet. The second arrow, which is a little curved arrow over a dot, is the so-called step over line, which will mean step over this line and execute it, but only one line at a time. Let's go ahead and do exactly that. So I'm going to click the step over icon, the second one, which is the curved arrow with the dot under it. Click. Now I see in my terminal window height being prompted. All right, let's go ahead and type in 3, just like I did before, and hit enter. Now notice what happens. Execution has paused on line 9 instead of 8.
H has the value of 3.
You'll see that my variable, a so-called local variable, has the value of 3 as intended. All right, so far this isn't all that enlightening other than demonstrative of the fact that I can pause execution of my program anytime I want. So let's now click that step over button again so that we actually print this column. Click, and there we have it, 4 hashes at the bottom of the screen. Now execution is paused at the end of the function. This is just my opportunity to either stop or restart or continue. I'm just going to go ahead and click the play button and let it finish executing. Unfortunately, that wasn't really at all enlightening, except to confirm for me that I typed in 3, and 3 is what is in the computer's memory. Not that interesting, though, yet. So let's do this. Let's leave the breakpoint on line 6 as before. Let's rerun the debugger by running debug50.
Wait. I didn't have all 6s before, did he? Oh, whatever.
Space, /buggy. Let's let it do its startup thing, which looks a little messy at first, but now we've highlighted line 8 again. I'm going to go ahead and step over this line because I do want to get an int. I'm going to type in 3 again, enter. But this time, instead of stepping over line 9 and just letting print column happen, this is where the debugger gets powerful. Let me step into line 9 and walk through the print column function itself line by line. So let me go ahead and click not this button, which is the curved arrow over the dot, but the next one, which is the step into button. Click, and now you'll see that execution has jumped inside of print column and paused on line 14, at which point I can see at top left what the default value of I is. And this is some crazy garbage value because whatever bits are being used to store I's value have some random garbage from some previous use of that memory. But as soon as line 14 executes once, I bet I is going to take on a value of 0. So let's do that. I'm going to go ahead and click step over, because I don't need to step into this because there's no other functions there.
The
step
value
over
0.
it, and immediately at top left, I is now 0. Now line 16 is highlighted. Let's step over this. Okay, and notice in the terminal window, what do you see? The first of our hashes. Let's step over, second hash, and I is now 1. Step over, now we see a third hash, and I is now 2. Step over, okay, there's the symptom of the bug. 4 hashes, and yet I is 3, but wait a minute, this is going to draw my attention now to line 14 before I continue onward. Wait a minute, 3 is of course less than or equal to 3, which is why I got that 4th hash on the screen. So at the end of the day, like, you still need to exercise some of your own human intellect to figure out and understand what's going on, but the value of this here debugger is that you can pause and work through things at your own pace and poke around inside of your own code and better understand what's happening, as opposed to compiling the program, running it, and just now having to infer from the symptoms alone what the source of the problem might be. So that was a lot. Let me go ahead here and just let it continue to the end. I know what the problem is.
I got it.
I need to change the less than or equal to sign to a simple less than instead. Questions, though, on debug 50 or any of these steps? Yeah. Sure. Mm-hmm.
Can't hear a word she's saying.
Correct. So in order of your questions, what again are these breakpoints?
What's up,
the
GM?
breakpoint, or the little red stop sign here, just tells
Trying to
the
lock in
debugger
another full
where to
day.
pause execution. So frankly, I didn't have to pause execution at main. If I really care about debugging print column, I could have clicked down here instead, and then it would have just run main automatically and only paused once print column gets called. So a breakpoint is where your code will break, the point at which it will break. As for the garbage values, I'm oversimplifying exactly what's going on inside of the computer's memory, and it's not necessarily using exactly the same memory as before, but the operating system will govern exactly how the memory is laid out. This is actually a significant problem, long story short, in a lot of today's systems, because it's not that interesting to me to know that there was 32,000, whatever that number is, or the negative number, but suppose that that revealed the password of another program or function that had some information there. It seems all too easy with the debugger, let alone C, to actually poke around the computer's memory. And we're going to come back to that in a couple of weeks. But for now, it's a garbage value insofar as you didn't put the value there. It somehow got there on its own for now. Other questions?
Huh.
Pepper 807.
Pepper 8?
Pepper 807.
I don't know.
Pippi Pepper 87.
Correct. So the
eat a
question is about the
sandwich.
order of operations for a for loop. So the first time you go through a for loop, the initialization happens, the stuff before the first semicolon. And
What? What?
Pepper 87.
Pepper ate the sandwich?
Yes.
What sandwich?
They go come. Pepper 87. Pepper doggy 87.
my god, I just came back in here. Jesus. What? All right. Oh my god. Oh. Hey, sorry. I got a baby I have to keep up with too, so she yeah, keeps me busy.
The condition
She wanted a
is actually
sandwich.
checked, the
I don't
Boolean
even know if she'll
expression.
eat it, but
then
she
everything
wanted
inside
one.
of the curly braces is executed. Then the incrementation or update happens, which in this case is I++, and then the condition is again checked, the Boolean expression, the code is executed, the update happens, the condition again, the code is updated, and so it starts to loop like this. The debugger's graphics are fairly simplistic, and it just highlights the whole line without making super clear what's happening, but that's just the definition of a for loop.
A straight jalapeno, they're spicier than I
Others
thought.
about debug 50 or printf.
That spicy food helps wake you up, you know what I mean? I already drank some coffee, so.
Can you change the position of I++ and height? Short answer, no. The first thing is the initialization, the variable you want to create and initialize. The second thing is the actual condition, the so-called Boolean expression. The third thing is always the update. So it must come in this order. What you're not seeing is that you can actually have multiple Boolean expressions, you can have multiple initializations, you can have multiple updates, but we're keeping it simple for now.
Huh.
And this is canonical. All right, so to
Well,
make
see,
clear,
that's what I was trying to do
assuming
yesterday,
that
but I
either
couldn't.
printf or
Whatever.
debug 50
I
helped
guess
me
we'll get to
figure
that.
out where the illogic was in my thoughts. I now know that the fix here is to just go and change the less than or equal to a simple less than, and if I run the program again, of course, it's going to give me the 3 bricks that I always wanted instead. But there's other techniques we can use too. So besides printf and debug, you might wonder why we have a 7-foot duck behind me here, all of these little rubber ducks on the floor. So rubber duck debugging per week 0 is actually a thing.
Oh my
This was
god, I didn't
popularized
even notice the
some years
tiny
ago, and the
ducks.
idea
Holy
is that
crap.
When you are facing some bug, some mistake in your program, or you're just confused on some concept, there is anecdotal evidence to suggest that just talking out the problem with an inanimate object like a rubber duck on your desk is enough often for that proverbial light bulb to go off over your head.
All right, I got a
because you
Luffy.
hear in
I'll
your
talk to
own
Luffy.
words what confusion you're having, what illogical thoughts you're having, and you don't even need another human or TA or AI in the room to answer the problem for you. So in fact, on the way out today at the end of class, we've got hundreds of ducks and enough for everyone to take home with you if you'd like to use that as another debugging technique, whether in CS50 or something else. But of course, now in the age of AI, you also have the AI-powered virtual duck at CS50.ai.
This dude really likes Sesame
also
Street.
in VS Code at CS50.dev, which really is a mechanism for asking questions that you don't think you can solve on your own. So it might be reasonable to ask the duck, what does this error message mean if you're having trouble wrapping your mind around it? But it's less reasonable to say copy-paste your code into the duck and say, what's wrong with my code? You should really be meeting the AI halfway. After all, what's the point of actually doing this or any other class is to develop that muscle memory, develop those mental models, get some practical skills. So try hard to walk that line between asking the duck too much versus deploying some of these same tools yourself, printf, debug 50, even a physical rubber duck on your desk, before you resort to sort of escalating it to human-like or duck help. All right, so with those tools added to one's toolkit, let's actually consider and reveal what's been going on underneath the hood since last week. So this was the mental model we proposed for last week, whereby when you write source code in a language like C, it's not something that the computer itself understands natively, because computers we saw only understand zeros and ones, aka machine code. So the compiler is the program that we use to convert your source code to the machine's code, from C to zeros and one in this case. More generally, a compiler is just a program that translates one language to another. And in this case, we're
The
going
real
from source code
interpreter
to
is the
machine code.
compiler.
So let's consider what's really happening. And indeed, this is among the goals of this week, is to take a look at a lower level so that when you encounter more interesting, more challenging problems, you'll understand from so-called first principles what the computer is actually doing and supposed to do, so you can deductively figure things out for yourself and generally not view computers as like magic, or I don't know how this works, you'll have a fairly bottom-up sense of how everything works by term's end inside of any computer, laptop, desktop, phone, or the like these days. So here's the simplest of programs that we wrote last week, even though there's a lot of syntactic complexity, as we've seen. The goal is to get it to machine code, these here zeros and ones. So how has that been happening when you just run make since last week? Well, these are the two commands that we've typically run after creating a file like hello.c. We then compile it with make hello, and then we run it with /hello. So let's give ourselves this starting point real quick, just so that we have an example in mind of exactly what it is we're compiling. So let me go back to VS Code here, close out buggy.c, and let's create a new file just like last week called hello.c, inside of which is our old friend, standard.io.h, int main void, and then inside of this we'll keep it simple, just printing out hello, world, which again is my source code in C. How do I now actually compile that? Well, of course, I can go down to my terminal window, make hello, /hello, and we're off and running. So it was a bit of a white lie for me to let you think, though, that last week the compiler itself is called
create a code called what?
Machine code, these here zeros and ones. So example in mind of exactly what it is we're compiling. So let me go back to VS Code here, close out buggy.c, and let's create a new file just like last week called hello.c, inside of which is our old friend, standard.io.h, int main void, and then inside of this we'll keep it simple, just printing out hello, world, which again is my source code in C.
I just pulled up the old one.
How do I now actually compile that? Well, of course, I can go down to my terminal window, make hello, /hello, and we're off and running. So it was a bit of a white lie for me to let you think, though, that last week the compiler itself is called make. Make is a command that literally makes your program. It makes it by compiling it, but make is not technically the compiler. If we really want to get nitpicky, the compiler you've been using is actually called Clang for C language. And this is a very popular compiler, freely available, open source, so to speak. You can even look at the code other humans wrote to create the compiler online. And what make is really doing for us is essentially automating this command. So all this time, I could have just run clang space hello.c, but the default file name from Clang, the compiler, weirdly and for historical reasons, is not going to be hello, as you would hope. It's going to be a.out for assembler output. And we don't do this in in week 1 of the class. It's like, this just makes things unnecessarily complex that we're adding some random name that you just have to know to type. However, we can do this now as follows. Let me go back to VS Code here. Let me clear my terminal and type ls, and we'll see everything we've created thus far. Buggy.c, which when I compiled it, I got buggy, and hello.c, which I just wrote, and when I compiled it, I got hello. Let's do this command now manually, though. Let's use clang on hello.c and hit enter. That too seems to work, but if I now type ls, you'll see a third program specifically called a.out, which happens to be the same as hello. It just is using the default name instead of my custom name, hello. But if I do /a.out, indeed, that too will work. But the reason we don't do that, certainly in the first week of the course, is that things get a little annoying or sort of escalate quickly thereafter. So let me go ahead and change this program as we've done a few times already. Let me include CS50x so that we get access to like getString. Let me do string name equals getString, quote unquote, what's your name, question mark, close quote. And then down here, just like before, let me add my %s and add in my name. So I did that super quickly, but it's the same program we wrote a few minutes ago, and it's the same one we wrote last week. What happens now, though, is as follows. If I now try to do clang, hello.c, enter, I actually get an error message. This one perhaps more cryptic than most. Somehow or other, I have this error. Linker command failed with exit code 1 because of an undefined reference to getString. Now, in the past, when we've seen undefined or really undeclared mentions of getString, the problem was just with missing this line. This line is clearly here. But the catch is, I'm getting this error message now because when I run clang of hello.c, I'm just assuming that Clang knows where to find the CS50 version of getString, and that is not the case. Technically, if I want the compiler to compile this code for me, what I'm actually going to have to do is this. Let me go back to my terminal window here, and I'm going to say clang hello.c, but I'm then going to specify -LCS50, which is cryptic at first glance, but this is telling the compiler to link in the CS50 library so that it knows what the zeros and ones are that belong to the getString function. Long story short, if I hit enter now, the error message has gone away. If I type ls, I've still got a.out, but it's a new version thereof. And if I do /a.out, now I see the new behavior where I can type in my name and see hello, comma, David. Now, this is getting a little stupid that I keep using a.out. We can change that as well. In fact, these commands, as we're starting to see, support what are called command line arguments. And a lot of the programs we've run already take command line arguments. When we run code space hello.c, the so-called command line argument to code is hello.c. When I run make hello, the command line argument to make is hello. In other words, the command line arguments to a program are all of the words you're typing in your terminal after the name of the program itself, whether it's make or whether it's code or anything else. So this is to say, what I just ran clang of hello.c -LCS50, I was passing in two command line arguments, hello.c, which is the code I want to compile, and -LCS50, which means use the CS50 library, please. But I can add another to the mix. I can actually do something like this, whereby I do clang -o hello, then I can do hello.c, and then program are all of the hello.c -LCS50.
What? Clang hello.c. I did something wrong. Huh? Well, I must have missed a step or something.
Sort of escalate quickly thereafter. So let me go ahead and
Confused.
change this program as we've done
Oh,
a few times
that's it.
already. Let me include
No.
CS50.h so that we get access to like getString. Let me do string name equals getString, quote unquote, what's your name, question mark, close quote. And then down here, just like before, let me add my %s and add in my name. So I did that super quickly, but it's the same program we wrote a few minutes ago, and it's the same one we wrote last week. What happens now, though, is as follows. If I now try to do clang hello.c enter, I actually get an error message. This one, perhaps more cryptic than most. Somehow our
Did I even got the same thing? Clang. Nope. That's that. I got something else going on. What the heck? What is wrong with mine? Mine's the exact same, dude. What did I do different? Get string name, printf. What?
other, I have this error. Linker command fails with exit code 1 because of an
What is
undefined
it?
reference to getString. Now, in the past, when we've seen undefined or really undeclared mentions of getString, the problem was just with missing this line. This line is clearly here. But the catch is, I'm getting this error message now because when I run clang hello.c, I'm just assuming that Clang knows where to find the CS50
Dude,
version.
God dang it, what? What? Dude, I just made you a sandwich. What? Go, hurry. Hurry, what is it? Hurry. What is it? I don't understand why mine's not doing the same thing his is doing. It's saying I got an error though. It's a lot of punctuation. It's saying the whole thing's wrong. I don't know what the fuck. Oh my God, what did I just do?
Is this. Let me go back to my terminal window here, and I'm going to say clang hello.c but I'm then going to specify -L CS50, which is cryptic at first glance, but this is telling the compiler to link in the CS50 library so that it knows what the zeros and ones are that belong to the getString function. Long story short, if I hit enter now, the error message has gone away. If I type ls, I've still got a.out, but it's a new version thereof. And if I do /a.out, now I see the new behavior where I can type in my name and see hello, comma, David. Now, this is getting a little stupid that I keep using a.out. We can change that as well. In fact, these commands, as we're starting to see, support what are called command line arguments. And a lot of the programs we've run already take command line arguments. When we run code space hello.c, the so-called command line argument to code is hello.c. When I run make hello, the command line argument to make is hello. In other words, the command line arguments to a program are all of the words you're typing in your terminal after the name of the program itself, whether it's make or whether it's code or anything else. So this is to say, what I just ran clang of hello.c -lcs50, I was passing in two command line arguments, hello.c, which is the code I want to compile, and -lcs50, which means use the CS50 library, please. But I can add another to the mix. I can actually do something like this, whereby I do clang -o hello, then I can do hello.c, and then -lcs50 enter. Now that too seems to work, and if I type ls, well, I've got all the same programs as before, so let's go ahead and get rid of those to make clear what's going on. I'm going to remove a.out, I'm going to remove hello, and just for good measure, I'll remove buggy as well, so that all I have left in this folder is source code. So if I type ls, there's my two files. Let's do this again. Clang -o hello, hello.c -lcs50. Enter. Now if I type ls, I don't see a.out anymore, because apparently, according to the documentation for clang, the actual compiler, if you pass -o as a command line argument followed by another word of your choice, you can name the program anything you want without having to resort to MV or clicking on it and typing a new name in manually. So if I now do /hello, I see the exact same version where it's just asking me for my name and then printing it out. But long story short, the whole point of this exercise is that like running commands like this quickly gets very tedious. You have to remember like the order in which to do it, what the command line argument. I mean, this is just stupid waste of time. Typically, certainly in week 1 of the course, to have to memorize these kinds of magical commands to get things working. But for now, know that when you run make, it's essentially automating all of that for you and making it as simple semantically as make hello or make buggy. But what's really happening is the make command, because of the way we've configured CS50.dev for you, is doing all of this behind the scenes. And it's not that magical. This just means change the file name to hello when you compile it. This just means compile this code. And this just means use the CS50 library. Like, that's all. But that message about linking something in, there's something juicy going on there such that make is in fact helping us sort of solve a whole bunch of problems when we compile. And in fact, let me propose that if we take a step back and look at some of the actual code that we're compiling, let's consider like what we actually mean by compiling. Yes, it's the case that to compile your code means to go from source code to machine code, but technically there's a few more steps involved. Technically, when you compile your code, that's sort of become the industry term of art that really is referring to 4 separate processes, all of which are happening in succession automatically, but each of which is doing a different thing. So just once, let's walk through these several steps. So what is this pre-processing step? So consider this program here, which we wrote in brief last week. We've got include standard.io.h, which is there because we want to be able to use printf ultimately. We've then got a prototype for this meow function, and the meow function does this. All it does is print out, quote unquote, meow, followed by a new line, takes no input, returns no return values. The main function now has a for loop, iterates 3 times, each time calling the meow function. And we saw this already earlier today. This line of code here, the so-called prototype, is necessary because we need to tell the compiler that meow exists before we actually use it here, especially if I don't get around to implementing it until later. So this copy-paste of that first line of code, a so-called prototype, solved that problem. This is what the header files are essentially doing for us. Before I use printf down here, the compiler needs to know what it is, what its inputs are, what its outputs are. Turns out the prototype for printf is going to be in standard.io.h. And that's what that line of code has been doing for us all this time. In fact, let's take a simpler example that we keep using here, whereby I'm including CS50.h and standard.io.h. And I'm using the CS50 getString function to get someone's name and put it in a variable called name. And then I'm printing out hello, comma, such and such. What's going on now when I pre-process this file by running make, which in turn runs clang? Well, the compiler finds on the server's hard drive the file called cs50.h, goes inside, and essentially copies and pastes its contents into my own code. Meanwhile, such that we get the prototype there for getString. And we haven't seen this yet, but it stands to reason that all this time using printf, we've been passing in a prompt, like what's your name, and we've...
Whatever. It's mommy's phone. I don't know. Yeah. All right.
If I get a phone,
You want some shorts?
what?
You want shorts? Or pants?
Uncle!
What?
Uncle!
Yeah, it is cold. You feel it?
No!
What?
Uncle's fine!
No, it's too cold.
It!
Dude, you're gonna steal my chips. God.
That is
It's guacamole.
Buggy.
Try some.
Okay. Not too hot.
It's not hot.
What?
It's not hot.
It is?
It's not hot.
A buggy?
Yeah, try it.
Okay.
See if you like it.
Yeah. Mm.
Do you like it?
Uh-huh.
Okay. What are you doing?
been getting back a string. What's inside the parentheses, recall, is the input. What's before the function name is the output, the so-called return value. What about standard.io.h? It's in that file that printf's prototype is. So essentially what the compiler does when pre-processing this file is it finds standard.io.h somewhere on the server's hard drive, goes inside and copy and pastes those relevant lines of code into my code as well. It's to avoid me having to do all of that myself, find the file, copy, paste it, or manually type out the prototype. These preprocessor directives just automate all of that to you. So what this effectively has at the top of my code after the file has been pre-processed is all of those hash symbols followed by include are changed to contain the actual contents of those header files. Now the compiler knows what getString is all about and what printf is all about. That then is the pre-processing step. What does compiling technically mean? Compiling means taking that pre-processed code, which again looks a little something like this, and convert it into something called assembly code. And we won't spend much time in this class on assembly code, but this is how programmers used to write code. Before there was C, before there was Python and Java and all of these other modern languages, programmers were writing code like this. Before this existed, they were programming zeros and ones into the earliest of mainframe computers using punch cards and other technologies, like literally sheets of paper with holes in them. Not very fun, very tedious, so the world invented this. Also not very fun, very tedious, so the world invented C. Not that much fun, so the world invented Python and so forth. We continue to sort of evolve as a species with code. But the compiler technically takes your preprocessed source code and converts it into something that looks like this, cryptic, and that's to be expected, but there are some familiar phrases. There's mention of main, there's mention of getString, there's mention of printf, and there's a bunch of other things. Move and push and XOR and call and these other commands here. These are the assembly instructions. Those are the lowest level instructions that the CPU inside of a computer understands. CPU is the central processing unit, the thing by Intel or AMD or Apple or other companies. Those are the lowest level commands that the actual hardware inside of the computer understand. It's just nice to be able to write words like main and for and printf than it would be to run these much more arcane commands that you'd have to look up in a manual. So compiling just takes C code and makes it a lower level type of code called assembly. When I said a.out means assembler output, that's why. Inside of that file is essentially the output of an assembler. All right, we're almost there. What does it mean to assemble a program, which is step 3 of the compilation process? That means converting assembly code to the actual zeros and ones we keep talking about.
Okay,
so
hold on,
the file is called help is all about,
I was getting
and
distracted.
what printf is all about. That then is the pre-processing step.
Okay.
What does compiling technically mean? Compiling means taking that pre-processed code, which again looks a little something like this, and convert it into something called assembly code. And we won't spend much time in this class on assembly code, but this is how programmers used to write code. Before there was C, before there was Python and Java and all of these other modern languages,
No way.
programmers were writing code like this. Before this existed, they were programming zeros and ones into the earliest of mainframe computers using punch cards and other technologies, like literally sheets of paper with holes in them. Not very fun, very tedious, so the world invented this. Also not very fun, very tedious, so the world invented C. Not that much fun, so the world invented Python and so forth. We continue to sort of evolve as a species with code. But the compiler technically takes your preprocessed.
Okay, see, I figured, you know, at one point in time they probably had to do something along the lines of making ones and zeros, but I wasn't expecting that to be what it used to look like. That is a lot. Oh my God.
Source code and converts it into something that looks like this, cryptic, and that's to be expected, but there are some familiar phrases. There's mention of main, there's mention of getString, there's mention of printf, and there's a bunch of other things. Move and push and XOR and call and these other commands here. These are the assembly instructions. Those are the lowest level instructions that the CPU inside of a computer understands. CPU is the central processing unit, the thing by Intel or AMD or Apple or other companies. Those are the lowest level commands that the actual hardware inside of the computer understand. It's just nice to be able to write words like main and for and printf than it would be to run these much more arcane commands that you'd have to look up in a manual. So compiling just takes C code and makes it a lower level type of code called assembly. When I said a.out means assembler output, that's why. Inside of that file is essentially the output of an assembler. All right, we're almost there. What does it mean to assemble a program, which is step 3 of the compilation process? That means converting assembly code to the actual zeros and ones we keep talking about. So if the file is called hello.c, when that file is assembled, the assembly code becomes the zeros and ones for your code in hello.c. But your code is not everything that composes your final program. Your code from hello.c has to be combined with code from CS50's library, from the standard I/O library that other humans wrote. I and the team wrote the CS50 code. Other humans in the world wrote the printf code in standard I/O. So essentially, the fourth and final step is to link all of those zeros and ones together.
Bro.
Somewhere on...
So it's, okay, the pre-processing, that was pretty, like, it's just pulling this information, this part you're putting at the top. Compiling, you put it down to the first stuff people were typing in with letters, and then it sends it into assembly, which sends it into zeros and ones. I thought this went straight to zeros and ones. I didn't even know there was a middle step right here. I don't even know what this linking part's about to be.
On the server, there is not just the header file, cs50.h and standardIO.h, but your code, hello.c, our code, cs50.c, and the code that contains printf's own implementation. Bit of a white lie, it's technically not called standardIO.c, but the point remains ultimately the same. So these files have already been compiled for you in advance. This is your code. What the assembly process does is it combines all of that into zeros and ones, and then all 3 chunks of zeros and ones are linked together. So if you think back to when I tried compiling the code without -lcs50, there was some mention of linker. Linking just means the computer did not know how to link your code with CS50's code because we were missing -lcs50, which tells the compiler to go find it somewhere on the hard drive. And the final step then of linking is to combine all of those zeros and ones into one bigger blob of zeros and ones, and that's what's inside your hello program that you can execute. So long story short, these 4 steps are what's been happening ever since the start of last week. Pre-processing, compiling, assembly, and linking. But thankfully, the world of programmers generally just treats all 4 of these steps as what we know now as compiling. It's just a lot easier to say compile and not worry about those lower level details. But that might reveal better to you what all of these error messages mean when you see hints of this kind of terminology. Questions on any and all of that? From here on out, we're going to go higher level than lower. Yeah?
No,
Mm-hmm.
I can't see. What was this?
Pretty crazy.
No.
Really good question. How does the computer know which of those zeros and
Put the
ones
captions on,
corresponds
why couldn't I hear 'em?
to data? Thankfully, from here on out, we're going to go higher level than lower. Yeah?
No.
Mm-hmm.
No.
Really good question. How does the computer know which of those zeros and ones corresponds to data, like numbers or strings of text or actual commands? We're going to come back to that in week 4 of the class.
Yeah,
Long
for real,
story
that's what
short,
I was
what
wondering.
we just saw on the screen is a big blob of
Jesus.
zeros and ones. Actually follow some pattern where the bits up top represent a certain functionality, the bits on the bottom represent something else, and they're organized into patterns. So long story short, we'll come back to that, but they follow conventions. It's not just a hot mess of
Okay.
like zeros and ones. Other questions? Correct. The pre-processing step goes into the header file and essentially copies and pastes the contents of it into your own code so you don't have to waste time doing that manually yourself. Other questions? Mm-hmm. No. So when you compile your code, you're going from the assembly code to the zeros and ones. When you compile, let me pull up the.
Yeah,
the
I said
chart
it
again.
backwards.
When you compile your code, you're going from the C code to the assembly code.
Yeah.
And the patterns you get when you see the assembly code are specific to a certain CPU. So long story short, if you're designing software for iPhones or for Android devices or Macs or PCs, you're going to necessarily use a different compiler because given the same C code, you will get different assembly instructions. in the
Ooh,
output.
I didn't
and
know
this
that.
is why you can't
Okay.
just take, back in the day, like a CD containing a program from a Mac and run it on a PC or vice versa because it's the wrong patterns of instructions. But
That's
the
what
reason
the
why we have
format-
all these annoying
that's why the
layers
format matters.
of complexity is because 4 different people can now implement the notion of compiling. Someone can implement the preprocessor, someone can implement the compiler, the assembler, the linker, and you can actually collaborate by breaking things down into these quantized steps. But also, you can do this step, and then 2 different people can write compilers to actually write, to output assembly code for like iPhones over here and Android devices over here, but all of us can still enjoy using the same
Okay.
language up here. So there's a lot of reasons for this complexity. Just understanding it is useful, but you're not going to need to use this sort of knowledge day to day. But it's what enables so much
What?
of today's complexity nonetheless.
It's charging.
All right, so
dude.
a bit of a flourish now as to what we've been doing with compiling. Well,
Jeez.
compiling is going ultimately from source code to machine code. Couldn't you just kind of reverse the process, right? If someone wrote really interesting software like Microsoft Word or Excel or something like that, well, when I buy it or download it, like I literally have a copy of all of those zeros and ones, couldn't I just kind of reverse this process and reverse engineer someone else's code by decompiling it? And this is genuinely a threat, and this comes up in matters of law and intellectual property because the zeros and ones have to be accessible to you and to your computer. So it's not a great feeling if someone with enough time and enough savvy could sort of reinvent Microsoft Word by just figuring out what all those zeros and ones mean. However, it's sort of easier said than done to reverse engineer code from these zeros and ones. For instance, this pattern of bits.
It's charging. It has to charge. It takes time. It has to charge. It has to charge. Look. It has to charge. There. Jesus. You're so impatient. This pattern of bits on the screen.
On the screen here did what did we say last week? silly question. No normal person should be able to answer this, but I did say
Said
it
hello
before.
world or something? I can't
These zeros and
remember.
ones print what?
I remember him showing that.
It just prints out hello world.
That's
I
what I
cannot
thought, yeah.
glance at that and figure it out like off the top of my head, but if I know what architecture, what CPU this code has been compiled into, and I pay attention in week 4 and know what the various layout of the zeros and ones are, I could painstakingly...
Oh, for the love of God, what?
This.
What?
This.
We're taking pictures.
This.
What do you want?
What push your part?
What?
The part.
I don't know what you want.
Let's see.
Figure out what each of those patterns of zeros and 1 means by breaking them into chunks of 8 or 16 or 32 or 64, which are common units of measure that I alluded to last week. Now, that's going to take a crazy amount of time, and the sort of presumption is that if you are smart enough and capable enough and have enough free time to do that, it would probably take you less time to just implement Microsoft Word the normal way and just rebuild the software. It's going to take you more time to go in reverse than it would in the so-called forward direction. But there's other subtleties as well. Inside of this code is not only commands like...
Well, actually, isn't that what people do when they make emulators and bring back old games like the original way? Don't they have to decompile it, I think? I don't know how that... 100% how that works, but I feel like that's how that works. I don't know.
Printf functions like printf, but
I
suppose
guess
that it
they gotta
contained a loop,
recreate it,
for
I don't
instance, to
know.
print meow, meow, meow. Well, we know already that you can use a for loop sometimes, or you can use a while loop, but they're functionally equivalent. It's sort of a stylistic decision which one you use, whichever one you're more comfortable with, or maybe feels a little better designed. But you can't figure out from the zeros and ones whether or not it was a while loop or a for loop, because it just results in the same pattern of zeros and ones. It's just a programmer's choice, which is to say you can't even perfectly reverse engineer everything, because it's not going to be obvious from the zeros and ones what the source code originally looked like. But again, the bigger deal breaker is if you have that much time and energy and savvy, just like re-implement Microsoft Word itself, don't try to reverse the whole process, which is going to be much more painstaking and time-consuming instead. Now, this is not true for all languages, and just as a teaser, in a few weeks' time when we talk about web programming and another language called JavaScript, it turns out that JavaScript source code is actually sent from web servers to web browsers, and you can look at the source code of any website on the internet, harvard.edu, facebook.com, gmail.com, it's going to be there. So not all languages, it turns out, are even compiled typically. Sometimes the source code is just executed by the underlying computer. So we're just scratching the surface of some of the implications of all this. In a little bit time, let's take a look further under the hood at the actual memory, solve some other problems, but I think it's now time for Cheez-It. So let's go ahead and take a 10-minute break. Snacks are now served. See you in 10.
He said Cheez-Its. Oh my
All
God.
right, we are back, and up until now, when we've been writing code, recall that we have to specify like what type of value you want to put in a variable. Like that's why I had to go in and add string before the word name in my first bug today. But it turns out C, as we've kind of seen already, has a whole bunch of these data types. I rattled these off last week: bool, int, long, float, double, char, string. But we'll consider for a moment just how much space each of these things takes up, and see if we can't help you see what the debugger was seeing earlier. That is, what is where in memory. So a bool, it turns out, actually takes up 1 byte, which is kind of stupid because technically a bool, true or false, really only needs 1 bit. It just turns out that it's more efficient and easier to just use a whole byte, 8 bits, even though 7 of them are effectively unused. So a bool will take up 1 byte, even though it's just true and false. An int, recall, uses 4 bytes, so if you want to count really high with an int, the highest you can go is roughly 4 billion, we've claimed, unless you want to represent negative numbers, in which case the highest is like 2 billion, because if you want to be able to count all the way down to negative 2 billion, you got to kind of split the difference. A long, meanwhile, is twice that.
Olivia.
Sunny day with 57 degrees right now. Today's high will be 70 and the low 46 degrees.
I'm trying to watch a video. You gotta be quiet. Okay. Okay. Well, it's too loud. It's too loud.
What is driving right here?
You got a lot to say.
No, it's okay.
8 bytes, which is roughly 9 quadrillion possibilities, which is quite a few more than 4 billion. That is if you want to include negative numbers as well. Then we had floats, which were real numbers with decimal points, which speak to just how precise you can be with significant digits. A float is 4 bytes by default, but a double gives you twice as many bits to.
So the real reason they create long and what is it, integer long, float and double, is it uses less memory. It uses less bytes. I think it's just to be efficient or something.
Play with, which lets you be more precise, even though at the end of the day, whether you're using floats or doubles, floating point imprecision, as we've seen, is a fundamental problem for scientific, financial, and other types of computing where precision is ever so important. A char, meanwhile, at least as we've seen it, is a single byte using ASCII characters specifically. And then string I'll put as a question mark because a string totally depends on its length. If you're storing hi, that's like 1, 2 bytes. If you're storing hello, that's like 5 bytes and so forth. So strings depend on how many characters you actually want to store inside of them. So where does this go? Well, here's a picture of a stick of memory, a DIM, so to speak, whereby on this
Olivia. I'm watching the video.
stick of memory, which is slid into your computer, your laptop, your desktop, or some other device, there's all these little black chips that essentially contain lots of room for zeros and ones. It's somehow electronic, but inside of there are all of the zeros and ones that we can store data in. So if we kind of zoom in on this, it stands to reason that, for the sake of discussion, if this one chip represents like 1 gigabyte, 1 billion bytes, it stands to reason that we could slap some addresses on these bytes, whereby we could say this is the first byte and this is the last byte. Or more precisely, this is byte 0, 1, 2, 3, dot, 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 byte 1 billion. And it doesn't matter if it's top, down, left, right, or any other order. We're just talking about this conceptually at the moment. So in fact, let's go ahead and draw this really as a grid of memory, a sort of canvas that we can just use to store types of data, like bools and ints and chars and floats and everything else. If we are going to use 1 byte to store like a char, well, you might use just these 8 bits up here, 1 byte up here. If you want to store an int, well, that's 4. You might use all 4 of these bytes necessarily contiguous. You can't just choose random bits all over the place. When you have a 4-byte value like an int, they're all going to be contiguous, back to back to back in memory like this. But if you've got a long or a double, you might use 8 bytes instead. So truly, when you store a value in memory, whether it's a little number or a big number, all you're doing is using some of the zeros and ones physically in the computer's hardware somewhere and letting it permute them, turn them on and off to represent that value you're trying to store. All right, so let's go ahead and abstract away from the hardware, though, and let's just start to think of this grid of memory sort of in zoomed-in form and consider more at a lower level what is actually being stored inside of here. For instance, suppose that we've got some code like this, containing 3 scores on like problem sets. You got a 72 on one of them, a 73 on another, and a 33 on the third. I've deliberately chosen our old friends, 72, 73, 33, which we'll call spell high,
Olivia.
or together in the...
Olivia. You can play with your phone, but you have to be quiet. Look, it's on. It's on.
Context of colors is like a shade of yellow, just so that we're not adding some new random numbers to the mix. These are our old friends, 3 integers. Well, let's use these in a program. Let me go over to VS Code here, and let me create with code a program called scores.c that's just going to let me quickly calculate my average score on my problem sets. I'm going to go ahead and include, as we often do, standard io.h at the top. I'm going to do int main void after that, and then inside of my curly braces, I'm going to do exactly those sample lines of code. My first score was, let's say, a 72. My second score was 73, and my third score was 30.
Olivia, stop. No, let it charge. Stop. Stop. No, you can't hold that. Stop it. Olivia, stop. No, ma'am. No, ma'am. It's charging. It's charging. You want it in your room? Dude, it doesn't have enough battery. It needs to charge. You need to let it charge. Come here.
So I've declared 3 variables, 1 for each of my problem set scores. Now let's calculate the average. So printf, quote unquote, average colon, just so I know what I'm printing. And now I'm going to go ahead and use...
Uh-oh. Oh. Two. Three.
Maybe percent I \n, and then what I'm going to pass in is a bit of math. So to compute an average, it's just score 1 plus score 2 plus score 3 divided by 3. And I put the scores, the numerator, in parentheses, just like in grade school. Like I need to do that operation first before doing the division. So just like math class. Semicolon at the end to finish my thought. Let's see how this goes. Make scores, enter, /scores, and it would seem that my average across these 3 problem sets is 72, which is great, but I don't think that's actually what I want here. What have I done wrong? It's unintentional. Yeah. Yeah, I'm kind of being a little generous with myself here. I didn't really factor in my worst score, so that was accidental. So now let me do this correctly. Make scores, /scores, and now, okay, my average is 59. But I beg to differ. I'd like to quibble. My score technically, I think mathematically, should really be 59 1/3. I'm kind of being cheated that third of a point. So what's going on here? Why am I only seeing 59 and not my full grade? Perfect, because I'm using integers. When I divide by 3, it's going to truncate everything after the decimal point, which we touched on at the very end of week 1, which is an issue with just truncation in general. So one approach to fix this, I could change my %i to %f, which is the format code, it turns out, for a float, and that is what I want to print. So let's see if that fix alone is enough. Make scores. Oops, it's not. I got ahead of myself there. Let me scroll up to the error. Format specifies double, but the argument has type int. Turns out you can use %f for doubles as well, so that's why I'm seeing double, even though I intended a float in this case. So there's a problem here. The argument has type int, even though I'm passing in %f. You're seeing mention of %d here, which is an alternative to %i. We typically encourage you to use %i because I for integer, but that is not the solution to this problem because I want my third of a point back. So how could I go about fixing this? Well, the fundamental problem here is that I'm trying to format an integer as a float or even as a double. Well, I need to convert these scores to floats instead. So I could go in and change this to float, this to float, this to float, and heck, just to be super precise, I could add a 0.0 on the end of each of them just to make super clear these are floats. But there's another way. I could, for instance, simply convert my denominator to 3.0, because it turns out, so long as you involve like one float in your math, the whole thing is going to get promoted, so to speak, to floating point values instead of integers. I don't have to convert all of them. So I think now if I do make scores, /scores now, there's my third of a the third of a point back. There's another way to do this, just as an aside, and we'll see this again down the line.
Whoa, 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 whoa. That didn't work for me. Hold up. Oh, okay. So you still have to put this as a float because it returns a float from here, but that will turn all the rest into float. So, okay, I got you. 59.3. Okay.
If you really want to stick with 3, because it's a little weird just semantically to divide by 3.0, like that's an implementation detail, but you're truly computing an average of 3 things, you can technically cast the 3 to a float. In parentheses, you can specify the data type that you want to convert another data type to, and this too should make the compiler happy. Aha, /scores, I get roughly the same answer. We're seeing some floating point imprecision though, nonetheless, but that too would achieve the goal here. But in short, that's all just a function of floating point arithmetic there. So what's going on now actually in the computer's memory? Let me revert back to the simpler one with just 0.0 there, and let me propose that we consider where these 3 things are in memory. Well, if we treat this as my grid or canvas of memory, who knows where they're going to end up, but for the sake of discussion, let's assume that 72 ended up in the top left of my computer's memory. I've drawn it to scale, so to speak, in that this score1 variable is clearly taking up 4 bytes of memory, and it's an int, and that's typically how many bytes are used on systems. Technically, it depends on the exact system you're using, but nowadays, it's pretty reasonable to assume that an integer will be 32 bits on most modern systems. Score2 is probably over there. Score3 is probably over there. So I'm using 12 bytes total, 4 bytes for each of these values. All right, so that's really all that's going on underneath the hood. I don't have to worry about this. The compiler essentially figured out for me where to put all of these things in memory. But what really is in memory? Well, technically, each of these variables, if it's composed of 32 bits, is really just a pattern of literally 32 zeros and ones. And I figured out the pattern here. I crammed them all into the space there. But you see here 3 patterns of 32 bits, which collectively compose those numbers there. But let's consider design now. In terms of my code, this gets the job done. It's not that bad or big of a deal for just calculating the average of 3 scores, but this should also start to rub you the wrong way this week onward when it comes to design. Like, this is correct, especially now that I clambered back my third of a point.
Is that what you're saying?
But this is bad design, using the variables in this way. Why, might you think?
You can put it in one line.
Yeah.
All right.
Yeah, I'm going to have to type in each score manually with each passing week when I get the 4th problem set and the 5th. I mean, surely people who came before us came up with a better way to solve this problem than like manually create 10 variables, 20 variables, whatever it is by the end of the semester. It just feels a little sloppy. And indeed, that's often the way to think about the quality of something's design. Think about the extreme. If you don't have 3 scores, but 30 or 300, is this really going to be the best way to do it? And if you feel like, no, there's got to be a better way, odds are there are, certainly if the language itself is well designed. So let's consider how else we might go about solving this. Well, it turns out we can treat our canvas of memory, that grid of bytes, into chunks of memory known as arrays. An array is a chunk of contiguous memory, back to back to back, whereby if you want to store 3 things, you ask the computer for a chunk of memory for 3 things. If you want 30, you ask for 1 chunk of size 30.
Go.
If you want even more, you ask for a chunk of size 300. Chunk is not a term of art. I'm just using it to colloquially explain what an array actually is. It's a chunk or a block of memory that is back to back to back to back. So what does this mean in practice? Well, it means that we can introduce a little bit of new syntax in C. If I want to create 1 variable instead of 3, and certainly 1 variable instead of 30, I can use syntax like this. Hey compiler, give me a variable called scores, plural, give me room for 3 integers therein. So it's a little bit of a weird syntax, but you specify the type of all of the values in the array. You specify the name of the array, scores in this case, and I pluralized it just semantically because it makes more sense than calling it score now. And then in square brackets, so to speak, you specify how many integers you want to put into that chunk of memory. So this 1 line of code now will essentially give me 12 bytes automatically, but they'll all be referable by the name scores, plural. So let's go ahead and weave this into some code as follows. Let me go back to VS Code here, clear my terminal, and now let's just whip up the same kind of program but get rid of these 3 independent variables. And instead, let's go ahead and just say int scores plural bracket 3. Now I need a way to initialize the 3 values, but this I can do too. It turns out that if I want to put 3 values in this, I just need slightly new syntax. I can say scores bracket 0 equals 72. Scores bracket 1 equals 73. Scores bracket 2 equals 33. So it's not all that different from having 3 variables, but now I technically have 1 variable, and I am indexing into it at different locations, location 0, 1, and 2. And it's 0 because we always, in computing, start counting from 0. So I do scores bracket 0 is going to be my 72 problem set. Scores bracket 1 is my 73 problem set, and scores bracket 2 was my weakest, my 33 piece set. Now my syntax down here has to change because there are no more score 1, score 2, score 3 variables, but there are scores bracket 0 plus scores bracket 1 plus, and notice what VS Code is trying to do for me. It's saving me some keystrokes. As I type in scores and type 1 single bracket, notice it finishes my thought for me and magically puts the cursor where I want it, so I can put the 2 right there and generally save on keystrokes. But that has nothing to do with C, it just has to do with VS Code trying to be now helpful. So I think now, if I go down here and do make scores, /scores, we get the same answer. But it's arguably better designed because I now have 1 variable instead of 3, let alone many more. And in fact, if I wanted to change the total number of scores, I can just change what's in that initial square bracket. So if we consider what's going on now, if we look at the computer's memory, it's the same exact layout, but there's no more 3 variable names. There's 1, scores bracket 0, scores bracket 1, and scores bracket 2. And notice here, ever more important, an array's values are indeed contiguous, back to back to back. Now, the screen is only so wide, so they kind of wrap around to the next row of bytes, but the computer has no notion of up, down, left, right. I mean, it's just a piece of hardware that's got lots of bytes available that can be addressed from the first byte all the way down to the last
That's
byte.
arrogant.
The wrap is
Okay,
just a
well, that
visual
was simple.
artifact on this here screen. All right, so
there
if
more
I've done
to it?
this now, maybe we can make this program a little more dynamic than just hard coding in my scores. Let me go in and add the CS50 header library so that we could also use, for instance, like getInt and start getting these scores dynamically. So I could do getInt, and I could prompt the user for
enter
a
scores.
score. I could use getInt again, and I can prompt the user for another pset score. I can use getInt a third time and prompt the user for a third such score. And then pretty much the rest of my code can stay the same. Let's do make scores again, /scores, 72, 73, 33, and now my program's a little more interactive. Like this doesn't work for just my 3 scores, it could work for anyone's scores in the class. Now this too hints of bad design. I like my introduction of the array, because I now have 1 variable instead of 3, but what now might rub you the wrong way among lines 7, 8, and 9?
Repeating.
Yeah. It's repetitive. I mean, I typed it manually, but I might
You
as well
probably
just
put it up
copied and
here.
pasted, like literally the same thing. So what's a candidate for fixing this? Like what programming construct might clean this
A
up?
loop?
Yeah, we could use a for loop or a while loop or whatever, but a for loop would get the job done, and that's often my go-to, so let's do that instead. Let's go under my declaration of the array and do for int I equals 0, I less than 3, I plus plus, which we keep seeing again and again. Now, how do I index into the array at the right location? Well, here's where the square brackets are kind of powerful. I can just say my scores array at the location I should get an int from the user as follows. So now I'm using getInt once inside of a loop, but because I keeps getting incremented, as we've done many a time now for meowing and other goals, I'm putting the first one at location 0. Why? Because I is initialized to 0. I'm putting the second one at location 1. Why? Because I'm going to plus or increment I on the next iteration, then the next iteration. So this has the ultimate effect of putting these 3 scores at location 0, 1, and 2, instead of me having to type all of that out manually. Now, I don't love how I've done this still. If we really want to nitpick, this solves the problem correctly, but it's kind of got a poor design decision still. It's got a magic number, as people say. What is the magic number here, and why is it bad? Yeah, over here.
0 through 3, it's too many.
Yeah,
right?
it was a little soft, but I think the number 3 is hard-coded in 2 places. We've got it on line 6, which is the size of the array, and then again on line 7, which is how many times I want to iterate. But those are the exact same concepts, but it's on the honor system that I typed the number 3 correctly both times. So I think we can fix this a little better. I could do something like int n equals 3, and then I could use n here, and then I could use n here, so that now I only change it in one place. If your eyes are wandering to the bottom of the program, there's still a problem here because I've still hard-coded 0, 1, and 2, but we'll come back to that. But this is arguably a little better. But let's talk a little bit about style. Typically, when you have typically when you've got a variable that should not change its value, we saw last week that we should declare it as constant. And the trick there is to literally just write const for short in front of the type of the variable. And now it should not be changeable by you, by a colleague, a collaborator, or the like. But typically, too, by convention, stylistically, to make visually clear to another programmer that this is a constant, it's convention also to capitalize constant. So to actually use like a capital N here in all places, just to make clear visually that there's something interesting about this variable.
It's
and
different.
It is a constant
different.
that cannot be changed. All right, with that refinement, I don't think we've really improved the program fundamentally. I think we're going to need to do a bit more work to do this really well. So I'm going to do this a little quickly, but mostly to make the point that we can make this indeed more dynamic. So let me hide my terminal window there. Let me go ahead now and get the scores as I already am as follows here. And let me go ahead and assume, for the sake of time, that we have a function that exists already called average, and I simply want to pass in to that average function the scores whose average I want to calculate. So average does not exist off the shelf. Like I can't just use an existing library for it. I'm going to have to implement this thing myself. But how? All right, well, let's go ahead and do this. At the top of my file, I'm going to go ahead and define a function called average that takes in what? An array of numbers. So this syntax is going to be a bit new, but the way I do this is int, say array, bracket, 0. Or array sounds a little too generic. Let's just call it numbers, for instance, here. So that says my average function is going to take as an argument an array of numbers. This average function, though, should return a value too. And it should return what type of value from what we've seen thus far? A number, a float specifically. It could be int, but then I'm going to get shortchanged my third of a point potentially. So I think I want it to return a float, or if you really want precision, you could return a double, just to be really nitpicky, but that seems excessive here.
Yeah, if you're calling it.
All right, well now inside of my average function, how can I calculate the average? Well, this is just kind of like a math thing. So I could declare a variable called sum and set it equal to 0. I could then have a for loop inside of this function for int I gets 0, I less than, I'm going to come back to this, the number of numbers in the array, and then I'm going to do I++, and then on each iteration, I'm going to do sum equals whatever the current sum is, plus whatever is in the numbers array at that location. So I'm going a little quickly, but again, I'm just applying the same lesson learned. Numbers is my array. Numbers bracket I means go to the ith location in there. But if my loop starts at 0, that means go to location 0, and then 1, and then 2. And heck, if there's more scores in this array, it's just going to keep going on up from there because of the plus plus. But I hesitated here for a couple of reasons. So I put a to-do here, which is not a thing. That's a note to self.
Yeah.
How far do I iterate? Well, if you've come into CS50 with programming before, you can usually just ask an array, aka a vector, what its length is in Java and in Python and the like. You can't do that in C. So if I want to know what the length is of this array, I've got to have the function tell me. So I'm going to additionally propose that this average function can't just take the array. It's also going to have to take another argument, a second input, for instance, called length, that tells me how long it is. And then down here, which is where we started the story, when I use this so-called average function, I'm going to have to tell the average function by passing in n how many numbers are in that array, just because. This is annoying that you have to pass in not only the array, but also its size separately. That's the way it's done in C. More recent languages have improved upon this, so you can just figure out what the length of the array is, as we'll see in a few weeks in Python. All right, back to the average function at hand. I think we're almost there. This is a little unnecessarily verbose. Recall that we can tighten this up by just doing plus equals whatever is in numbers bracket I. That's just tightening it up. It's syntactic sugar, so to speak. And then the last thing I'm going to do in my average function is what? Actually calculate the average. So what is the average? It's just the numerator, like the sum of all of the scores, divided by the total number of all of the scores. Well, I've got the sum, so I think I just want to do sum divided by what to get the actual average now?
By length?
Yeah.
Is that what it was?
Exactly. Sum divided by length will give me the average, because the sum is the numerator effectively, all of the scores added together, and the denominator is the length. How many numbers were there actually? Now I can't just write this math expression here. If this is going to be my function's return value, and we've done this once or twice before, I literally say in my average function, return this value. So it hands back the word. I could use printf and just print it on the screen, but I don't want that visual side effect. I want to hand it back so that on line 23, I can simply calculate the average of those n scores.
Well, you don't want this up here. You want this on the bottom.
As the value of that format code, %f. All right. Unfortunately, I think we are in reasonably good shape.
Except
Let me cross my fingers now and hope I didn't screw this up. Make scores. Okay. /scores. How many do we want to do? So we'll do 72, 73, 33. Enter. And there is, so close, average. I've had a regression. I've made the same mistake again, just in a different way. I think I saw your hand go up. Why am I getting 59 and I'm not getting my third of a point? Yeah. In this return line on line 11 right now, I'm again stupidly doing integer divided by integer. That will make us suffer from integer truncation, because if you're returning an integer, there's no room for the decimal point or any numbers thereafter. So how do we fix this? Well, I could change the sum to float. Like that would be reasonable. So then I do a float divided by the length.
Or you could put float
I could
in
do
here.
my casting trick, like convert the length to a float just for the sake of floating point arithmetic. There's a bunch of ways to solve this, but I think I'll go with this one now. Let me now do make scores again, /scores, 72, 73, 33, and now I've got, albeit with some imprecision, I think enough precision certainly for like a college grade in this case, 59.333 and so forth. Okay, so what are the things to actually care about here? So there's a decent amount of code here. Most of it is sort of stuff we've seen before, but the interesting parts I would propose are this. When you create your own function that takes an array as input, you have to take as input the length of the array. You're not going to be able to figure it out correctly, as in newer languages. You also need, of course, to pass in the array itself. How do you pass in an array? Well, when you're defining the function, you specify the type of values in the array, whatever you want to name the array inside of this function, and then you use empty square brackets like this. You don't have to put n or some other number there. All you need to tell the compiler is that my average function is going to take some array of values, specifically this many. You don't put it inside the square brackets there. Then when I use it, now it's just the now familiar syntax. When you want to index into your array, that is go to location 0 or 1 or 2, you just use square bracket notation here. But the array itself, recall, was actually created in main when I did this line of code here, where I said give me an array called scores, each of whose values is going to be an int, and I want this many of them. And so maybe the final flourish that I'll add here, just to be sort of nitpicky, is I keep saying that main should really go at the top. Fine, no big deal. Let me highlight my average function, move it to the bottom of my file just because, and then, and only then, I'll copy and paste that first line, the so-called prototype, so that Clang doesn't freak out by not knowing what the average function is. So in short, there's seemingly a bunch of complexity here, but the only thing that's really new in this one example is this is how you pass to a function an array that already exists elsewhere. Not by its name, but by with the square brackets there. Whew. Okay. Questions on arrays or any of this new syntax? Yeah. Okay. Mm-hmm. How does it know it's not a double? So by default, if you just type a number like 3.0 into your code, it will be assumed to be a double, just because raw values, literal numbers with a decimal point, will be treated by the compiler as doubles and be allocated 64 bits. Just because, like, the world did not need to create a new format code. Like %d is not double. %d is decimal integer, but don't worry about that. We tend not to talk about it too much in class. %i is integer, %f is float, but %f is also double. And this is not consistent because what's a long? percent LLI, what did I say last week? Percent LLI gives you a long integer. It's just a mess. There's no good reason for this other than historical baggage. Sure. I'm not
Historical
sure if that's
baggage.
reassuring,
That's
All right.
amazing.
So, okay, let's use this knowledge for like something useful now and actually tease apart what is how we can use these skills for good and to better understand what's going on inside of the computer as follows. Let me go over to our grid of memory, and this time let's not store some numbers, but let's store like these 3 lines of code, these 3 variables. So 3 chars, even though you know where this is going. Like this is not good design because I got 3 stupidly named variables, C1, C2, C3. But let's make a point first. The first variable's value is quote unquote H. Second is I.
Crap, I'm
Third,
being summoned. Oh my goodness. What? No more? No another peanut butter and jelly?
is exclamation point. Why though am I using single quotes suddenly instead of double quotes?
Because it's only one. It's a character, single
It's a character.
not a
Chars are single quotes, strings are double quotes, and we'll see the distinction why in a moment. So for instance, if this is my grid of memory and this program contains just 3 variables, each of them a char, odds are they'll end up like this in memory. C1, C2, C3, HI, exclamation point. Assuming there's nothing else going on in my program, they're just going to end up being back to back to back in this way, even though it might not in this way. So what does this really mean is going on? Well, let's go ahead and poke around. Let me go back to VS Code here. Let's close scores.c, reopen my terminal, and let's create a new program called hi.c and just do something playful. So let me include standardIO.h at the top. Let me do int main void after that. And inside of my curly braces, let's just repeat this. C1 equals h in caps, char C2 equals I in caps, and then char C3 equals exclamation point in exclamation point. That's all. Now, let's actually poke around and see what's inside the computer's memory. So I could do something like this. I could printf, for instance, %c, 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 \n, and %c, turns out, means character. So what do I want to plug in? C1, C2, and C3, semicolon. So let's go ahead and do this. Make hi, enter, /hi, and voila, there's my HI exclamation point. There's no magic here. Like I'm literally just printing out 3 char variables. I don't need the spaces. If I want to get rid of those spaces between the word, I can remake this, make hi, /hi, and now we're back in business. HI exclamation point. But here's where an understanding of types can give you a bit of power and sort of satiate some curiosity. What if I change my %c to %i, %i? So int. Well, turns out that a char is really just a number because it's an ASCII value from 0 to 255. So there's nothing stopping me from telling the compiler, don't print these as chars, print them as integers. So let's do make hi, /hi, enter. And that's a little cryptic. It looks like it's saying 727,333, but no, let me add those spaces back in between each of those placeholders. Make hi again, /hi. There are our old friends, 72, 73, 33. It is not necessary in this case to say int, because the compiler is smart enough and printf is smart enough that if you hand it a value that happens to be a char, it knows already it's going to be an integer essentially, so you don't even need to bother explicitly casting it this way. We're essentially implicitly casting it to an integer by using those format codes as such. All right, so that just proves that what I've claimed is the case, that there is this equivalence between characters and numbers, is actually the case inside of the computer's memory. So even though you're storing HI exclamation point, technically you're storing 3 patterns of 8 bits each that give you these decimal numbers, 72, 73, and 33, or specifically these patterns here. All right, then what is a string? And this is where things get a little more interesting. A string, as we've used it, is like a whole word or a phrase, or when we started class today, like a whole paragraph of text. So that's multiple values. Now, why is that interesting for us potentially? Well, let's go ahead and write one line of code as a string. So here, for instance, is one line of code with a string. Let's go ahead and put that into my program. So I'm going to go back to VS Code here and clear my terminal. And I'm going to go ahead and delete all of this code here for a moment. And I'm going to do something like this. String s equals quote unquote hi with double quotes now. And now, just like in week 1, I'm going to print out %s \n and print out the value of s. Per earlier, because string is technically one of our training wheels for just a few weeks, I'm going to additionally include CS50x at the top so that the compiler knows about what this word is, string. All right, let's go into the terminal, make hi, /hi, enter, and we're back in business, printing that out now as an entire string. Well, what's going on inside of the computer's memory this time? Well, I still have HI exclamation point, but it's a string now. Well, it turns out the way that's going to be laid out in the computer's memory is exactly like before. There's no mention of C1, C2, C3 because those variables don't exist. There's just one variable, s, but it's referring to 3 bytes of memory, it would seem, HI exclamation point. And you can kind of see where this is going. Like a string as a spoiler.
What? What is it? What? What? What is it? Oh, that was print string, but...
The way that's going to be laid out in the computer's memory knows about what this word is, string. All right, let's go into the terminal, make high, /high, enter, and we're back in business. Print.
Okay, what is it? What is it?
Time.
God dang. I want to get more water. I'm gonna throw my trash away. Olivia. You're making it difficult. What? You can play. Okay.
Printing that out now as an entire string. Well, what's going on inside of the computer's memory this time? Well, I still have HI exclamation point, but it's a string now. Well, it turns out the way that's going to be laid out in the computer's memory is exactly like before. There's no mention of C1, C2, C3 because those variables don't exist. There's just one variable, S, but it's referring to 3 bytes of memory, it would seem, HI exclamation point. And you can kind of see where this is going. Like a string, as a spoiler, turns out is actually just what?
Numbers.
It's
Integers.
just going to be an array of characters, hence the dots we're trying to connect today. So at the moment, though, this is a single variable, S, a string, the value of which is HI exclamation point. But you know what? If it is, in fact, an array, I bet we can start playing around with our new square bracket notation and see as much in our actual code. So in fact, let me go ahead and do this. In VS Code now, let's not use %S, let's use %C, %C, and %C 3 times. Then instead of just S, let's print it out like it is an array. S bracket 0, S bracket 1, S bracket 2.
Oh.
Let's go back to VS Code, my terminal in VS Code, make high, /high, and nothing has changed. But I'm printing it out now, one character at a time, because I understand what's going on underneath the hood in this case.
Oh, yeah.
I can actually see these values now. Let's go ahead and change
Oh,
the
yeah.
%C to %I, and add a space just so it's easier to read. %I space, %I
Integers.
space.
That's what you need.
I don't need my casts in parentheses because printf is smart enough to do this for me. Make high again, /high. There again is my 72, 73, 33. However, that came from the mere fact that I put in double quotes HI exclamation point. So what's really happening here is it seems that a string is indeed just an array of characters. But how does the computer know when doing %S know what to actually print? In other words, it stands to reason that eventually, if I've got more variables, more code, there's going to be other stuff in the computer's memory. Why does printf know when using %S to stop here and not just keep printing characters that are over here, especially if I did have more variables and more stuff in memory?
Because there's got to
Let's
be a
take
string
look
built
at
in.
what's just past the
Part
end
of
of
the
this array.
string
Let's go back to
function
VS Code, and now
included
let's
the
get a little
library or
crazy
whatever.
and add in a fourth %I. And even though this shouldn't exist, let's do S bracket 3, which even though it's the number 3, it's the fourth location, but HI exclamation point is only 3 values. So let's look one location past the end of this array. Make high, /high, interesting. It seems, and maybe it's just luck, good or bad,
0.
that the fourth byte in the computer's memory seems to be a 0. Well, that's actually very much by design. It turns out if we look a little further, by convention, what the compiler will do for us automatically is terminate, that is end, any string we put in double quotes with a pattern of 8 0 bits. More succinctly, it's just the number 0, because if you do out the math, where you've got 8 zeros, it gives you 0 in decimal. Or, more technically, the way it's typically written is this, because it's not like the number 0 that we want to see on the screen. /0, similar to /n, is sort of a special escape character. This just means literally 8 0 bits, not the number 0 that you might see in a phone number or something like that. So even though we said string S equals quote unquote high with an exclamation point, seemingly 3 characters, how many bytes does a string of length 3 actually seem to take up in memory? Actually going to be 4. And this happens automatically. That's what the double quotes are doing for you. They're telling the compiler, this is not just a single character, this is a sequence of characters. Please be sure to terminate it for me automatically with a special pattern of 8 0 bits. And that special pattern of 8 0 bits actually has a name. It's the so-called null character, or NUL for short. The null character is just a byte of 0 bits, and it represents the end of a string. We've actually seen it before, if super briefly, 2 weeks ago. Here was our ASCII chart, and we focused mostly on like this column here, and this column here, and then we looked at the exclamation point over here. But all this time over here, ASCII character 0 is null, NUL, which just means that's how you pronounce.
Oh, and these are all
8
those
0
characters
bits.
before. This is all that stuff that was in the old coding whenever it went to assembly or whatever. When it compiled down to assembly, these are all these codes. Holy crap. It's all making sense now.
It's been there this whole time. So why is it done this way? Well, how is the computer actually printing something out in memory? Well, it needs to know where to stop. Printf is pretty stupid. Odds are inside of printf there's just a loop that starts printing the first character, the next character, the next character, and it's looking for the end of the string. Why? Well, consider what might happen. Suppose you've got a program that has not just one string, but 2. For instance, 2 strings like this. So in fact, let me go back to VS Code here, clear my terminal, and let's just make this program a little more interesting for a moment. String T equals quote unquote by, for instance, and then down here let's do 2 printfs. %s \n and print out s. Printf %s \n print out t. Now to be clear, %s means string placeholder. T and s are just also the names of the variables. There's no %t that we want to use here. All right, let me go down to my terminal, make hi, /hi, and voila, I get hi and bye, just like you would have expected last week. But what's going on inside of the computer's memory? Well, insofar as I've asked it to create two variables, s and t, like this, odds are what's happening in the computer's memory is hi is ending up here, aka s, t, because there's nothing else in this program, is probably going to end up here, bye exclamation point, but it wraps on this particular screen. T is taking up 1, 2, 3, 4, 5 bytes total, just as hi is taking up 4 bytes total, because the compiler is automatically adding for me the \0, the null character, to make clear to other functions where this string ends. So, what does this mean in real terms, and why is it 0? Well, why is it 0? Like, just because. Like, at the end of the day, all we have is bits. We've got 8 bits to work with for chars. You got to pick some pattern. We could have chosen all 1s. We could have chosen all 0s. We could have chosen something arbitrary. A bunch of humans in a room years ago decided 8 zeros will mean the null character. That's the special character we will use to terminate strings in this way. Well, what does that mean with our...
Hello? Okay. Oh. Oh. Well, that's good, right? Oh, damn. Okay. Yeah. I mean, if you look on YouTube, you'll see. No, you weren't. You were the one sending the reactions or whatever. Yeah, I figured. Yeah. I go. I guess the biggest entertaining part is how distracting Olivia is.
I said hi.
You wanna say hi?
Yes. Hi. What do you read?
I love you.
What?
Is it Mama?
Mama says hurry.
Oh, yeah?
Now Mama has no fun with it.
You want me to come home?
No. Look, he play with it. Have Mommy will walk.
Play together.
Look, say mommy. Look, mommy. Mommy, say mama.
Olivia.
Mama.
She's telling
Olivia.
she's telling you to say mama, not mommy.
No. Hi. My.
Mama.
No.
Yes.
Hi.
Hi, baby.
It's done now. No, try to nail this.
Oh, you nailed it?
Yeah?
Oh, okay.
And the goal with my dad. My goal is my me. My goal. See.
Oh.
I can't see mine. This.
You're so smart.
This. Die. The dies. Guys. Test. my that. No, not mine.
Are you even singing with me?
No, not say mine. No,
Why?
because don't say mine.
Because why?
Because nobody goes.
Are you home?
No, I don't see the water tower yet, but I see the QT sign.
Oh, it sounded like a
The
door
water
shut.
tower's in distance. I haven't passed the I-30.
It sounded like you were shutting the door on your phone.
Close the little overhead thing. Oh, and Danica broke back.
That's
It definitely looks like that.
Oh, yeah. Yeah, it does.
There's no mistake in that one.
Yeah.
What?
Well, and the way she hides back all far away like that, I mean, it's, I don't want to say too much. I mean, I'm still on.
That part.
Yeah, that's.
All of that part.
Well,
Yep.
And we just take some of the things from before and some of the things now. We stack it all up. We're good.
Yeah.
Five.
Well, I've got about. I'm more than halfway through the lecture. I got an hour and 40 minutes in.
Alright, I'm gonna let you get back to it. I'm gonna come home and then I'm gonna pull the little one out of there and distract her for you.
Alright.
While I start my sleep.
Okay. Well, we can take turns or something. I don't know. Whatever. She entertains herself for a good little while, but then she eventually ends up coming back. Yeah. She already ate two. No, she ate cereal and she had 2 peanut butter sandwiches. She really liked. I think Pepper got to her second one though. She was eating. Yeah, well, she was eating it, and then she called me in there, and she's like, "Where'd my peanut butter jelly go?" While she was eating a piece, and then I see Pepper just sniffing around, so I'm like, I'm pretty sure Pepper got it.
If you moved it from the table, yeah.
Well,
It's down on the edge. So Pepper learned how to use the step-up ladder.
yeah.
So she can get up on the step-up ladder now.
Well.
She was like, oh, this makes people taller? I bet this makes dogs taller. So I look, now I can get on the table.
Mommy. Oh, mine.
That's dog.
I dropped that. Now me. Mine.
Alright.
Mommy.
Let me get off the phone. I'm gonna let you get back to it. I'm gonna come
Mommy.
in.
Alright.
Mommy.
Love you.
I love you too.
Bye.
Olivia,
I love you. Bye.
I love you. Bye.
Bye.
I know. Mama's gonna be here soon. She's on her way home.
Hey, gone.
Huh?
Hey, gone.
What? Gone?
Hey, gone.
I don't know.
Hey, guys.
All right, I gotta continue.
New syntax, well, it means we can poke around with strings as well. So even though
Yeah.
that first variable is s and that second one is t, you could technically poke around and access
That
s
took me an
bracket
extra
0,
hour to
1,
get
and
this
2,
far,
and 3,
Jesus.
t bracket 0, 1, 2, 3, and 4, and so forth. So in fact, if I wanted to dive in deeply there and actually see that, well, let me go ahead and do this. Back in VS Code here, let me make a refinement here. I've now got my 2 strings here. I could go and, for instance, down here, just like before, %C, 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 and if I then do S bracket 0, S bracket 1, S bracket 2, whoops, 2, and then down here T bracket 0, T bracket 1, T bracket 2, T bracket 3, and I'm doing that only because the word by is longer than the word high. If I do make high, /high, same principles work even in this context here. But let's add an interesting twist just because if I have these values in memory here as follows, well, it's if I've got two words in memory, I could use them in an array too. Instead of having like S and T or word 1 and word 2, I can actually put strings in an array too. So let's go ahead and do this. Let me go back to VS Code, and just for fun now, let's go ahead and do this. Give me an array called words that's going to fit 2 strings. Then in the first words bracket 0, put high. Then in words bracket 1, put by. The only thing new here is that I'm making an array of strings now instead of an array of ints, but all of the syntax is exactly the same. How can I go about printing these things? Well, just as before, I can do printf %s \n and print out words bracket 0. Then I can do printf quote unquote s \n words bracket 1. Again, I'm just sort of applying the same simple syntax that we saw before, /high, again, of the 6th version of this program, right? I'm just sort of jumping through syntactically to demonstrate that these are just different lenses through which to look at the exact same idea. And while a normal person would not do this, we could think about what's really going on in memory with arrays of words when those words themselves are arrays of characters. Because a word is just a string. So this code here gives us something like this in memory. In that program a moment ago, this is words bracket 0, this is words bracket 1. The only thing that's different is I'm not calling them S and T, I've given them one name with 2 locations, 0 and 1. Well, if each of these values is itself a string, well, you said earlier that a string is just an array, so we can actually think of these 2 strings, even though the syntax is getting a little crazy, using 2 sets of square bracket notation, where I can index into my array of words and then index into the individual letters of that word by just using more square brackets. And again, this is just to demonstrate a point, not because a normal person would do this, but if I go back to VS Code, instead of printing out these 2 strings, why don't I do something like this? Printf, quote unquote, %c, %c, %c \n. Then let's print out the first word, but the first character therein. Let's print out the first word, but the second character therein. The first word, but the third character therein. And even though I'm saying third and second and first, it's 2, 1, and 0 respectively, because we start counting at 0. And then lastly here, we can print out the second word, %c, 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 %c \n. Then words bracket, how do I get to the second word in this array? Words bracket 1, the first character they're in. Words bracket 1, the second character they're in. Words bracket 1, the third character they're in. Words bracket 1, the last character they're in. And again, this is just to demonstrate a point, but if I do make high now, /high, we have full control over everything that's going on. If you now do agree and understand that an array can be indexed into with square bracket notation, as can a string, because a string is itself.
What is it? Man, you're making this impossible. Jesus. That's amazing.
Look.
What? No, leave that alone.
Okay.
Leave it alone.
Okay.
Just an array. Strings are arrays for today's purposes then. Whew. Questions on
Strings
any
are
and all
arrays.
of these tricks?
Nana,
What?
what is that?
All right. Yeah, in front.
That's it. I mean, no, that.
Okay.
Whoa! What is that?
How do you establish or create an array? Well, in the context of this program, if I go back to VS Code, line 6 here gives me an array of size 2. An array of 2 strings, if you will. The previous example we were playing with, which was my scores, whoops, wrong program, wrong file. If I open up scores.c as before, this line here, line 9, gives me an array of n integers.
Don't they eat?
So that is what establishes or creates the array in memory. You specify a name, the size, and the type.
No, why?
That's all. And the only thing that's new today, again, is the square bracket notation, which in this context creates an array of that size, but once it exists, you can then access that chunk of memory by using square brackets as well. Other questions? Otherwise, yeah, in front. Good question. Do you need to go index by index to put things inside of an array? Short answer, no. So let me open up again scores.c from before. And what I could have done in an earlier version of my program would be something like this. I could have done 72, 73, 33, and I deliberately didn't show this because I didn't want to add too much complexity, but you can use curly braces in this new way and initialize the array in one line, and in that case you don't even need to specify the size because the compiler is not an idiot. It can figure out that if you've got 3 numbers on the right, it knows that it only needs 3 elements on the left to put them into. But let me undo that and leave it just as I did. But short answer, yes, you can statically initialize an array if you know all of the values up front and not when using getInt in that case. All right, so if you're on board with the idea that all a string is an array and that array is always null terminated, we can now use that knowledge to solve some simple problems and problems that others have already solved before us. So let me go ahead and close that file in VS Code. Let me go ahead and open up another program here called length.c, and let's just play around with the length of strings as follows. Let me include the CS50 library at the top. Let me include standard IO after that. Let me do int main void after that. And then inside of main, let's prompt the user for their name by using getString and just say name : today. And then after that, let's go ahead and figure out the length of the person's name. Like David, I should get the answer of 5. And Kelly, we should get the answer of 5. And hopefully for a longer or shorter name, we'll get the correct answer as well. So how can I go about counting the number of characters in a string? Well, the string is just an array, and that array ends with the null character.
Yeah,
There's a bunch of ways we can do this, but let me go ahead and do this. Let me create a variable called n, which eventually will contain the length of the name. And I'm going to set it equal to 0 because I don't know anything yet about the length. Then I can do this with a for loop, but I prefer this time to use a while loop. I'm going to say the following. While the person's name at that location does not equal \0, go ahead and add 1 to the value of n. And then after all of this, go ahead and print out with %i\n the value of n. So what's going on here? This is easier said when you know already where you want to go with it, but with practice.
I'm taking you. Can I take you? Yeah. Is he doing stuff? He is.
Yes.
So cool. Well, you want to watch a show with me? Want to play?
Yes.
Let's go play some Barbies. Want to play some Barbies? Play pretend?
It's crazy.
What do you want to play?
practice, you too can bang this out pretty quickly. N is going to contain the length of my string. I have in my loop here a Boolean expression that's just asking the question, does name at the current value of n not equal the null character? In other words, you're asking yourself, is this character null? Is this character null? Is this character null? Is this character null? And if not, you keep going. You keep going. And this is kind of a clever trick because I'm using n and incrementing it inside the loop. So when I look at d, that's not equal to \0, so I increment n. Now n is 1, so I look at name bracket 1. What's at name bracket 1 if it's my name? A. A does not equal \0, so it increments n. What's at location 2 in DAVID? V. V does not equal \n. So we repeat with I, we repeat with D, and then we get to the end of my name, which is the null character because the getString function and C put it there automatically for me. The null character does equal \0, n does not get incremented any more time. So at this point in the story on line 13, n is still 5 because I have not counted the null character. So I hope I will see 5 on the screen. This is just kind of a very mechanical way of checking, trying to figure out through inference how long the string is, because it's as long as it takes to get to that \0, the null character. So let's do make length, enter, /length, type in my name, David, and I indeed get 5. Let's go ahead and do /length, Kelly, I indeed get 5, and hopefully for shorter and longer names, I'm going to get the exact same thing too. In fact, we can try a corner case, /length, enter. Let's not give it a name at all. If I just hit enter here, what should the length of the person's name be? 0, which is not incorrect, it's literally true, but that's because we're going to get back essentially quote unquote, but even though it's quote unquote in the computer's memory, it's still going to take up 1 byte because the getString function will still put null at the end of the string, even if it's got no characters therein. So it turns out this is not something you need to do frequently, like initializing a variable, using a loop like this. It turns out there are better solutions to this problem. You do not need to reinvent this wheel yourself, because it turns out in addition to standard.io.h and CS50x, and as you probably saw in problem set 1, math.h, and perhaps others, there are other libraries out there, namely the string library itself. In fact, if you go into the CS50 manual, you can look up the documentation for a header file called string.h, which contains declarations for, that is prototypes for, a whole bunch of helpful functions. In fact, the manual pages for it are at this URL here. The most important function, and the one we're going to use so often for the next few weeks, is wonderfully called strlang for string length. Someone else, literally decades ago, wrote the code that essentially looks quite like this, but packaged it up in a function that you and I can use, so we don't have to jump through these stupid hoops just to count the length of a string. We can just ask the string length function what the length of a string is. But odds are, if we looked at the C code that someone wrote decades ago, it would look indeed quite like this. So how can I simplify this program? Well, I can get rid of all of this code here. I can include string.h at the top of my file, and then I quite simply could do something like this. Int length equals strlang of name. That's going to put in the variable length. Actually, let's be consistent. Int n equals strlength of name, and then on line 9, let's print it out. Let's try this. Make length, /length, David, okay, Kelly, okay, and no one, and 0. It seems to now be working. So this is a wheel we do not need to reinvent, and frankly, now in a matter of design, we don't really need the variable n anymore. Recall that we can nest our functions just like we did with average before, so let me get rid of that line and just say strlang of name is actually perfectly reasonable here. All right, well, what more can we do with this? Well, let's consider some other matters of design. Let me close out length.c and let's create another program of our own called string.
Hold up, I want to copy this. All right, name, and then Sterling. Is that how I put it? I don't remember.
Like we did with average before, so let me get rid of that line and just say strlang of name is actually perfectly reasonable here.
Oh.
All right, well, what?
Okay, so you don't put it here. You put it here. more sense. I should have figured that. Yep. Okay, and then main. Nope. Something didn't work right. That worked for me. Did I not spell it right?
More can we do with this? Well, let's consider some other matters of design. Let me close out length.c and let's create another program of our own called string.c, in which we'll play around now with this library and others. Let me go ahead and include CS50.h. Let me go ahead and include standardio.h. Let me go ahead and include also string.h. All right, what do I want to now do? Well, int main void, and inside of main, let's go ahead and write a program that prints a string character by character, just to demonstrate these mechanics. So string s equals get string, and I'm going to ask the user for some input, because I just want to play around with any old string. I'm going to go ahead and proactively say output here, and I'm going to go ahead and not use a new line character there deliberately. Below this now, I'm going to have a for loop, though I could use a while loop, that says int I equals 0, I is less than strlang of s, the string I just got from the human, and increment I on each iteration, and on each iteration, print out just one character in that string, specifically at s location I, and then at the very bottom of this program, let's just print a single \n to move the character onto a new line. Long story short, what have I done? I wrote a stupid little program that prompts the user for a string, prints the word output thereafter, and then just prints the word that they typed in character by character by character by character until it reaches the end of the string based on the length returned by strlang. So let's go ahead and run this. In my terminal window, I'm going to do make string /string, and I'll type in my own name as before. This was a subtlety. I deliberately wrote 2 spaces here because I just, to be nitpicky, I wanted input and output to line up perfectly so you can see what's happening. Indeed, if I do enter here, now I see input is David, the output is David as well. So that was just a formatting trick that I foresaw. Why is this program correct but not arguably well designed? It's pretty good in that it's using the strlang function. I didn't reinvent the wheel unnecessarily, but there's an inefficiency that's kind of subtle. And it relates to how a for loop works. Any thoughts? This program, I claim, is doing unnecessary work somewhere. Yeah. Okay, that's definitely stupid. You don't have to output it character by character. That's just my pedagogical decision here. So correct, but not the question we're fishing for. There's a second stupid thing. Yeah. Yes. Every time through this loop, and this isn't so much my conscious choice, but my mistake, I'm checking the length of s again and again. Why? Because recall how a for loop works. The initialization happens once at the very beginning. Then you check the Boolean expression. Then, if it's true, you do the code. Then you do the update. Then you check the Boolean expression. Then you do the code. Update, Boolean expression.
Whoa. This ain't working for me to start. Oh.
You do the code. But every time you evaluate this Boolean expression, you're asking, is I less than the str length of s? But this is a function call. Like, you are literally using strlang again and again and again. And like a crazy person, you're asking the computer, what's the length of s? What's the length of s? What's the length of s? It's not going to change. It's going to be the same no matter what. So how can we fix this? Well, I could solve this in a couple of ways. Like, I could, for instance, down here, do int n equals strlang of s, and store it in a variable n, and just do that. I think that eliminates the inefficiency, because now I calculate the length of s once, It's not going to change, nor is my variable, so I can now use and reuse that variable. It's just saving me a little bit of time, microseconds maybe, but when you're writing bigger programs and you're doing things in loops, if that loop is running not 3 times or 5, but 1,000,000 times, millions of times, all of those microseconds, milliseconds might very well add up. But it turns out there's some syntactic tricks we can do too. I alluded to this earlier. If you want to initialize not 1 variable, but 2, you can actually do it all before the first semicolon, like that. So now on line 9, I'm declaring a variable called I and setting it equal to 0, and I'm declaring a second variable called n, also the same type, int, and setting it equal to the length of s. And now I can use that again and again. Now, as an aside, this is a little bit of a white lie because smart compilers nowadays are so advanced that they will notice that you're calling Sterling again and again inside of a loop, and they will just fix this for you, unbeknownst to you. But it's representative of a class of problems that you should be able to spot with your own human eyes and avoid altogether so that you don't waste more time and more compute and more money in some sense than you might otherwise need to in this case. Any questions on that there? Optimization, yeah. You do not say int again. The constraint is that you have to use the same data type for all of your initializations, so you better hope that you only want ints in this case. Otherwise, you got to pull it out and do what I did earlier. Good question. Others on this? Yeah. When does it account for spaces? A space is just ASCII character number 32. So there's nothing special about it. It's sort of invisible, but it is there. It is treated like any other character. There's no special accounting whatsoever. The null character, which is also invisible, is special because printf and Sterling know to look for the end of that variable, the end of that value as such. All right, let's try one other demonstration of some of these ideas here. Let me go into another file that we'll create called, how about uppercase.c. Let's write a super simple program that uppercases a string that the human types in and see how we can do this sort of good, better, and best. So I'm going to call this file uppercase.c. Inside of this file, let's use our now friends, include CS50x. Let's do include standard.io.h. Let's then include, lastly, how about string.h. And the goal here inside of main is going to be to get a string from the user. So string s equals get string, and we're going to ask the user for a before string, representing what it is they typed before we uppercase everything. Then I'm going to go ahead after that and print out, just as a placeholder, after, and 2 spaces, just to be nitpicky so that the text lines up vertically on the screen. Now I'm going to do the following. For int I equals 0, n equals Sterling of s, semicolon, I less than n, just like before, I plus plus. So I'm just kicking off a loop that's going to iterate over the string the human typed in. Now, if my goal in life is to change the user's input from lowercase, if indeed in lowercase, to uppercase, let's just express that literally. If the current character in the string, so s bracket I, is greater than or equal to quote unquote a, and s bracket I is less than or equal to quote unquote z, using single quotes, this is arguably a very clever way of expressing the question, is it lowercase? We know from our ASCII chart from week 0 that the ASCII chart has not only numbers representing all the uppercase letters, but also numbers representing all the lowercase letters. Lowercase a, for instance, is 97, and they are all contiguous thereafter. So we can actually treat, just like we did before, chars as ints and ints as chars, and sort of ask mathematical questions about these chars and say, is s bracket I between a and z inclusive? So if it is lowercase, and I'll add a comment here for clarity, if s bracket I is lowercase, what do we want to do? We want to force it to uppercase. So this is a little trick I can do as follows. Printf, the current character, but let's do some math on it. Let's change s bracket I by subtracting some value. Well, what might that value be? Well, recall from week 0, our ASCII chart here, and let's focus, for instance, on the lowercase letters here and the uppercase letters here. What's the distance between all 4 chars as ints and ints as chars, and sort of ask mathematical questions about these chars and say, is s bracket I between a and z inclusive? So if it is lowercase, and I'll add a comment here for clarity, if s bracket I is lowercase, what do we want to do? We want to force it to uppercase. So this is a little trick I can do as follows. Printf, the current character, but let's do some math on it. Let's change s bracket I by subtracting some value. Well, what might that value be? Well, recall from week 0, our ASCII chart here, quote z, using single quotes, users input from lowercase, if indeed in lowercase, to uppercase. Let's just express that literally. If the current character in the string, so s bracket I, is greater than or equal to quote unquote a, and s bracket I is less than or equal to quote unquote z, using single quotes, this is arguably a very clever way of expressing the question, is it lowercase? We know from our ASCII chart from week 0 that the ASCII chart has not only numbers representing all the uppercase letters, but also numbers representing all the lowercase letters. Lowercase a, for instance, is 97, and they're all contiguous thereafter. So we can actually treat, just like we did before, chars as ints and ints as chars, and sort of ask mathematical questions about these chars, and say, is s bracket I between a and z inclusive? So if it is lowercase, and I'll add a comment here for clarity, if s bracket I is lowercase, what do we want to do? We want to force it to uppercase. So this is a little trick I can do as follows. Printf, the current character, but let's do some math on it. Let's change s bracket I by subtracting some value. Well, what might that value be? Well, recall from week 0, our ASCII chart here, and let's focus, for instance, on the lowercase letter, force it to uppercase. So this is a little trick I can do as follows. Printf, the current character, but let's do some math on it. Let's change s bracket I by subtracting some value. Well, what might that value be? Well, recall from week 0, our ASCII chart here, and let's focus, for instance, on the lowercase letters here and the uppercase letters here. What's the distance between all upper and lowercase letters? It's 32, right? And the lowercase letters are bigger, so it stands to reason if I just subtract 32 from the lowercase letter, it's going to immediately get me to the uppercase version thereof. So this is kind of cool. So I can actually go back to VS Code, and I can literally subtract the number 32 in this case, because ASCII is a standard, it's not going to change. Else, if the letter is not lowercase, I'm just going to go ahead and print it out unchanged without doing any mathematics at all to it. And I'll make clear with a comment, else if not lowercase. Makes clear what's going on there. All right, let me go ahead and make uppercase in my terminal window, /uppercase. Let's type in my name all lowercase, and I get back David. Oh, minor bug, a couple bugs actually. Let me fix my spacing. I think I want another space after the word after, and at the very bottom of my program, I think I want a \n. Now, let's rerun make on uppercase, /uppercase, enter, DAVID, and now it's forcing it all to uppercase. Meanwhile, if I do it once more and type in name capitalized, it's still going to force everything else to uppercase. Questions? Oh, I'm an idiot. Okay, thank you.
Oh, dang it. Oh, you know, I don't want it like that. Hold on. I want it like this. There we go. That looks better.
Yes, I misspelled after. Otherwise, my alignment would have worked. So let's do this again. Make uppercase, if only so that we can prove it's the same. DAVID in all lowercase, and there we go. That was, thank you, the intent. All right, so it's kind of a little trick, but this is kind of tedious, right? Like Microsoft Word, Google Docs all have the ability to toggle case from uppercase to lowercase or lowercase to uppercase. It's kind of annoying that you have to write this much code to achieve something so simple, seemingly, and so commonplace. Well, it turns out there's a better approach here, too. In addition to there being the string library, there's also the ctype library. In ctype.h, another header file, there's a whole bunch of other functions that are useful that relate to characters in ASCII. So for instance, if we go ahead and use this as follows, I'm going to go ahead at the top of my file here and include now ctype.h. It turns out there's going to be functions via which I can actually ask these questions myself. For instance, in this next version of the program, I don't need to do any of this clever but pretty verbose math. I can just say if the isLower function, which comes from the ctype library, passing in s bracket I, returns true, will then convert the letter to uppercase by subtracting 32. But you know, I don't even need to do this mental math or math in code. I can also, from the ctype library, use a function called toUpper, which takes as input a character like s bracket I and let someone else's function do the work for me. So let me go back down to my terminal window here. Let me make uppercase now, /uppercase enter before DAVID. This now works too. But if I really dig into the documentation for the ctype library, you'll see that you can just use the isLower function on any character, and it will very intelligently only uppercase it if it is actually lowercase. So someone else years ago wrote the conditional code that checks if it's between little a and little z. So knowing this, and you would see that indeed in the documentation, I don't even need this else. I can instead just get rid of this whole conditional, tighten my code up significantly here, and simply say printf using %c the toUpper version of that same letter, and let the function itself realize if it's uppercase, pass it through unchanged. If it's lowercase, change it first. And then return it. So now if I open my terminal window again and clear it, make uppercase, /uppercase enter, DAVID, and we're back in business. So again, demonstrative of how if you find that coding is becoming tedious or you're solving a problem that like surely someone else has solved, odds are there is in fact a library function for it, whether it's from CS50 or it's from the standard library, that you yourselves can use. And unlike the CS50 library, which is indeed CS50 specific, which is why Clang needed to know about -L CS50, many of these libraries just automatically work. You don't need to link in the C-type library. You don't need to link in other libraries. But non-standard libraries like CS50's training wheels for the first few weeks, we do need to do that. But make is configured to do all of that automatically for you. All right. In our final minutes together, let's go ahead now and reveal some of the details we've been sweeping under the rug about main. I asked on week 1 that you sort of take on faith that you got to do the void, you got to do the int, you got to do the void, and all of that. Well, let's see why that actually is. So main is special insofar as in C, it is the function that will be called automatically after you've compiled and then run your code, just because. Not all languages standardize the name of the function, but C and C++ and Java and certain other ones do in this case. Here is the most canonical, simple form of main. We know that including standard.io.h just gives us access to the prototypes for functions like printf, but what's going on with int and what's going on with void? Well, void in parentheses here just means that main, and in turn, all of the programs we've written up until this moment, do not take command line arguments. Literally every program we've written, /a.out, /hello, /scores, /everything else, I have never once typed another word after the name of our programs that we've written in class. That is because every program has void inside of these parentheses telling the computer this program does not take command line arguments, words after the program's name. That is different from make and code and cd and other commands that you've typed with words after them, their names at the prompt. But it turns out the other supported syntax for the main function in C can look like this too, which at a glance looks like kind of a mouthful, but it just means that main can take 0 arguments or it can take 2. If it takes 2, the first is an integer and the second is an array of strings. By convention, those inputs are called argc and argv. Argc is the count of arguments that are typed after the program's name. Argv is the argument vector, aka array of actual words. In other words, now that we have the ability to use arrays, we can get 0 or 1 or 2 or 3 or more words from users at the prompt when they run our own programs. So what do I mean by this? We can now write programs that actually have command line arguments as follows. Let me go into VS Code here and close our old program uppercase. Let's write a new, simpler program here in my terminal called greet.c and just greet the user in a couple of different ways. So I'm going to include initially CS50.h and then I'm going to include standard.io.h here. Then I'm going to say int main void without introducing anything new just yet. I'm going to ask the user, like we did last week, for a return value from getString, asking them what's your name, as we've done so many times. Then I'm going to say printf hello, comma, %s\n, spitting out their answer as follows. Same program as last week again. I'm going to make greet. I'm going to say /greet, and I'm prompted now for my name. I hit enter. Notice that I did not take any command line arguments. The only command I ran was /greet, no other words. Let's now use this new trick and actually let the user type their name when they're running my program, rather than waste their time by using getString and prompting them. Let me go into my editor here. Let's get rid of the CS50 library. Let's get rid of my use of getString. And let's simply change void to int argc, then string argv, open bracket, close bracket. That's all. Down here, let's simply print out argv bracket 1 for reasons we'll soon see. The only change that I'm making really is changing the prototype for main from the first version, which we've been using for like a week and a bit now, to the second version, which is the only other version supported. I'm going to go back to my terminal window now, make greet, and darn it, I shouldn't, so close. Why did I make, how do I fix the mistake I accidentally made? Yeah, and back. Oh, no, in front. Yes, I should have kept the CS50 library because it's in the CS50 library that string is defined, so include CS50.h. In week 4, we will delete that line for real and actually show you what string actually is. I promised at the start of class that string is a term of art, but it's not a keyword in C, but we'll see what it means in a couple of weeks' time. Okay, let me fix this. Make greet, /greet, but now I'm gonna type, before I even hit enter, my actual name. And when I hit enter now, I see hello, comma, David. If I instead do /greet Kelly, enter, now I see hello, comma, Kelly. If I do nothing, like greet, enter, I just see hello, null, which is not the same null as before, N-U-L. This is N-U-L-L for reasons we'll come back to before long, but clearly printf knows something's going on. There's no actual word there. Why, though, did I do argv bracket 1? Well, it turns out that just as a feature of C, if I recompile this program and do /greet and type in nothing else, I'm going to see something kind of curious, hello /greet, because automatically the 0 location in the argv variable will automatically contain the program's own name. Why is this useful? If you ever want to do something self-referential, like thanks for running my program, or you want to show documentation for your program and the name of your program, that it depends on whatever the file itself is called, you can use argv bracket 0, which will always contain the program's name, no matter what the file has been named or renamed to. But we can fix that null issue now in a couple of ways. So argc is the other input that I said now can exist, which is the count of arguments at the prompt. So if I want to check if the user actually typed their name, I could say something like if argc = 2, well then, and only then, go ahead and print out their name. Else, let's just do some clever default like printf, quote unquote, hello world, or heck, nothing at all. This version of the program now is a little smarter because when I run make greet and do /greet of my name, works exactly as intended. But if I forget and only do /greet, it's going to say hello world. Moreover, if I don't quite cooperate and I say David Malin, enter, it similarly just ignores me because arg count is not 2 anymore, it's now 3. So argc contains the total numbers of words at the prompt, but the first one is always the program's name. Question? Sorry, can you say that once a little louder? Why is it information that we just have, or?
Oh, I didn't mean to do that.
Oh, so the short answer is just because. Like the definition of C, if you look up the documentation for C, you can either define main as taking no arguments with the word void, or you can specify that main can take 2 arguments. And the compiler and the operating system will just ensure that if you provide 2, those 2 variables, argc and argv, will be filled with those 2 values automatically. Someone else decided that, though. That's just the way it works. You can't put 3 there, you can't put 4 there. You can change the names of those variables, but not the types because of this convention. So there's one last feature of main then. It's the actual value it returns. Up until now, every program I've written starts with int main something. Int main something. What is that int? We have yet to use it. Technically, the value that main returns is going to be called the so-called exit status, which is a numeric status that indicates success or failure. Numbers are everywhere in the world of computing. So for instance, here's a screenshot from Zoom, whereby if something goes wrong with Zoom, like you have bad internet connectivity or something like that, you might see an error code like 1132. That means nothing to normal people unless you Google it, look up the documentation, but it means something very much to the software engineers who wrote this code, because they know, oh shoot, 1132 means this error. And they probably have a spreadsheet or a cheat sheet somewhere that converts those codes to actually useful error messages. And frankly, in a better world, they would just tell you what the problem is rather than just say, report the problem and mention this number. That said, on the web, odds are you're familiar with this number, 404, which is also a weird thing for so many normal people to know, but this generally means file not found. It's a numeric code that signifies that something has gone wrong. Exit status isn't quite this, but it's similar in spirit. In main, you can return a value like 0 or 1 or 2 or something else to indicate whether something was successful or not. By convention, a function like main returns 0 on success, if all is well. And that leaves you then with like several hundred possible things that can go wrong, because you could return 1 to signify one thing, 2 to return another, 3 to signify another, and so long as you have a spreadsheet or a cheat sheet or something, you can just keep track as the programmer as to what error means what. So what does this mean in real terms? Well, if I go over to VS Code here, let me implement a relatively simple program, our last, called status.c. So in status.c, I'm going to go ahead and use the CS50 library at the top, the standard IO library at the top, and then inside of int main, and with our new format, int argc, string argv, square brackets, inside of main, I'm going to now do the following. If argc does not equal 2, then I'm going to go ahead and print out this time a warning. I'm not going to have some silly default like hello world. Let's tell the user that they didn't use my program correct. And I'm going to say printf missing command line argument. And we'll assume they know what that means. Then to signify an error, I'm going to say return 1. It could be 2, it could be 3, but this is the first possible error, so I'm going to start simple with 1. Otherwise, if argc does equal 2 and I get to this part of my code, I'm going to say hello, comma, %s \n and pass in argv bracket 1 just like before. And just to be super specific, I'm going to return 0 to tell the computer, the operating system, that this is success. 0 signifies success. Any other value signifies error. Let's make status now.
What is it? You got a boogie?
Yeah.
Okay. You need a wipey?
Yeah.
Oh no.
What? No.
Olivia, Mama will help you. Oh my God, what are you doing?
I want to.
Trying to wipe it on you?
No, she's just hiding. She just wants to bug me.
Yeah.
A bug. A bug inside.
You're the bug.
A bug inside.
Oh my God. Fine, whatever. You obviously don't have a boogie that's that boogied.
No. She's just saying it just to get attention.
That guy who tried to beat up that little teenage girl,
Huh?
he's getting 2 assault charges.
I don't even know what you're talking about.
It was a manga or whatever. That guy with the red looking Trump supporting hat got out of a truck at a high school peaceful protest against ICE. And he started trying to pick a fight and swung on a teenage girl and got jumped by girls.
Oh my God.
He got jumped
What
so
the
bad, he beat, his face is all swollen and bruised.
Yeah.
He jumped back in the truck and they got video of it, and the police confirmed that he was the aggressor, that he stopped with his Trump supporting
Yeah, he was in his car, I mean.
and stopped, got out to aggress the high schoolers, got jumped by a bunch of girls. Then when he realized his face was plastered all the news, shaved his face, completely shaped everything
Damn.
to try to evade it, but they were able to find him, and now he's
Dang.
facing 2 assault charges of a minor with intent to
Well.
harm.
And didn't run from that one.
It was in Bastrop.
It was in Bastrop. I told you.
Somebody's like, what? Where he fucked up is he tried that in a small town. Just because it's Bastrop doesn't mean them kids play.
Well.
Oh man, that shit was crazy.
Bastrop. Sounds like Bastrop.
Don't play with them kids. You can feel however you feel, but you coming out in a peaceful protest and to try to agitate doesn't end well, especially in assaulting a child.
I have to do this.
These people are too comfortable with
No.
assaulting children.
No. Okay, what do you need?
But they found him. They found it, but best believe they found his ass. And guess what his name was? Chad. Motherfucking Chad.
What do you want, Olivia? Pepper, lay down. What do you want? What? The TV? You don't have anything on the TV? You want your baby show? Okay.
Yeah. He said yeah. No, you don't want it? Oh, she wants you to do it. She doesn't want me to do it. It doesn't matter how it gets done. It matters how it gets done for her.
I already put an extra hour on the class just from having to stop and do stuff with Olivia.
I feel you, dude. I haven't gotten to study at all today.
You could study. I mean, either ways.
I don't know if that's to do it, right?
I mean, I do it even with them when I'm here with her, so it just takes longer. What? It died.
It died.
You gotta put it back on the charger. It died. You gotta put it back on the charger. There. You gotta let it charge. Leave it alone. Let it charge. Oh man, where'd my water go? Oh no. God dang it. I don't know where my water went.
Let's do /status, and this is a little magical, but let me go ahead and cooperate initially. I'm going to type in my name, David, and I'm going to see hello, comma, David. Most people wouldn't know this, but among the commands you can type at your terminal are this one here. And the TFs and I, the TAs and I would do something like this. We, after running your code, can do echo space $? and we can see secretly the return value that your program returned, 0 in this case. Meanwhile, if we do this again, /status, /status, and let me not type my name this time. When I do this, I see missing command line argument. What value should the code have returned then? 1. So let's see, echo $? There's the 1. So even after just 1 week of CS50, if you've ever wondered how Check50 knows if your code was correct or not, among the ways we check for that is by checking this semi-secret status code, this exit status, which isn't really a secret. It's just not displayed to normal people because it's not all that enlightening unless you're the software developer who wrote the code in question. But this means we could return 1 in some cases, or 2 in other cases, or 3 or 4 in yet others. And these command line arguments are sort of everywhere. And in fact, a program I skipped over a moment ago was going to be this. There's no academic value to what you're about to see, but another program that takes command line arguments is known as cowsay. And this is sort of very famous in computing circles because it's been on systems for many years. Cowsay is a program that allows you to type in a word after the prompt like moo, and it will print out what's called ASCII art, an adorable little cow with a speech bubble that says moo, so kind of evocative of like Scratch. But it takes other command line arguments, not just the words that you want to come out of its mouth, but even the appearance that you want it to have. So for instance, I can say -f duck and run it again, enter, and now I have a little cute duck saying moo, which is a bit of a bug, so let me change that to quack, for instance, instead. And again, no academic value here, it's just fun to now play with the various options. But if we really want to have fun with this, we can do another one, so cow say -f dragon, and we can say something like roar, and now we have this crazy dragon appearing on the screen, which is to say, again, no value here. It's just fun to play with command line arguments sometimes. And how is cowsay doing this? Well, someone wrote code, maybe in C or some other language, using argc and argv and poking around at their values, and maybe a conditional that says if the -f value is dragon, then print this graphic. Else if the value is duck, then print this other one. It all boils down to the same fundamentals of week 0 of functions and conditionals and loops and Boolean expressions and the like. It's just being composed into more and more interesting things. And indeed, in closing, among the other interesting things we'll play with this week to come full circle is that of cryptography, the art of scrambling information so as to have secure communication. So important nowadays with passwords and credit card numbers and personal messages that you might want to send. And we'll have you explore through code some of the algorithms via which you yourselves can encrypt information. And there's a number of ways we can.
Dang, how to do the dragon one? I want to see how I did the dragon one. That's just awesome. Nah, screw it. It was still awesome.
Things. And indeed, in closing, among the other interesting things we'll play with this week to come full circle is that of cryptography, the art of scrambling information so as to have secure communication. So important nowadays with passwords and credit card numbers and personal messages that you might want to send. And we'll have you explore through code some of the algorithms via which you yourselves can encrypt information. And there's a number of ways we can do this form of encryption, and they all boil down to this mental model. You've got some input, like the message you want to send, and you want to encipher it somehow, encrypt it somehow, so that no one knows what message you've sent. So you want your plain text, which is the human readable version in English or any other language, to become ciphertext ultimately. So the code you'll be writing this week is inside of this black box, some kind of cipher, an algorithm that encrypts information so that you can do exactly this. Now the catch is that you can't just give it plain text and run it through an algorithm and get ciphertext, because you need to somehow have a secret typically for encryption to work. Like if I'm going to send a message to someone in back, well, I could just randomize the letters that I'm writing down, but how would they know how to reverse that process? Probably what we need to do is agree in advance that, you know what, I'm going to change every A to a B, and every B to a C, and a C to a D, and a Z to an A, all wrapped back around at the end of the alphabet. It's not very sophisticated, but no middle school teacher, if they intercept two kids passing notes in class, are going to waste time trying to figure out this cipher, but it does presuppose that there's a secret between them, the number 1 in that case, because I'm changing every letter by 1 place. So how might this work? Well, if I want to encrypt the word hi, H-I exclamation point, and my secret key with someone that I've come up with in advance is 1, I should send the ciphertext IJ exclamation point. Now this is a simple cipher, so I'm not really encrypting the punctuation, which may or may not be a good thing, but I am encrypting at least the alphabetical letters. But what does the recipient then have to do to decrypt this message? When they see on paper IJ exclamation point, how do they know what I said? Well, they use that same key, but subtract. So B becomes A, C becomes B, A becomes Z, and so forth, essentially inverting the key from +1 to -1. Of course, slightly more secure than a cipher of 1, a key of 1 would be 13. And in fact, in computing circles, 13 has special significance. ROT13, R-O-T13, is an algorithm that's been used for many years online just to sort of avoid spoilers, like Reddit might do this or other websites where they want you to have to do some effort to see what the message says. But it's not all that hard. You just have to click a button or write the code that actually does this. But if you use 13 instead, you wouldn't get IJ, you'd get UV, because U and V are 13 places away from H and I, respectively. But again, we're not touching the punctuation. Or we could send something more personal, like I love you, and the message comes out like that. Slightly more secure than that would be ROT26, no? No, why? Because it's the same thing. It literally rotates all the way around. A becomes A, B becomes B, so there's a limit to this. But more seriously, that speaks to just how strong this encryption is or is not. Because if you think about this now from an adversary's perspective, like the teacher in the room intercepting the slip of paper, how much work do they need to do? Well, they just try all possibilities. Key of 1, key of 2, key of 3, ... key of 25, and at some point they will see clearly that they guessed the key, which means that cipher is not very secure. Nonetheless, what we're talking about is historically known as the Caesar cipher, because back in the day, when Caesar was communicating by legend with his generals, if you're the first human on Earth to come up with encryption or come up with this specific cipher, it doesn't really matter how not complex it is if no one else knows what's going on. Nowadays, it's not hard at all to write some C code or any other language that could just brute force their way through this. So there are much more sophisticated algorithms nowadays than simple rotations of letters of the alphabet, as we'll soon see. But when it comes to decryption, it really is just a matter of reversing that process. So this message here, if we rotate all the letters in the opposite direction by subtracting 1, will be our final flourish for today. There's a bit of a hint there which will reveal that this message and our final words for us as the clock strikes 4:15 is going to be the U becomes T and the I becomes H. So I'm the only one this is amusing. CS50, and this was CS50. We'll see you next time.
He's struggling with that one. I finally finished the lecture. Holy crap. Oh my god. Now I gotta do the problems. And it looks like there's more problems this time. Here we go. Scrabble. In the game of Scrabble, players create words to score points. And the number of points is the... Okay, hold on. Let's go ahead and create my file. Okay. My directory wants to be in a folder called Scrabble. Okay. What's the commands? Help. is make. How do you make a file? God dang it. Or was I supposed to put it together? Like make directory. What was it called again? Scrabble, right? In a folder called Scrabble. That's what it was. Okay, CD. Scrabble. Got it. Okay. And then code. Scrabble. Boom. Okay, I'm in. Okay, include. And then alright, that's what we're gonna do. Okay. Alright. Got that part out of the way. Alright, in the game of Scrabble, players create words to score points, and the number of points is the sum of the point values of each letter in the word. Okay. A is 1, B is 3, C is 3, D is 2, E is 1, F is 4. Okay, that's a lot of... I need a list. Alright. For example, if we want to score the word code, we would note that C is worth 3 points. The O is worth 1 point. The D is worth 2 points. And the E is worth 1 point. Summing these, we got the code. We got that code is worth 7 points. And a follow on. Implement a program in C that determines the winner of a short Scrabble game. Your program should prompt for input twice. Once for player 1 to input their word, and once for player 2 to input their word. Then, depending on which player scores the most points, your program should either print player 1 wins, player 2 wins, or tie. In the event the two players score equal points, tie. Okay. Okay, your program should behave per the example below. Alright, so make a program, you just put the words, and then, yep. Alright, so first, I'm gonna go ahead and implement, string. One equals get string. Okay. And then same thing, string player 2 equals get string okay. And then we're gonna have to create some functions, and then it's gonna end with printing out who the winner is. Yeah, so it's just gonna print the results. Okay. So put something down here that just says we'll do this. Okay. And then we'll put player. Okay. Okay. Let's see, how do I want to start this off? Okay, so we have multiple ones that means different things. Just put print. No, because I can use the debugger now, so I don't need to print every time. Okay, so let's go. I need a. Oh, there's a lot of crap to label. Okay. separate all this. All the results are really gonna be is which ones. Okay, which ones got more. Here, I'll just do this. If here 1. I'm gonna put something down here at the bottom, like I mean, I can put that at the end anyways. I mean, that's no big deal. Oh yeah, I won't name it player 1 anyways. I'll have to name it something else. Okay, how do I want to start this? I guess I have to define all of these. God dang, that's a lot of crap to... Isn't there a quicker way to label them all? I don't remember if there was a quick way to... It's not great, what was that? String length. Tells you how long the string is. So what I could do is, how do I do them both at the same time? see, try to think how this one ran. So you can do these. Oh, but I still gotta define the individual letters. Can I do like multiple things? I don't think I can. Okay, let's try. Okay. Crap, how do I give? If I put some into it, I can turn it into numbers. How do I make it equal numbers though? Crap. I need to think that. Hold on. I mean, I can make them individual variables. Or I'd have to go one down, but I still gotta put all these freaking letters in somehow. Can I do more than one? gonna be hard. Crap. Fuck. I can't do it like that. Make. Okay, screw it. Let's see. What is. Okay, if I ask. I know that if I. Hey, what's up? This is this stuff's not easy, dude. Even after watching the videos, it's like, man, this stuff's hard, bro. Like, I'm not even gonna lie. Let's see. Alright. God dang it, how did I do it? Let's see, you can make. Okay, you can make areas, which can select the characters. So maybe I should do something like a string words. How do I associate? Let's try the 4 thing, maybe. 4. It's gonna receive a string. Oh shoot, I don't even need to put that. Actually, I'll just do this. Let's see. Let's do
0. Hey, mute the mic real quick.
Well, they left. Oh well. Alright, so I'll do like so n equals well I is less than player 1. What if I title it string 1? Let's do that. That'd probably be better, honestly. Okay, for I equals 0, and then I plus plus. Okay. So it'll run as long as the length of the string. Right? No, wait, I need to put string length, not. Okay, string length. Length. Okay. we got something. We got something going on now. Alright. So that begins that sequence. And then I'll have to... wow, okay, so it'll check it. Okay. So now I gotta figure out a way to check it. Man, I gotta associate the... Hey, Cran Man. So, I just finished the lecture thing assignment. Now I'm trying to write the code for this situation. It's not super easy, but not super easy for me anyways. Alright. How many points are those? 10 points total, so I only need to make like 10 different ones. Values. But how do I... Are you planning on creating OS or libraries? Since man, I'm barely just trying to learn this stuff. That's pretty much where I'm at with it. I'm just well, it wants me to make a Scrabble game where every letter has a value, and then you add those values up together. But yeah. But I'm trying to figure out how I'm gonna... I mean, you got a score of 1 out of 10 for each letter, but I gotta... Yeah, no, but like, I meant for future. Dude, I mean, I don't know, honestly. All I know, like, I want to get into the coding stuff. That's all I really know. So, that's... I mean, I'm not even positive where I want to end up with it. I just know I want to learn it. But I want to admit, this stuff ain't easy, so it's going to take me a whole minute before I ever get to figuring out exactly what I want to do. I feel like they want me to use the arrays things. That creates an area too. And then I put 0's weight. Oh, wait. Oh, maybe I could use that for the player 1 and player 2. Okay, hold on. Instead of doing this, maybe... Let's try... Let's see, hold on. Yeah, so I can store words. Wait, can I store characters? Because it's free. I mean, I don't know, and I don't have like a time limit on it. I'm just doing something. I know some people told me to do it, and then some people are telling me not to do it. And so, I mean, I don't know. It's whatever. I mean, I started it, and so since I started it, now I want to finish it. Aries. Let me think. I mean, I could set that for. don't work like that. Yeah. Multi-character. Oh, fuck me. I don't know why I put that. Oh my god, dude. Oh. So I have to put 2. Oh my god. And then if I want to print individual characters out, then I do that. Yeah.
Where mine is?
Huh?
Mine is the boy. Mine is that. My card. This is mine. No, over there. Yours. No, this is mine. Okay, yours. What is the meanness?
Okay, what if I don't put anything?
Hubby. What kind of hubby is it?
Okay, so I need to make it go for the length of string. God dang. So I'm gonna put 2 of these. You know what? I might as well get rid of this crap right here and just move. Fuck it. That's what I'm gonna do. Because this is starting to get ridiculous. Okay, let's just screw that. Alright. Alright, so for the length. Oh, I spelled that wrong. Hold on. God dang it. String. How do you spell it? Strlen. Okay. Oh crap, why'd I do that? Oops. Why is that not changing color yet? Does I only exist with? I don't think I only exist within there. Alright. Put that, but that's not really the. Undeclared I. Let's just do this. Oh, that's what it was. God dang it. Putting too many of those. Okay. Player 1. Okay, 0, 1, 2. I don't need that. I don't know why. Okay. The semicolons are giving me Java PTSD. Yeah, why don't you use I'm just, this is what they're wanting me to use in here. I mean, I don't even know what Clion is. The only thing I've learned is Visual Studio Code. So, what the hell, dude? But this is what they're wanting to use for the class, so I don't have a choice. I have to use this. Okay, let me think. So I got the amount of times to go through. Dude. So I have to assign each character to an integer. Oh my god. Okay. Man, I gotta figure out how I'm gonna do this. Type. Oh, what do I need type for? Fuck, I don't even remember what that one was. C type.
Dada. Dada.
Okay, I did that.
Dada.
Oh, I did that one different. What?
What is this?
That's candy.
What?
That's candy. Where'd you get candy?
No. No, you can't.
Sea lion. They're versions only for one language, but way faster. Oh, for like Python or so, or I guess C lion's just for C. PyCharm's for Python. Yeah, I don't know. I think Visual Studio. No, I was using something. Well, they had me using Spider for the MIT stuff that I was doing the other day. Let's see. Compute the score of each word. Compute scores. Oh, figures they really would do that. Points. Word one. Compute score. So they created. What's up with it? Oh, those are all the numbers. I feel like this could have been done differently. String word. each letter of the alphabet. You can insert these. But how are they gonna? Score equals 0 for integer. Length string word. Yeah, see, okay, I was doing that part. Length. Oh, I didn't even think that. If you because the I is gonna count every time like that. 0, 1, 2. So it's gonna be at 0. So it's gonna be the first one, and the score is going to add to the points for that. Okay, where do you get points from? Up here. Integer points. I mean, but how do you? But this can't use that up here, can it? So you created it, but I thought this had to be in its own thing. They are versions only for management. I mean, I got that part. Okay, see, I did that part. Let me see, for... What's the... Is upper, is lower. Oh, you only have to do that because it distinguishes the different. I didn't even think about uppercase and lowercase. Is uppercase and lowercase even different? It's all uppercase. What does this do? Oh. And dude, he didn't show me this though. If you put this points, then it contains all of this points assigned to each of the. How does that assign each letter to the alphabet? I thought you still gotta assign it to the alphabet, don't you? Okay, look. Alright, so you input the word here. Word 1. And word 1 goes here to compute score. Oh, because you can call this function to both of them instead of what I'm doing. I'm doing more work. See, that's why I should have did what I was doing in the first place. Hold on. Okay, let's go back to this. But I shouldn't title this results. Oh wait, I don't have to put this here. God dang it, why am I doing that? No, that's not defined by that. I just gotta... Just define like this, and whatever I call it. And here is what it's gonna be. So I need to put... R... I don't have to do this then. Does it work like that? It should work like that. This is how you. He's containing all of them. Dude, how did. What? But how does it. From front to back. I mean, I get what it's doing, but how does it associate that with each letter? 3. This is the part that I don't understand, how the words are associated. Okay, so you define the integer of points. Points contains that series of points. How? Are you going to build any project and see? I mean, I'm just doing the classes. I have no idea on future plans, to be honest. I'm not gonna lie to you. I don't know. A lot of people keep asking me where I'm. I mean, I just hope to learn the coding stuff and get in it somewhere. The only way I'm gonna get in it is to start doing it. So that's what I'm doing. Let's see. Okay, so I got that part. The 4. Need a score tracker. Let's see. This is the part that's getting me though. It's like I figured that part out because you don't run it through that many times. Okay, we're making it all capital, lowercase, whatever. Take away A. Compute the score for each character. Was that what it was called? C-type, yeah. So. Gonna do one for if it's uppercase. That makes sense. Plus equals. Okay, this is the part that doesn't give me. Do I have to do this for every letter? That's not gonna work. Take away A. Well. What? What is it, Olivia? What is it?
What?
What? What? Oh, because I've been leaving the door cracked. I never closed the door.
She's getting on you.
I didn't close the door. Mama closed the door.
No, Mama. Go
What?
She
threw
threw
a
socks
sock
at
me. God.
She's like, don't let that happen
Oh,
again.
jeez.
I'll put it inside. Hey, why come my go? I'll put it inside.
Why?
Why me? No good.
Okay. Hey, don't you hit me. I'm gonna beat you up. Alrighty then. Ouch, stop. Thank you. Let go. Let go. Those are your sisters.
How does this assign stuff to the alphabet, though? Let's see. Okay, look, if I do this. Okay, so you have this function. Like, can I. Word, string word.
Okay, I'm moving it.
as an integer. Yeah, see, like, how does that? That's not making any sense to me. I mean, I could write this out, but this ain't making any sense to me why it's doing it like this. I don't want to do it if I don't understand it. Score plus equals. I feel like there's something else. This doesn't make any sense. Oh. I forgot about that part. Type void. Incompatible type void. But I thought I defined it here. I can't use it like this. Why can't I use it like that? Okay, fucking. Or do I have to do some crap where it's like, no. Okay, well that's just. I don't understand how to So obviously that doesn't work like I thought it would. X equals result string length 1. Type void. Okay, so God dang it. I'm gonna put int. God dang. Gosh, it gets so confusing. I'm not supposed to put one there. Okay. Damn, fucking hell, I'm gonna be doing this shit forever. Oh my god. What fucking shit. Jesus Christ. What is this asking for? Print time. Fucking hell, dude. God dang. This fucking son of a bitch. What is wrong with this? String length. I thought I fucking typed it right. No, I didn't. Oh, I didn't. Because I went back. It's STRL, yeah. Okay. Holy shit. What's wrong with this? Array comparison into string, aka character. God dang, I forgot to put that as in. Oh my god. I mean, I did that, but then I went back, undid what I did, so now I'm redoing what I already did. I'm so fucking... God dang. God, son of a... Okay, this is the shit it was telling me to do. Wait. Oh my god. How is this gonna work? Debug 50. Player 1 input is okay, current string is hello. Score is 0. N equals, well, currently 0. Okay. Alright, so now I is 0. N is 5. 1, 2, 3, 4, 5. Character score is 0. Oh, because it's lowercase, it goes down here. Score 4 for H. How does that... This part doesn't make sense to me. Now turn implementing compute score. To compute the score of a word, you need to know the point value of each letter in the word. You can associate letters and their point values with an array. Okay, imagine an array of 26 ints called points, in which the first number is the point value for A. Okay, the second number is the point value for B, and so on. By declaring and initializing such an array outside of a single function. Well, I mean, how does it know? B counts as 3 points. Score went to 5. Oh, E counts as 1 point. What's L? That was 1 point. That was 1 point. Okay. How does it associate the alphabet like that, though? I mean, or is it because the C type? That without the C type, it wouldn't work? That's what I don't understand.
Mama, what to do? Mama, what to do? Mama, what to do? Mama, what to do?
I just started the course. The course I'm at week 1, but can't code at the moment because my internet sucks. Can't run the code space. Oh. Man, it's a lot. I mean, it's easier in the beginning and it starts getting harder, so that's all I can say. But I mean, it's worth doing. But hey, this topic, okay, he talked about arrays, but he didn't talk about using arrays like this. So I'm very confused. I don't understand how this can be used. Because how do these associate with the alphabet if you just have A? It's got to be because of this, because the C type. It knows that it's in alphabetical order, I guess. Oh, man. Screw it, I'm gonna run it. Let's see, check. 50. CS 50. Identifies. Oh. I don't put the exact thing it wants me to put. It's correctly identifies HAI as winner over O. Expects player. Okay. It tied it. What you talking about? But that is right. What do you... What? Player 2 wins. Actual... No, it shouldn't be a tie. Science identifies Scrabble as winner over winner. Pig is winner over... Skating is winner over figure. I'm saying it's... how is this one a tie? That's HAI and OH. This is 6. Well, the H is 4. A is 1. I is 1. That's 6. And O is 1. H is 4. I was saying player 2 wins. Expected player 2 wins, but it says tie. Huh. Expected player 2 wins. Why would player 2 win? It shouldn't be a tie anyways. I need to make something to prevent punctuation. the punctuation. Oh, what is it's saying tie because I got an else. If x is greater than y, else if y is greater than x. Well, that question is a tie. Unless... Was it accidentally adding scores for punctuation? Score. Player one. Oh wait. It's counting punctuation. B is a score of 3. Okay. Crap. Okay. What? Okay, I need to check what these two. What is that? Oh, okay. I need to check those two. Because... messed. You know what? Let me check this. I bet I got this messed up. There's so many numbers I typed up here. I probably got this wrong. Let's see here. 1 3 3 2 1 4 2 4 1 4 2 4 1 8 4 1 8 5 1 3 3 2 1s 3 10. There's 4 1s. 2 3 4 4 4 4 8 4 10. No. What? I put commas. 1 3 3 2 1 4 1. This is the high. Okay, where's this at? Right here. So the score is 4 because it already got the H. Okay. Okay, got 1 for the A. Got 1 for the I. Okay, now on the next one. A 1 for the O. H. Got 4 for the H. Okay. X is 6. Y is 5. So 6 is greater than 5. Print player 1. But it says player 1 wins. What the heck? Oh my god. What? I just did it. Okay. Let me try that again. It just worked. Correctly identifies winner between random words. Can't check until a frown turns upside down. Implement correct. What? How, dude? This is it. I just checked it. That doesn't make any sense. I literally just typed those exact things in. Expected player 2 wins actual time. I didn't do that. Oh my god. That's insane. Oh, it's saying it's messing up every time it's supposed to be player 2 wins. Else if why is what is it? Oh crap! Oh my god, that's what it was. Oh my god, that okay? It was me. Oh my god, oh, that's embarrassing. Ugh. Check 50. Yep, that was all me. Yep, I messed that one up. Okay. check it one more time. Just to make sure. Oh, it doesn't subtract the character. Okay, string. It's gonna take I, and I is going to give it that. It's gonna give it that first letter.
Hi there. It's currently 2:30 p.m. with a current temperature of 67 degrees Fahrenheit. Today's low is 45 degrees, and the high is
readability. Sherlock's Web. Okay. Oh man. Alright, I get no help with this one. Oh, this looks crazy. Okay, hold on. What? I have to define the readability. Holy crap. The bigger the I have to create a program that can define the readability.
Okay. Is that what you're doing right now?
Yeah, I didn't say the whole thing.
You just stopped talking.
Oh.
And so I was like, okay.
You're just like.
I'm putting on my shoes.
Oh.
You gotta go get the kids.
Yeah. Do you want me to go get them?
get them.
I wasn't sure if that's what you were saying that you wanted.
I said I got to go get the kids.
Oh.
I didn't say, will you go get the kids?
Oh.
I don't talk in Morse code.
Whatever, all girls
Bop,
do.
beep, boop, 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 beep, bop. Don't speak your 01001 language, sir.
Sorry. This looks hard.
You got this. Nothing's hard for you. I didn't mean that. Wow.
I wasn't even saying that. I was like, no, this is hard, dude.
Okay, well, I love you. You got this.
Love you.
After I bring the kids home, I'm gonna go get sativa, then I'll feed them, and then I gotta go to work.
Alright.
Tattoo today. Still in your shirt.
Okay. According to Scholastic, Bubba's been around since. Been around a second. What does it mean, though, for a book to be particularly reading level? Well, in many cases, human expert. Decisions. God, this is gonna be hard. In a folder called Readability. Oh my god. Create a file called. No, wait, no, that's not what I meant to do. Crap, I'm gonna use that other thing he was talking about. Watch. Oh, that sounds terrible. Okay. Readability. So it's already gonna. Alright. In a file called readability and a folder called readability, you'll implement a program that calculates an appropriate grade level needed to comprehend some text. Your program should print as output grade X, where X Is the grade level computed rounded to the nearest integer? If the grade level is 16 or higher, equivalent to or greater than a senior undergraduate's reading level, your program should output grade 16 plus instead of giving the exact index number. If the grade level is less than 1, your program should output before grade 1. Okay, holy crap. So what sorts of traits are characteristics of higher reading levels? Well, longer words probably correlate with higher reading levels. Likewise, longer sentences probably correlate with higher reading levels too. A number of readability tests have been developed over the years that define formulas for computing the reading level of text. One such readability test is the index of a text is designed to output that U.S. grade level that is needed to understand some text. The formula is well, let's go ahead and put this in here. The formula is index equals 0.5 times what the length. I'm assuming that's what that is. Take away 0.296 times S. I don't know what S is. Take away 15.8. So that times the length take which what the hell? Where L is the average number of letters per 100 words in the text. What? L is the average number of letters. Letters per 100 words in the text. And S is the average number of sentences per 100 words in a text. Okay, so L is the average number of letters per 100 words, and S is the average number of sentences per 100 words. Holy crap. Oh. I'm gonna need include math page. I already got studio straight, yeah. That's main void. I'll get you more.
Daddy, daddy, why you? My daddy, daddy, why you? My daddy, daddy, why you? Daddy, 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 daddy.
Let's see what we got here. Advice. Write some code that you know will compile. Okay, I got that. Alright. Write some pseudo code before writing more code. Just notes. Yeah, I just did that. First, consider how you might prompt the user for some text. Recall the getStrings function. Sees, yeah. String text, getString. I put it like the exact same way. I already. Okay. Now that you've collected input from your user, you can begin to analyze that input. First, try to count the number of letter in the text. Okay. Now that you've collected input from the user, you can begin to analyze that input. First, try to count the number of letters in the text. So that's going to be, wait, where are we at? One way to approach this problem is to create a function called countLetters that takes a string text as input and then returns the number of letters in that text as integers. You'll need to write your own code to count the number of letters in the text, but someone more experienced than you may have already written the function to determine if a character is alphabets. This is a good opportunity to use. He's already written a function to determine if a character is in the alphabet. Open link in new tab. A collection of those. Okay. Need to look for. Locate a substring. Length of a string. Locate a substring. Time in seconds. Check whether a character is alphabetical. Okay, so it's C-type H. C-type H. Check whether a character is an alphanumeric. Check whether a character is alphabetical. So this one is alpha. Character is blank. Check whether a character is a digit. Okay, so what we're gonna do is run through, and we need to count the letters first. So we'll put 4 equals 0. What was the other one called though? I had to find the length. String length. I don't think that was it. Where is it? STRLEN. Yeah, that's it. String length of text. Well, I is greater than n. I plus plus. Let's hit this one around the length of the text. And then I need to F. God dang it. I mean, I need to know if it's got a character. Okay. To lower. Convert characters to lower. Okay, to lower. Just to make it easier. Text. Then the value of I. Let's see. Check whether characters alpha. That's nothing. Alright, I can put that's nothing. I don't know. Okay, that should count. How many letters are in there? Okay. You can integrate count letters into your code. Into the code particle as follows. Okay, next write a function to count words. Okay. Same thing. Oh yeah, I could put them right next to each other actually. Try to make it look clean. Count words.
Michael,
Yeah.
I want to do the scratch game thing where I make a game.
Okay. I mean,
What? Yes. I had a good day at school. Dada, do you see a difference from me in the morning and me now? What?
count. The one for spaces. Is blank. It's a balance number.
Hello? August or Pride? Oh yeah, that's okay. Yeah. Yes, ma'am. Yes, ma'am.
It's not a dot. Actually, I think the little guy.
Okay. What's the soonest availability you have?
Don't call it a duck.
Monday the 16th at 1:30. And how long is the consultation? Okay. Okay. Michael.
Hmm.
Tomorrow or not tomorrow, the 16th at 1:30, about an hour and a half. I might have to leave you to go get the kids.
Okay.
Are you okay with that?
Alright.
Okay. For your rehabilitation. Wednesday morning at what time? Oh wait. You said it was a Monday or a Tuesday? Wait, Monday. The 16th. Actually, no. The 16th is no school that day, so that works because I don't have to. Yes, that works. Okay, awesome. Yeah, the 16th works just great. Perfect. Okay, awesome. Thank you so much. You too. Bye. Alright, your appointment is appointed.
Mm. Well.
I forgot to take a picture of the studio.
Mm. You okay?
Oh my god, please let that happen. Out of all the things in the world.
What?
Oh my god.
Mm.
They say they're a couple votes away from impeaching Old boy.
Oh, really?
Yeah, and somebody said, I'm reading the comments now.
If he gets impeached, he's gonna get locked up.
That's what somebody said. And somebody else says, don't let him in the missile room, hide the keys.
Mama? Can I use these?
But I guarantee you it's specifically because of the Epstein stuff.
Good. He needs to get locked up. These motherfuckers aren't feeling untouchable. Can you what? Use them? Yes, baby. I want you to, if you're using it on paper, to have something underneath that paper, though.
Remember when he kept telling everybody to lock up Hillary? Like,
Yeah. I mean, it sounds like they all need to go somewhere.
man, what? It wasn't it for like tax fraud or something? Like the same crap he's doing? Like, I don't know, dude. This is just crazy. Too much for me to keep up with. Oh. Why'd I do that? Uh-oh. Olivia's being a butthole.
Olivia!
Okay. What's alphanumerical? I think that's what I'm looking for. That is what I think it is, isn't it? Okay. Yeah, I think that's what I need then.
Have we ever had president impeached?
Yeah, I think there was one. Alexa, was there ever a president that was impeached?
Yes. 3 U.S. presidents have
Oh,
been
3.
impeached. Andrew Johnson, Bill Clinton, and Donald Trump. Would you like to know more about any specific...
So he has been impeached before.
Donald Trump has been impeached?
Yes. Donald Trump has been impeached twice. His first impeachment was in 2019 for abuse of power and obstruction of Congress. And his second was in 2021 for incitement of insurrection.
So this will be his third impeachment. Does he get 3 strikes rule on that one too?
I don't know.
Or is that just a Texas thing? He's going for the trifecta.
Alexa, if Donald Trump has been impeached, how is he still president?
Impeachment doesn't automatically remove a president from office. Trump was acquitted both times by the Senate. So he remained in office after each impeachment.
Oh, because the Senate.
Yeah, so they can impeach him, but that doesn't
If the Senate doesn't agree, then it don't matter.
he stacks his chips.
Yeah. I don't even know if I need to put an else. I'm just like being paranoid. Return count. Okay. And now. Jesus. What? What?
baby!
What?
This.
What?
This.
What is it?
This.
Your finger?
Yes.
What's wrong with your finger?
This.
Boogie? You're not trying to wipe a boogie on me, are you?
It is.
No, dude. That's gross.
It is.
No, calm down.
Ah.
Jesus.
She's gonna find out that freaks you out. She's gonna do it more and more. Come here.
Oh my
Where's it at?
god. Confused.
You need a tissue?
Okay.
Fine, whatever.
Recall that the Coleman index is computed using that.
I like it.
You wanna help?
Okay.
Yes.
I think I just need to take this, put it over here.
Okay. Then what?
Okay. And then, what else should I put? L is the average number of letters per 100 words. So, let's do average number of letters. Olivia, stop. Stop. No, ma'am. L equals Olivia. Jesus. What is it? The average number of letters per 100 words. That is the number of letters divided by the number of words.
Stop. Go play with your siblings.
No, don't do that.
Go play with your siblings.
Oh,
Then go. Now. Go that way. Sorry, don't want to clean up the
Per 100 words. The number of letters divided by the number of words. Okay, so
Stop. Okay? Use your words. I don't understand what you're saying. I don't want you to translate her. She needs to learn how to use her words. Y'all all went through this. Let her go through this. I had to tell Cora to tell you not, or to not tell you things. Now it's your turn. You can't tell her what she's saying. First off, Olivia, pick up this mess. You made a mess. I don't want to hear you crying over something you did.
letters divided by number of words.
It goes in here. Put it all up. There it goes. Put it where it goes.
Times 100. Okay. And then int s equals s is the average number of sentences per 100 words in the text. Wait, sentences. Wait. Oh crap, how did I count sentences? Text. if it can be a comma though. Does that mean anything? I don't know if that's gonna work. I don't know. I guess I'll find out here in a minute. Okay, where was I at? Oh, here. No. Okay. The number of sentences. Wait. Divided by the number of words. Multiplied by 100. Okay. You'll want to round the results to the nearest whole number. Okay. If the resulting index number is 16 or higher, okay. If index is greater motion around it yet then. Else if okay.
Let's take a look at readability. In readability, your task is going to be to write a program in C that can take some text and assess the approximate reading level of that text. So for example, you might run your program as /readability. Your program should then prompt the user to type in some text, and after the user types in a few sentences maybe, your program is going to produce as output the approximate US grade.
Okay, hold on. Line 17. Counts letters. Oh, yes, I did mean count letters. Round index. Am I not using round correctly? actually put it down here. Oh, I'll leave that one. Oh god, dang, I keep forgetting the F. Okay. What's this a faster way to do this? Good god. Okay, line. What's 122? That's a long. There is no 122. Two lower. Shouldn't. It's not supposed to be an integer. What? For the size of... Will that work? Probably not. No. Doesn't work like that, unfortunately. This. God dang. I can't do that. Ah, just trying to make it easier, man. Does it only work for single character? I thought it didn't work. Okay, if C is an uppercase letter A through Z, this function returns it to lowercase. If C is not an uppercase, function returns C itself. And okay, I guess that's why I had to do it here. God dang it. think that'll work. No. Okay, screw it. I'm just gonna get rid of that completely. I don't care. See what else I got. Okay. Expected syntax. $51. Okay. I don't know if this will work. Try running program through the following text. Okay. Dang. So I gotta type it out. Try to run the program in the following things to ensure you get these specific. Be sure to copy only the text, no extra spaces. It won't even let me copy it. God dang it. Text. Finish. Something isn't counting right. Readability. Oh, god dang it. God, it's not gonna let me do it. This sucks. Alright. God dang it. Alright, the first thing we're checking is letters. So, got count 0. There's 0, 220 letters. Okay. It's got a letter at the beginning, so that's 1. It's not a letter. It's 2. 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And the next one. Yep. Okay, it looks like the letter's working right. Let's the next part. characters. I probably don't need to check it 220 times, but no, yeah, I need to check every single character. Is blank. This should count the words, right? This is, yeah, words. Every space is a word.
Alright, I gotta go. I love you. I'll see you soon. Bye.
Wow. You could say,
Wow.
you could give me a hug and stuff. Jeez.
Yeah, I gotta get to do that. What do you think about my tattoo flyer?
The 14th is Valentine's Day. You mean Tattoo Day? That's hilarious. Anti-Valentine's tattoos. That's funny.
Okay.
That's awesome. I love you. That was pretty awesome. Okay, so that's the third space. Alright, so that looks like the words, so sentences. Count sentences. I mean, it's only one sentence. But that's supposed to be a grade 16. How is that supposed to be a grade 16? I don't got enough digits, man. Oh, that's not working. Alright, here's the problem. I only moved 10 characters and it counted 9 sentences. That's not right. That's the problem. So, I'm using the wrong thing. I should not be using that. I need to be using capital letters. What do you think? If I use a capital letter. Let's see. Alright. That's not going to work. So, we either need to switch it for the... There's the sentences. I mean, really what ends... Yeah, I mean, capital should work, honestly. Is upper... is upper. Make sure I'm doing it the right way. Actually. Turn a space. Okay. Let's try this. Okay. Here's the fun part. I get to type the whole thing again. God dang it. A large pass. Oh, crap. Ah, it worked. 16 plus. Okay. Now let's try. Grade 8. Ugh. Dang it. Okay, see. The things that end a sentence are really what? Periods, exclamation marks, and question marks. Okay. Well, is up or it's not gonna work. What else do we got? Is a digit. Check whether a character is a digit. What consists of a digit? Oh, that's like a number, isn't it? 0 through 9. Dang it. Not a digit. It's blank. Numerical. A letter or a number or not. A letter or a number. Alphabetical. Lowercase. Okay. That's not gonna work. I don't think this one says a space. Supply space. That's blank. What if I create a new function where it's a okay. How do I check if it's multiple characters? If it's a period, exclamation, or question mark. I could turn those three. And I can put a loop within a loop. What if I did that? Well, let me do that. Nope. Oh. It works like this, don't it? No, crap, it's too many. God dang it. What, I can only do 2? Oh, I can't even do that. No, gotta be one thing. Crap. Alright, is equal to...
Can I make a peanut butter sandwich?
I guess so.
Okay.
Alright. Alright, there are more things in heaven and earth. More things in heaven and earth. That are dreamt of in your philosophy. Grade 8. That's supposed to be grade 9. It's gotta be the rounding thing. Alright. is just one off? Yeah,
Can I have a sandwich too?
I guess so. Oh, god dang it. That's what I'm messing up on. It's not even that. It's this. Oh, crap. It's just that. Hold on. Yeah, that's what I was doing. I forgot the double quotes. Okay. Now, let's try this again. Oh, I never... It keeps saying grade 8. God dang it. That's not grade 8. It's grade 9, bro. Okay, let's try. The rounding's gotta be throwing it off. Alright, let's try this one. Oh. Let's see. A large. That one's right. Okay. How do I... How did it create that as grade 8 all of a sudden? Whoa, hold up now. Oh, man. Oh, man. Well, I think I made it worse. Debug 50. Okay, so it's counting the letters. First letter. Second letter. Three letters. Eight. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like it's counting the letters right. Okay, the number of sentences is 1, 2, 3, 4 sentences. This is gonna take forever. Come on now. Get to the first one. Oh, I did get count one. Okay, so I did count one sentence. So it counted that as a sentence. What, after 11 characters? Somewhere before 11 characters. 11. I don't know. Okay. I think that's working correctly. Alright, this is what I need to do. I need to 1, 2, 3, 4, 5, 6, 7, 8. There's 8 words. Okay. So I need to start that at 1 because it doesn't count the first one, technically. Alright. So I need to fix that with the words. Letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait. Those are all. Wait. 7 times 3 is 21. It's 29. Yeah, okay. And sentences, there's 1, 2, 3, 4. Yeah, it's 4 sentences. The only thing it's getting wrong is the words. It's off by 1 word. Okay, I can change that at least. What? Shows sentences as 0. Okay, so I need to put for words. I need to put 1 there. Okay, make readability. And then see if this changes it. Grade 2. Okay, it's returning the sentences. Okay, let me double check this. That is the number of sentences. Divided by the number of words, all multiplied by 100. Number of words, all multiplied by 100. Well, there's more sentences than words. Alright. Oh, I wonder if I could turn it into floats here. And maybe that'll... before grade 1. Oh, that's what it is. I needed to get the floats in there. Oh my god. I needed to do the floats even earlier than this because otherwise they're not going to be floats here. Okay. Okay. I think I finally got it. Readability. Okay. Let's do the max one just to make sure. A large class of computational problems involved. Oh, I thought I missed that. Okay. Nine. Oh, I think I just did it. Oh my god, yes. Whew. Style 50. Let's see. What is it? Oh, it wants me to rearrange that. What is this? Oh, spaces. Get rid of spaces. Spaces. I don't need a space there? Oh, okay. I don't know why. Why does that look better? I don't know. Dang. Alright, dude. Yes. Okay. Whew. That was a lot. I was getting kind of frustrated too. I was getting so frustrated for the beginning part there. Or was that on the last problem? I feel like the last one was harder, dude. Well, it's also because I didn't know that thing and I was trying to do it without looking at stuff. But I guess I just need to use the tools I have available, honestly. Read the hints. Use the hints. Read the hints. 12 out of 12. Woo! Whoop-de-woo-woo. Dang. Ugh, that's crazy, dude. That was so much. Oh my god. Alright. Let's go ahead and get out of there. Clear. Get out of here. Oh my god. I did it. Ugh. I did that one. I did that. I did one. Oh, crap. That was just readability. Submit one of. Dude, I'm doing the less comfortable one. I didn't even want to do the complicated. I mean, if you give me an option, I'm doing the easier one. God dang it. Oh, my God. What? Try out David's programs for class via week 2's examples to see manage. See functions. I'll focus first on fixing the very first area you see scrolling. Oh, dude, I figured that one out. That was amazing. Now I gotta do this. I don't like the way this looks, bro. Oh my god. Oh, but just skip to the part. What do I need to do? What kind of this the file? Main directive. What does it want? Folder called Caesar. Caesar. Oh my god, Caesar is spelled weird. Okay. It's not how I thought it would be spelled. Oh my god, Jesus. Woo! I don't even know what I'm gonna need for this one. Alright, problem to solve. Wait, can I just have someone read this for me? Can you read it? Man, I want you to read it, man. God. I thought I had a thing for that.
Supposedly, Caesar, yes, that Caesar, used to encrypt, i.e., conceal in a reversible way, confidential messages by
Dang, is that the best voice you got?
shifting
God
each
dang.
letter therein by some number of places. For instance, he might write A as B, B as C, C as D, and, wrapping around alphabetically, Z as A. And so, to say hello to someone, Caesar might write ifump instead. Upon receiving such messages from Caesar, recipients would have to decrypt them by shifting letters in the opposite direction by the same number of places. The secrecy of this crypto system relied on only Caesar and the recipients knowing a secret, the number of places by which Caesar had shifted his letters, example 1. Not particularly secure by modern standards, but, hey, if you're perhaps the first in the world to do it, pretty secure. Unencrypted text is generally called plain text. Encrypted text is generally called ciphertext. And the secret used is called a key. To be clear, then, here's how encrypting hello with a key of 1 yields ifm.
Alright, hold up. I gotta go to the restroom.
More formally, Caesar's algorithm, i.e., cipher, encrypts messages by rotating each letter by positions. More formally, if is some plain text, i.e., an unencrypted message, is the character in, and is a secret key, i.e., a non-negative integer, then each letter in the ciphertext is computed as equals plus %26, wherein %26 here means remainder when dividing by 26. This formula perhaps makes the cipher seem more complicated than it is, but it's really just a concise way of expressing the algorithm precisely. Indeed, for the sake of discussion, think of A, or A, as 0, B, or B, as 1, H, or H, as 7, I, or I, as 8, and Z, or Z, as 25. Suppose that Caesar just wants to say hi to someone confidentially using, this time, a key of 3. And so his plaintext is hi, in which case his plaintext's first character, 0, is H, aka 7, and his plaintext's second character, 1, is I, aka 8. His ciphertext's first character, 0, is thus K, and his ciphertext's second character, 1, is thus L. Make sense? In a file called Caesar.c in a folder called Caesar, write a program that enables you to encrypt messages using Caesar's cipher. At the time the user executes the program, they should decide, by providing a command line argument, what the key should be in the secret message they'll provide at runtime. We shouldn't necessarily assume that the user's key is going to be a number, though you may assume that, if it is a number, it will be a positive integer.
Oh, alright. That dude kind of sucks at reading. Design and implement a program Caesar that encrypts messages using Caesar cipher. Implement your program in a file called Caesar and a directory called Caesar. Your program must accept a single command line argument, a non-negative integer. Let's call it K for the sake of discussion. A single line argument, a non-negative a single command line argument. And, oh, that thing at the beginning. Oh, I figured he was going to do that. He typed that, and then he typed, yeah.
Dada,
Yeah.
can we play video games?
Huh?
Can we play video games?
Yeah, we're going to play some games.
Dada said yes.
God damn, at 8 hours now. Oh, okay. Alright, let's call it okay for the sake of discussion. If your program is executed without any command line arguments or with more than one command line argument, your program should print an error message of your choice with printf and return from main a value of 1, which tends to signify an error. What? Executed without any command line arguments or with more than one line command argument, your program should print an error message of your choice with printf and return from main with a value of 1. Tends to signify an error immediately. If any of the characters of the command line argument is not a decimal digit, your program should print the message usage. The characters in the command line argument is not a decimal digit. Oh, these are a lot of conditions. Okay. Is not a decimal digit, your program should usage and return from main a value of 1. Do not assume that k will be less than or equal to 26. Your program should work for all non-negative integrals values of k less than, holy crap, 2 to the 23rd power take away 26. In other words, you don't need to worry if your program eventually breaks if the user chooses a value for k that's too big or almost too big to fit in an integer. Recall that an int can overflow, but even if k is greater than 26 alphabetical characters in your program's input should remain alphabetical characters in your program's output. For instance, if k is 27, a should not become that. There's 27 positions away from a. Should become B, since B is 27 positions away from A. Provided you wrap around from Z to A, your program must output plain text with 2 separate spaces. Two spaces, but without a new line, and then prompts the user for a string of plain text using getString. Your program must output ciphertext with 1 space but without a new line, followed by the plaintext corresponding ciphertext with each alphabetical character in the plaintext rotated by k positions. Non-alphabetical characters should be outputted unchanged. Your programs must preserve case capitalized letters. God dang. Oh man, I got less hints on this one. Okay, let's go ahead and just... There's more ways than one way to do this, so here's just one. Well, I'll take the one. I'll take the idea. Okay. Let's see. Wait. I don't even know how many I'm gonna need for this. God dang. First, try to write a main function in C that implements the program using pseudocode, even if not yet sure how to write it in actual code. There's more than one way to do this. Here's just one. It's okay to edit your own pseudocode after seeing ours here, but don't simply copy paste ours into your own. Oh. Alright. Well, I'm gonna have to change all that. Whatever your pseudocode, let's first write only the C. Specifically modify main and Caesar in such a way that if the user provides no command line arguments or two or more, the function prints usage. Alright. If the user provides no command line arguments, two or more. God dang it, how did we do that last time? If they don't. Here it is. This is the one we did. If characters equals 2. Okay, that's what it was. Yeah. If it equals 2 characters, then it says hi. Oh, I'll put in parentheses. Alright. The user present now. No command line arguments or 2 or more. user provides exactly one logarithmic command, the program should.
Michael?
Huh? I don't remember. No command if it provides no or two or more.
Turn 0 to tell the computer, the operating system, that this is success. Like 0 or 1 or 1. Otherwise, if argc does equal 2 and I get to this part of my code, I'm going to say hello, comma, %s \n and pass in argv bracket 1 just like before. And just to be super specific, I'm going to return 0 to tell the computer, the operating system, that this is success. 0 signifies success. Any other value signifies error. Here, let me implement a relatively simple program, our last, called status.c. So in status.c, I'm going to go ahead and use the CS50 library at the top, the standard IO library at the top, and then inside of int main and with our new format, int argc, string argv square brackets, inside of main, I'm going to now do the following. If argc does not equal 2, then I'm going to go ahead and print out this time a warning. I'm not going to have some silly default like hello world. Let's tell the user that they didn't use my program correct. And I'm going to say printf missing command line argument. And we'll assume they know what that means. Then to signify an error, I'm going to say return 1. It could be 2, it could be 3, but this is the first possible error, so I'm going to start simple with 1. Otherwise, if argc does equal 2 and I get to this part of my code, I'm going to say hello, comma, %s \n and pass in argv bracket 1 just like before. And just to be super specific, I'm going to return 0 to tell the computer, the operating system, that this is success. 0 signifies success.
See, that's what I did, but I didn't want to do that. Damn it. Oh, God, Jesus, I can't. Bring it back. There it goes. That's what I did. What the?
Any other value signifies error. Let's make status now. Let's do /status, and this is a little magical, but let me go ahead and cooperate initially. I'm going to type in my name, David, and I'm going to see hello, comma, David. Most people wouldn't know this, but among the commands you can type at your terminal are this one here. And the TFs and I, the TAs and I would do something like this. We, after running your code, can do echo space $? and we can see secretly the return value that your program returned, 0 in this case. Meanwhile, if we do this again, /status, status, and let me not type my name this time. When I do this, I see missing command line argument. What value should the code have returned then? 1, so let's see, echo $? There's the 1. So even after just 1 week of CS50, if you've ever wondered how Check50 knows if your code was correct or not, among the ways we check for that is by checking this semi-secret status code, this exit status, which isn't really a secret. It's just not displayed to normal people because it's not all that enlightening unless you're the software developer who wrote the code in question. But this means we could return 1 in some cases, or 2 in other cases, or 3 or 4 in yet others. And these command line arguments are sort of everywhere. And in fact, a program I skipped over a moment ago was going to be this. There's no academic value to what you're about to see, but another program that takes command line arguments is known as cowsay. And this is sort of very famous in computing circles because it's been on systems from operate initially. I'm I'm going to type in, I'm going to go ahead and use the CS50 library at the top. So there's one last feature of main then. It's the actual value it returns. Up until now, every program I've written starts with int main something. Int main something. What is that int? We have yet to use it. Technically, the value that main returns is going to be called a so-called exit status, which is a numeric status that indicates success or failure. Numbers are everywhere in the world of computing. So for instance, here's a screenshot from Zoom, whereby if something goes wrong with Zoom, like you have bad internet connectivity or something like that, you might see an error code like 1132. That means nothing to normal people unless you Google it, look up the documentation, but it means something very much to the software engineers who wrote this code, because they know, oh shoot, 1132 means this error. And they probably have a spreadsheet or a cheat sheet somewhere that converts those codes to actually useful error messages. And frankly, in a better world, they would just tell you what the problem is rather than just say, report the problem and mention this number. That said, on the web,
call it, you can prove return. Okay.
Odds are you're familiar with this number, 404, which is also a weird thing for so many normal people to know, but this generally means file not found. It's a numeric code that signifies that something has gone wrong. Exit status isn't quite this, but it's similar in spirit. In main, you can return a value like 0 or 1 or 2 or something else to indicate whether something was successful or not. By convention, a function like main returns 0 on success, if all is well. And that leaves you then with like several hundred possible things that can go wrong, because you could return 1 to signify one thing, 2 to return another, 3 to signify another, and so long as you have a spreadsheet or a cheat sheet or something, you can just keep track as the programmer as to what error means what. So what does this mean in real terms? Well, if I go over to VS Code here, let me implement a relatively simple program, our last, called status.c. So in status.c, I'm going to go ahead and use the CS50 library at the top, the standard IO library at the top, and then inside of int main, and with our new format, int argc, string argv, square brackets, inside of main, I'm going to now do the following. If argc does not equal 2, then I'm going to go ahead and print out this time a warning. I'm not going to have some silly default like hello world. Let's tell the user that they didn't use my program correct. And I'm going to say printf missing command line argument. And we'll assume they know what that means. Then, to signify an error, I'm going to say return 1. It could be 2.
the. Hold on. Let me see. I'm gonna double check before I say anything. Alright. I don't know why this isn't working. Missing command line. Alright.
It could be 3, but
Status. Where's status? Okay. Maybe I need the second part.
this is the first possible error, so I'm going to start simple with 1. Otherwise, if argc does equal 2, and I get to this part of my code, I'm going to say hello, comma, %s \n, and pass in argv bracket 1, just like before. And just to be super specific, I'm going to return 0 to tell the computer, the operating system, that this is success. 0 signifies success. Any other value signifies.
I don't know. See what this does. I don't know, dude. Because I don't know why it's not. It's returning the value that it gave it. That's all this is doing, right? I don't know why it's. I can't get it to work correctly. Yeah, that's the string 1. So all you're doing is returning the string back if you do it like that. But
Signifies error. Let's make status now. Let's do /status, and this is a little magical, but let me go ahead and cooperate initially. I'm going to type in my name, David, and I'm going to see hello, comma, David. Most people wouldn't know this, but among the commands you can type at your terminal are this one here. And the TFs and I, the TAs and I would do something like this. We, after running your code, can do echo.
wait, doesn't 1 technically mean 0? No. I don't know. God dang it. Dude, I can't. Okay, so now it doesn't pass the conditions. Now it's just. What is 2? It's not equal to 2. I thought I already tried that. Oh my god, okay. Alright. So I got that part figured out. Kind of a pain in the butt, but I don't understand how that works too. If the user provides no command line arguments or two or more functions, print. Why does the two that fits there? He didn't even explain that, did he?
Space $ question mark. Well, then and only then, write programs that actually have command line arguments as follows. Let me go into VS Code here and close our old program uppercase. Let's write a new, simpler program here in my terminal called greet.c and just greet the user in a couple of different ways. So I'm going to include initially CS50.h, and then I'm going to include standard.io.h here. Then I'm going to say int main void without introducing anything new just yet. I'm going to ask the user, like we did last week, for a return value from getString, asking them what's your name, as we've done so many times. Then I'm going to say printf hello, comma, %s\n, spitting out their answer as follows. Same program as last week again. argc, then string argv, open bracket, close bracket. That's all. Down here, let's simply print out argv bracket 1 for reasons we'll soon see. The only change that I'm making really is changing the prototype for main from the first version, which we've been using for like a week and a bit now, to the second version, which is the only other version supported. I'm going to go back to my terminal window now, make greet, and darn it, so close. Why did I make? How do I fix the mistake I accidentally made? Yeah, in back. Oh no, in front. Yes, I should have kept the CS50 library because it's in the CS50 library that string is defined. So include CS50.h. In week 4, we will delete that line for real and actually show you what string actually is. I promised at the start of class that string is a term of art, but it's not a keyword in C, but we'll see what it means in a couple of weeks' time. Okay, let me fix this. Make greet, /greet, but now I'm going to type, before I even hit enter, my actual name. And when I hit enter now, I see hello, comma, David. If I instead do /greet Kelly, enter, now I see hello, comma, Kelly. If I do nothing, like greet, enter, I just see hello, null, which is not the same null as before, NUL. This is NULL for reasons we'll come back to before long, but clearly printf knows something's going on. There's no actual word there. Why, though, did I do argv bracket 1? Well, it turns out that just as a feature of C, if I recompile this program and do /greet and type in nothing else, I'm going to see something kind of curious, hello /greet, because automatically the 0 location in the argv variable will automatically contain the program's own name. Why is this useful? If you ever want to do something self-referential, like thanks for running my program, or you want to show documentation for your program and the name of your program, that it depends on whatever the file itself is called, you can use argv bracket 0, which will always contain the program's name no matter what the file has been named or renamed to. But we can fix that null issue now in a couple of ways. So argc is the other input that I said now can exist, which is the count of arguments at the prompt. So if I want to check if the user actually typed their name, I could say something like if argc equals 2, well then, and only then, go ahead and print out their name. Else, let's just do some clever default like printf, quote unquote, hello world, or heck, nothing at all. This version of the program now is a little smarter because when I run make greet and do /greet of my name, works exactly as intended. But if I forget and only do /greet, it's going to say hello world. Moreover, if I don't quite cooperate and I say David Malin, enter, it similarly just ignores me because arg count is not 2 anymore, it's now 3. So argc contains the total numbers of words at the prompt, but the first one is always the program's name. Question? Sorry, can you say that once a little louder? Why is it information that we just have, or? Oh, so the short answer is just because. Like the definition of C, if you look up the documentation for C, you can either define main as taking no arguments with the word void, or you can specify that main can take 2 arguments. And the compiler and the operating system will just ensure that if you provide 2, those 2 variables, argc and argv, will be filled with those 2 values automatically. Someone else decided that, though. That's just the way it works. You can't you can't put 3 there, you can't put 4 there. You can change the names of those variables, but not the types because of this convention. So there's one last feature of main then. It's the actual value it returns. Up until now, every program I've written starts with int main something. Int main something. What is that int? We have yet to use it. Technically, the value that main returns is going to be called the so-called exit status, which is a numeric status that indicates success or failure. Numbers are everywhere in the world of computing. So for instance, here's a screenshot from Zoom, whereby if something goes wrong with Zoom, like you have bad internet connectivity or something like that, you might see an error code like 1132. That means nothing to normal people unless you Google it, look up the documentation, but it means something very much to the software engineers who wrote this code because they...
All right. Well, we got that figured out. So 1, if I set it for 1, then it doesn't really, I guess 1's just entering it. But the second I put anything in, then that's 2. That's interesting. Okay. Well, that works. Recall that. Okay, checking the key. Now that your program is hopefully accepting input as prescribed, it's time for another step. So your C below main, a function called only digits that takes the string. Odds are you'll want a prototype like function called only digits. Okay. That takes a string as an argument and returns true if that string contains only digits 0 through 9, else it returns false. Be sure to add the function's prototype above main as well. So be sure to include 50. I think I already got that one. Also, a string and bool. Recall that string is just an array of characters. Recall that string length declared in string H. Yep. Calculates the length of string. You might find is digit declared in C type. I got C type there to be helpful per manual. But note that only checks one character at a time. Then modify main in such a way that it calls only digits on aggregate. Okay. So first, I need to Recall that a string is just an array of characters. Recall that string length declared in string H calculates the length of the string. Okay, now the problem. Okay. Only digits that takes a string as an argument and returns true or false. And returns true if that string contains only digits. 0 through 9. Okay. So, for do this equals 0. Oh, did I put 0 or O? Oh my god. Okay. Equals length, string length. String length of S. Is digits. Okay. F as digits equals.
You, the stinky face. Quit being so stinky. Besides, you're gonna love it after you do dishes. Why? You have to like roast dishes. I can just wash my hands.
Then modify main in such a way that it calls only digits.
Besides, you've been at school all day. Your butt's been in so many stinky places. You know all those chairs you sit in that a ton of other kids sit in? Stinky. Gross. Take a bath.
Okay.
The dude said you have to get like 60% of your earnings, right? Not even that. He says 80%.
Well, 80% the first time, 60% this.
No, it says unable to earn. If you're unable to earn any 80% of your earnings in regular occupation, you stay on long-term disability.
Let me see. When I looked it up, it said I saw where it said 60%.
It came from your New York Life group. I gotta call them tomorrow and get them to get a different person on our thing.
No, see. After disability benefits have been payable for 24 months, the employee considered disability if solely due to injury or sickness if he or she, and it's down here. That's before. This is after 24 months. This is definition of disability disabled. So that's the initial one. But after disability benefits have been payable for 24 months, the employee is considered disabled if solely. But it does say right here, unable to earn 60% or more of his or her indexed earnings. But he said it didn't. But I mean, the jobs he found were within that range.
Yeah, but they weren't anywhere local. If you can't work, then it doesn't matter. He's like, oh, well, you can find jobs in Alaska. What the fuck is that going to help you do? Like, you can't get to Alaska. Oh, you can find jobs in Brazil, and I don't live in Brazil.
Yeah, like, that's the thing that's, they're not being, I mean, but that's what everybody was saying they were going to do anyways when I was doing a bunch of research.
Well, I'm going to get somebody else to represent our case. Fuck Andrew. He's a piece of shit. So, this is our other stuff for the house. Our tax things and whatnot. And look.
What the heck?
It's because I got your DVA.
Oh my god.
So now they're making special flyers with your name. Oh, that's, I guess, local businesses trying to get our business.
Oh, yeah.
PC Tart. Look, turn it around again.
What the heck?
That's what your name looks like.
Did you get any letter or anything for it?
Yeah, we got. It's titled. It's yours. Doing business side.
I was just curious.
So now, if anyone ever tries to, you're branded. They can't take your.
My what?
Branding.
They can't take them. They can't take the name.
No.
So I can start up a company called PC Tart.
It's already started.
Oh.
That's why you're getting mail.
I'll just start doing how Nintendo was doing, where just start doing everything under PC Tart. We'll start making trading cards, video games, fucking whatever, whatever people will buy.
After this pizza, I gotta go.
All right. Return only digits. Okay. That it calls only digits on one. I forgot that's Python. Oh, I think I need to put this in parentheses. I think that should work. Make sure every character. Okay. mean, I don't know. I fed them twice already, but they'd probably eat again. Okay. What is it? Only digits.
Pizza's ready. All the things.
Equals true.
There you go. That's what I used to do when I was a kid, and I was told I had to eat the crust. That's what I used to do.
What'd you used to do?
Eat the crust first, and then save the topping for later.
Oh.
We got invited to a Super Bowl party.
A Super Bowl party?
Andy invited us out there. I think they're out, and they moved a little bit further out, but us and the family.
Look at us. Aren't we cool?
Hey, we got some cool friends, man.
Well, yeah, you do.
Amazing. We all do. Me and you. They're our friends. I mean, yeah, I've known Andy for a while, but that's our friends.
Yeah.
And I mean, your homies is dope too.
Yeah.
And I'd like to think that they were our friends.
Yeah.
I mean, I've known Ben longer than I've known you.
Yeah.
The only person that I've met through you that is dope as fuck is Alex. Actually, all your homies that I've met through you is dope as fuck. I've yet to find one that I'm like, meh. Well, I take that back. There's one. Just one. I forgot about that one. It's cool. It's cool. It's cool. It's cool. It's cool. It's cool. Alright, we're still figuring it out. I wonder. Before I go.
Okay. If I put 42, should return nothing. Return nothing. If I put banana. Caesar. Banana. Crap. That didn't work. Do that.
Hey, no, oh shoot, 11:30 program returned. 0 in this case. Meanwhile, if we do this.
I like this this community circle thing that you added me to.
People the one here?
Yeah, people awesome. Are finding stuff and posting it in it, and the owners of lost keys and stuff are finding it.
Well, yeah.
I like that. It's a little nice little community. A little small town vibe, big city culture.
Digit. Oh, spelled it wrong.
I need to get a tattoo shop here.
Honestly.
Because that's the third group thing that I've seen for tattoos. I said I'm at Nexus Rose. Closest to Manor. Am I still not in this group? What are you talking about? It says join and now I gotta wait for them to approve me?
Nah, they approved me really fast. I think they approved me like the next day or something.
Well, that doesn't mean no good. I'm already in the group though.
No, well, it might just be a little typo thing.
No.
Something messed up or something, I don't know.
That's it.
What the heck? Did I not run the debug?
This review is for group safety, so admins can get to know participants. You can create 5 posts and comments. The admin review is pending. After 5 posts and comments, you're in. Find businesses in Maine are looking for a space to rent. What's up? Anywhere from 500 to 700 square feet. Their wedding photos were so cute. I can't believe he picked that photo out of all of them though. Hers is so pretty. Danica. I gotta go. Awesome. I love that. Apparently, amongst everything China has heard about the U.S., China has officially declared it out loud that child endangerment of sorts will be punishable by deletion of the person.
Nice.
Making it
Straight
a severe escalation publicly for these such heinous crimes.
Well,
it's to deter bad actors from ultimately, because you're doing your thing, right?
Oh, yeah.
From doing these acts, and it's a bold statement amongst everything going on. That was hard rewording because there's words I don't know what is okay and not okay. But go China. Why is China capable of doing it but not us? Like, come on now. We should be protecting our babies. Reason grandma lived on one income and not today's society. Number 1, no endless tech to upgrade. Number 2, no subscriptions for everything. Number 3, everything was made from scratch, including food and gifts. Number 4, kids didn't come home with a new fundraiser each week. Number 5, items were made to last, not to break every 1 or 2 years. Honestly, it's accurate. That's why our house is going to be filled with antiques. Oh my goodness. Look. You get it?
Yeah.
It's amazing. Alright, let me help the baby. What's up, baby? You have what?
how did you do the? Okay, that returns 0.
Alright, I love you, but I got to go.
Okay.
Sorry. I know I've been
Love you.
bugging. The kids are gonna start taking their baths. So, I need a sweater. None of the chores. Since you guys are doing chores right now.
Motion detected at front door.
Alexa, what's my name? Alexa, I am not Damien. Cora.
Let me think. Okay. So it's gonna run through the string for the length of the string. Oh wait. Is that what it was? Maybe that's what it was. It's supposed to put the whole thing in parentheses. Oh crap. Four.
Okay, Cora, I've started the dishwasher for dishes tonight. You can empty it, okay? Empty it, and I can help you if you need help with putting the rest of them in. They already kind of.
Non-void function does not return a value in all control paths. Okay.
he's like, "Mommy, wait, hug," and he just. I was like, "What is that?" Love you.
Love you.
See you soon.
It's always gotta be one little mistake. God dang, bro. Fuck. Why is it returning 0? If it meets this condition, if this equals false. Okay, look. God dang. I can't even debug this thing, dude. No, I can't debug this stupid thing. God dang it. Okay, I was able to successfully do this. Okay.
Alright, your bathroom.
Okay. Yeah.
Where's new batteries?
Where's new batteries?
For the.
I don't know, Declan. I don't know. I don't know. I already told you that. We don't have any more. You already used them all for all the toys.
Motion detected at front door.
Well, so much for that. So the problem I'm having is proving that it's a digit. Ario wants a prototype like this. Okay. I created that. I'm using that. The debug can't even help me. God dang. Holy moly. Alright. So it's getting stuck on returning 0. That's the gist of it. Or is this the problem? Trying to get rid of this. Is this stopping it? Am I just an idiot? Hold on. God dang it. What? Oh, that's I'm so stupid. What is it? You okay? I feel like an idiot. That's what it was the whole time. No. Oh my god. That was so stupid. I didn't even think about that. Okay, well. Okay. What? Using the key. Oh my god, what? The baby? pizza. Something to fuel the brain. Alright. Now, well, ooh, yummy. Oh no. I don't think I can lock in now. Alright. Now, 216. Oh yeah, I got a few more subs. Yeah, I got some yesterday, dude. Yeah, I know. Well, after we got off, I got back on. I think it was like a couple hours later. But I guess you were already in bed or something. Yeah, I'm on my last problem though. I was gonna try to finish this before hopping on. So I might be like, I don't know, maybe an hour or something. I'm like in it. I already did like 2 problems and this is my last one. And like I'm halfway through the problem, so hopefully I should finish it kind of soonish. I think so. I hope it only take that long. I'm already like halfway through it, so. Okay, now modify main in such a way that it converts that into an integer. Okay, here. I'll take this out. I don't need that no more. I think. Wait, what? What's that? I've never heard of that one. See, it's the only thing when I get to these problems, they start making me use stuff that I didn't see in the video. I'm starting to get better at this. I'm starting to figure it out better. Which one did it say it was in? A standard library. Oh, nice. Oh, dude, you missed it, by the way, too. I don't know if you're still there, but I was on, like, a win streak last night. I got my rank back up to diamond. I almost made it to diamond, too, but then I started sucking again. Well, plus, it was, like, midnight, but... Mmm. Pizza awesome. Alright. Oh, okay. All I really need to do is just int ATOI. And then, what else I gotta do? Crap, I don't remember. Oh, you gotta add that to it. You gotta add another one. Jesus. There's so many. Standard library. That's a lot of stuff. Alright. Where's that sound coming from? Jesus. Oh my god, it was my baby's phone. She got a little baby phone. Jesus. Okay. Let's see. Converts to integer in my phone. Dude, they help you so much in this. To be helpful, permanent. And then use getString to prompt the user for some plain text with plain text. Okay. I guess we'll just call it plain text for now, right? No, wait. String plain text. String. Plain text. All right. Oh wait. Oh, whoa. I did it too soon.
Dada,
Yes.
I'm
Yes, sir.
my PlayStation 5 controller
Yes, sir.
needs a charge.
It needs a charge.
Put it on the bedside, see?
All right. All right. Then implement a function called rotate. Rotate the character. All right. Implement a function called rotate that takes a character as input and also an integer and rotates that character by that many positions if it's a letter. Oh, crap. Alphabetical. Wrapping around from Z to A and from Z to A as needed. If the character is not a letter, the function should instead return the same character unchanged. If the character is... Holy crap. That sounds confusing. Oh, it's already a problem on a prototype like this. Thanks for helping me out, buddy boy. Give me all the help. Okay. character rotates. God, dude, that sounds... I don't even know what they're asking for, honestly. That sounds crazy. And alright. For each character in the plain text, rotate the character if it's a letter. Function call like rotates A1 or even rotate A27 should thus return B, and a function call like, okay, this sounds crazy. Okay. Okay, what? Jesus Christ. Character rotates. Jesus. You see. Oh my god. Oh my god. Wait, I don't need to do that. What am I doing? Okay. A1 or even A27 should thus return B and a function call like what? Should thus return B and a function call like exclamation mark should return exclamation mark 13. What? Recall that you can explicitly cast a character to an integer with int and an int to a character with char, or you can do so implicitly by simply treating one as the other. Odds are you'll want to subtract the Haskell value of A from any uppercase letters. So as to treat A as 0, B as 1, and so forth. Okay. While performing arithmetic and even added back when done the same. Odds are you'll want to subtract the actual value of A from any lowercase letters so that A as 0, B as 1, and so forth, and then add it back when done the same. You might find some other functions declared in C type H to be helpful. Odds are you'll find percentage helpful when wrapping around arithmetic from a value like 25 to 0. I don't even know what the wrapping around stuff means. And then modify it in such a way that it prints ciphertext and then iterates over every character in user's plain text, calling rotate on each and printing the return value back. Oh my god. This is what? 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 What is it? Dude, come on, man. I'm right at the end of this thing. Okay. I'm gonna grab a pizza. Okay, let's look at the examples it gave us first, and then I'll check out this video. It's saying if let's rotate A capital A and 1, A and 27, thus should return B, and function. Why would 27 return B? And rotates exclamation mark 13 should return exclamation mark what? Why would it do that? I don't understand this at all. Number 33. I mean, there's only one exclamation mark. Why would it return another exclamation mark? It doesn't make no sense. I guess they're trying to rotate. But which way are they trying to rotate? Like, I don't understand what they're trying to do. Oh, you can type key. Should.
In Caesar, your task is going to be to encipher or encrypt some text by shifting all of the letters in that text by a certain amount. What your program is ultimately going to do is it's first going to get the key, the amount that we should shift each character by. Then we're going to prompt the user to type in some plain text. Then we're going to encipher that plain text by shifting all of the letters by the key. And finally, we're going to print out the resulting ciphertext. What does this look like? Well, if the key is 2, then for any plain text character, we're going to shift that character by 2 letters in the alphabet. So if we had a plain text capital A, that would be...
You're asking for the key the first time. What? What? Okay. So
Become the ciphertext capital C, because we're shifting it by 2 letters in the alphabet. B would become D, C would become E, so on and so forth, up until X would become Z. And then when we get to Y, if we were to shift Y by 2 characters, we would go past the boundary of the alphabet. So what we'll instead want to do is wrap around to the beginning of the alphabet, so that Y becomes A when we shift it by 2, and Z becomes B when we shift it by 2. What does this mean for how your program should actually work? Well, if we were to run /Caesar and then provide as a command line argument the number 2, meaning we want to use 2 as the key, shifting everything by 2,
okay.
and we were to type in the plain text ABC, then your program should print out the ciphertext CDE, the same as the plain text, but with every character shifted by 2 letters.
All right, I get that part.
If we were to instead
That's easy.
run /Caesar2 and provide the plain text of hello, for example, then the ciphertext should be this, JGNNQ, which is each of the letters in hello shifted by 2 letters.
Oh, that makes more sense.
Let's take a look at one last example. If I were to run /Caesar with a key of 2 and input a plain text of this is CS50, then the ciphertext should look like this. And there are a couple of things to note here. One is that we're preserving case. If a character is an uppercase letter in the plain text, then it's also an uppercase letter in the ciphertext. And likewise, a character that's a lowercase letter in the plain text is also a lowercase letter in the ciphertext. And any character that's not an alphabetical character at all, so things like spaces or numbers or punctuation marks, those don't change. The spaces stay spaces, the 50 stays 50, the exclamation point stays an exclamation point. Only the alphabetic characters are changing. So let's go through each of the steps of the Caesar program to figure out how you can actually write the code to do this. The first thing you'll want your program to do is to get the key, get the amount that we should shift each of the individual letters by. How is your program going to do that? Well, remember that your program is going to take the key as a command line argument, meaning that when the user is running your program, they're going to run your program as something like /Caesar followed by a number representing the key of how many characters to shift each of the letters by. How do you access those command line arguments? Well, recall that in a C program, your main function can take arguments. It can take an argument called argc, which is going to represent the argument count, the number of command line arguments, and also an array of strings called argv, representing each of those command line arguments. So for example, if I were to run /Caesar and then the number 3 as the key, argc would be 2. I typed in 2 things, /Caesar and 3. And argv is going to be the actual array of strings representing those arguments.
Oh, so someone finds
And recall that when you have an array, you can access an individual element of that array using square bracket notation. So argv0 is going to be the first string in the argv array, which in this case is /Caesar. And argv1 is going to be the second thing in that argv array, which in this case is the string 3. So that's how we might access the key. Now, when we get the key, you'll want to ensure that only a single command line argument is provided, and that that argument contains only digit characters before you actually take that argument and convert it to an integer. What I mean by that is that if the user runs /Caesar and then 2 and then 8, providing more command line arguments that's expected, your program, rather than doing anything else, should just print out a usage message, reminding the user that in order to run the Caesar program, they should run /Caesar followed by a key. And you should do this anytime they don't use the correct number of command line arguments. But even if they have the correct number of command line arguments, that argument might not be entirely numeric. If the user runs something like /Caesar 20x, where the command line argument is not entirely numeric, you should also display a usage message, reminding the user that they need to run /Caesar followed by a valid key. How do you check if the key is valid? Well, you'll probably want to take that command line argument and check each of the individual characters in that string to make sure the character is a digit. And you might want to think about what functions might be helpful for checking if an individual character is or is not a digit. Once you've checked to make sure that the command line arguments are correct, the last thing you'll need to do here is actually take the command line argument and convert it into an integer. Notice that argv1 right now, representing the key, is not the number 3, but the string 3. Recall that in C, every variable has a type. Some variables are int and other variables are strings, for example. And here, argv1 is the string 3 rather than the integer 3, which we'll probably want to use in case we need to do some math with that number, for example. So what we'll need to do is convert the string into an integer. To do this, you can use the a2i function, declared in standard lib.h, that takes a string, like the string 3, and converts it into the number 3, for example. So that function might be helpful for making sure that your key is in fact an integer. After you've gotten the key, the next step is to prompt the user to type in the plain text. To do that, you can use a call to getString, asking the user to type in what plain text they want to encrypt. Once you've gotten that plain text, the next step is going to be to encipher that plain text, shifting all of the letters by the key to get the ciphertext result. But before we talk about...
Wait a second. From string to an integer.
how to encipher the entire plain text, let's just talk about how to encipher one particular character. How are we going to do that? Well, there are a couple of cases that we might want to consider. If the character is an alphabetic character, like an uppercase letter or a lowercase letter, for example, then we'll want to shift that plain text character by the key, making sure to preserve the case. If
it's alphabetical, shift.
Was originally an uppercase letter, it should stay an uppercase letter, for example. Of course, if the character is not alphabetic, for example, if it's a space or a punctuation mark or a digit, then you can leave the character as is. Nothing actually needs to change there. But how do you know if a character is an alphabetic character or an uppercase character or a lowercase character? Well, it turns out there are a number of functions that you can use that might be helpful here. Functions like isAlpha, isUpper, and isLower. IsAlpha is a function that takes a character and returns a Boolean value, true or false, depending on whether or not that character is alphabetic. And likewise, isUpper checks to see if a character is uppercase, and isLower checks to see if a character is lowercase. If we call isAlpha, isUpper, and isLower on capital A, for example, isAlpha of capital A is true, A is an alphabetic character. IsUpper of capital A is also true, because capital A is an uppercase letter, and isLower of capital A is false, because capital A is not a lowercase letter. And so that can help you to figure out, given a particular character, is it an uppercase character or is it a lowercase character? And every character, uppercase and lowercase, has an ASCII value. Recall that ASCII is just a mapping from characters to numbers that represent them, where we've decided that capital A is represented by the number 65, capital B is represented by the number 66, so on and so forth. And lowercase letters have a mapping as well. Lowercase a is represented by the number 97, lowercase b by the number 98, lowercase c by 99, so on and so forth. And you can treat any individual character as equivalent to the number that represents it. So what does that mean in code? Well, it means that if I have a character in a variable called c that I set equal to the character a, capital A, and I print out that character using %c to mean I want to substitute a character into this string, then what gets printed out, as you might expect, is the character a. But this character a is really just the number 65 inside of my computer, and I can treat this character like the number 65. And like any number, I can do math with it, adding or subtracting numbers from it, for example. So I can take capital A and add 1 to it, for example. Capital A is represented by 65. 65 plus 1 is 66. So if I print out the character corresponding to the number 66, what's ultimately going to be printed out is the character B, because B in ASCII is represented by the number 66. But what happens if I try to take a character like the character capital 66? To the number 66, 65 plus 1 is 66. So if I print out the character corresponding to the number 66, what's ultimately going to be printed out is the character B, because B in ASCII is represented by the number 66. But what happens if I try to take a character like the character capital Z and shift that by 1? If I take the ASCII value corresponding to the letter Z and add 1 to it, I don't get the ASCII value corresponding to capital A. I get something that's outside of the range of all of the capital letters. What I'd really like to happen here is that once I try to shift past the letter Z, I want to wrap around back to the beginning of the alphabet, back to the letter A. But how do I do that? Well, to do this, we can take advantage of a formula. And here's the formula that we're going to use to convert the plain text into the ciphertext. It looks a little bit complicated, but we'll break it down piece by piece. C sub I here represents the ith character of the ciphertext. How do we determine what the ith character of the ciphertext is? Well, we're going to start by taking the ith character of the plain text, and we're going to add k to it, where k is the key. And we're going to take that whole result and take it modulo 26. This percent 26 means we're going to take the remainder when we take this whole value and divide it by 26. Why does this work? Well, for sake of example, let's say that A is represented by the number 0, B is represented by the number 1, C is represented by 2, so on and so forth, up until Z, represented by the number 25. So how might I go about taking the character Z and shifting it by 1 using this formula? Well, here's the formula, and the plain text character I want to shift is the character Z, which is here represented by the number 25. And I want to shift it by the key K, which in this case is 1. So I have 25 plus 1, which is the number 26, and 26 mod 26 is what's the remainder when I divide 26 by 26? Well, the remainder is just 0. So I'm left with 0, which corresponds to A in the above chart. The result is that I'm able to take a character, shift it by a certain amount, and by using modulo 26, I'm able to get the remainder when I divide it by 26, which allows me to loop back around effectively to the beginning of the alphabet. So the Z wraps around to A. And this mapping of A to 0, B to 1, C to 2, etc., you can call an alphabetical index, where I might say that A's alphabetical index is 0, B's alphabetical index is 1, C's alphabetical index is 2, and so forth. But of course, in our computer, we don't use the alphabetical index to represent each character. We use ASCII, where A is 65, and B is 66, and C is 67, and so we can't directly apply this formula. So, what do we need to do in order to take an ASCII character and shift it by a certain amount while still preserving this wraparound effect of going from the end of the alphabet back to the beginning? Well, here's what we might try to do. We might first convert an ASCII character to its alphabetical index, so that capital A becomes the number 0, for example, and capital B becomes the number 1. And you might want to think about what math you could do to make that work. Once you have an alphabetical index, you can shift that alphabetical index using the formula, adding the key and taking the result mod 26 to get the new character's alphabetical index. And finally, you can take the resulting alphabetical index and convert that back into ASCII, so that 0 becomes A, 1 becomes B, so on and so forth, being sure to preserve the case. Uppercase letters should remain uppercase, lowercase letters should remain lowercase. And that will allow you to encipher one alphabetic character. If it's alphabetic, you'll want to shift it to its alphabetic index, then shift it using the formula, then convert the result back to ASCII. But how then, instead of enciphering just a single character, do you encipher all of the characters that are in the plain text? Well, recall that the plain text is really just a string. And when you have a string, you can access individual...
Yeah.
Can you ask him if we can, the thing about Netflix?
What?
Like, can you ask Ben for Netflix?
Why? It's 7 o'clock.
Oh.
Y'all supposed to be taking baths anyways. You still haven't taken a bath?
I'm getting ready for all
Why
that.
are you asking about Netflix? Go take a bath.
Okay.
You were supposed to take a bath a long time ago. Oh man.
Well, characters by using array-like notation, where I can say text square bracket 0 will get me the first character of the string text. which in this case is capital T. Likewise, text square bracket 1 is lowercase h, text square bracket 2 is lowercase I, so on and so forth, and I can use this notation to access any of the characters inside of the string. How do I know how many characters are in the string? Well, there's another function called strlen, short for string length, that will take a string and tell you
What's
how many
up,
characters
Muhammad
are in this
Ahmed?
case, 12. So by combining this, knowing the length of the string,
Oh,
knowing how to
man.
access an individual character in the
I'm on the
string,
last problem.
and knowing how to encipher an
I'm
individual
almost
character in the
towards
string,
the end.
you
This
should be
part's
able to
hard though.
implement this Caesar program by first figuring out what the key is, then getting the plain text, then enciphering that plain text by shifting all the alphabetic characters.
Alright, I gotta get his little formula. Where's that formula at? There we go. Alright, holy crap. This is gonna be interesting. Okay, so. Alright, what did this do? This turns. What? Converts a positive or negative integer from a string 50 to an integer 50. Oh yeah, that converted it to an integer. From a string to an integer. Okay. Prompt user for plain text for each character in the plain text. Alright. Okay, we'll do, I haven't used I, have I? I think so. Oh, crap. God dang it.
letting her play with it. She wants to play with it.
Okay.
And I'm letting her. And play with it. You want it? No. You want to play with it? She wants to play with this teapot. Ruby could play with it. I'm not saying no.
If plain text.
Olivia could play this one.
Character.
Okay. I'm saying yes.
What? Olivia, I'm trying to do this. You want juice? Okay, hold on. Well, if I turn that into an integer, then do I still need that? I don't even know. You okay?
Okay.
You don't want juice?
Yeah.
Oh my God. Concentrate, man. Okay. If it's an alphabet letter, then send it there. God dang, man. I swear. Look. Okay. That'll send the number, and it'll send the text, and it'll loop through each text. What?
I'm letting her play first, though, but she wants it to not be mine and be hers. She wants to take it from me. She wants to turn it into hers, not
Dude,
mine.
I don't know, man. What? No. Olivia. Dang it, man. plain text. Okay, so that'll take the character. If it's a character, that'll take it. So send it down here. And now I gotta do this crap with the formula. So now I know that. Okay, it's only take. Okay, so. If upper is upper I need to convert it. What was the word for that? If it's upper, then I need to convert it. Where we at? Where's that? Okay. Okay, convert it with this. C. Okay, that'll convert it. And then convert it, and then I need to rotate it or use that formula. Where's that formula he had? Okay, so it's the character. I wonder if I can do it like this: equals. Hello? Yeah, I'm on the last problem I'm trying to finish. Do you need to talk? No. I know it's hard to concentrate. I'm on the last problem. We'll just. I don't know. Love you. Let's see, convert it.
Case is 1. This character I want to shift is the character Z, which is here represented by the number 25. And I want to shift it by the key K,
Plus. message you're in. What?
A cookie. Dada.
What?
Cookie.
I don't have a cookie.
Please.
I don't have a cookie.
Oh, what's it come? What's it come? Dun. 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 Dun.
What?
Say
Bye. Wait.
which in this case is 1. So I have 25 plus 1, which is the number 26, and
Dada.
What?
Dada. Join the book of it. No, do hot. What little one is me? A baby. Baby knows some more. Do you want it? Wait. Wait. Dada,
What?
what's that count? Oh, Dada. Dada.
What?
What's it called? Dada.
What? Olivia. Stop. What? Dude, I'm trying to do this. Stop. Dang it. I can't just sit here and do this. I swear to God. That's why I can't fucking get anything done. Oh my God, I'm gonna lose it. Alright, now I need to know how to convert it back. From a string to an integer. From a string to a long. From a string to a float. Okay, how do you get it back from an integer to a... This function returns its input s as an integer. How do you turn it back? No, you only get one. No, you only get one. That's it. I don't even remember what the thing was called. I think that's... What is it? 77. Okay, that does work. Okay. So I can convert it straight into an integer. I don't need to do all that. I don't think I gotta do that. I'm gonna just do this. Or maybe I can't do that. should just leave that. Never mind. If upper, okay. Dang it, that's not what I meant to do. What? What? Declan, no.
No, wait. Waggy. Quilla, quilla. Quilla, quilla, quilla.
Okay, if it's upper, that. If it's lower, that. It returns. Okay. It'll return it here. Yeah.
I would new batteries in my night light.
Huh?
New batteries in here. Because
Well, I don't have batteries. Declan already told you.
not even double A.
Oh, I didn't see the message till now. What?
Not even double A batteries.
Dude, I told you I don't. Y'all already used all. You keep coming to me with new toys and more batteries. I don't have any more batteries. Okay. God, how do I get a? I don't even know how to return this correctly. So it'll return those characters here. I don't even know. Okay. Then modify main in such a way that it prints ciphertext. I don't know if this is gonna work correctly. And then here's $35. Integer. Says plain text is an integer. Oh wait, I don't gotta put that. I think I'm just gonna put that. Just trying to call that command is all. Oh man, this is gonna be a lot. 37. What says 37? Oh. Character rotates 55. Says C and C. Okay, declaration shadows a local variable. Recall that you can explicitly cast a character to an integer with int and close parent. So I'm gonna do it like this. This definition here is integer. Okay. I'm doing these backwards, I guess. Let's see. Let's see. Special results unused. Trying to figure out the proper way to do this. Well, you know what? If that works, then I'm just gonna do that. This is probably gonna be tedious, but I mean, if it works, then I'm just gonna just turn this to freaking A. Let's try that. Screw it. Number. $71. Oh. Okay, if it's upper, if it's lower, it's already part of the alphabet. Yeah, because I already distinguished here that it's part of the alphabet. statement is here. So many errors. Misleading indentation. That's a German. Statement is not part of previous else. Man, what do you want from me? God dang. Text. It just returned the same thing. Okay. That's not going to work. Alright. I need to put this inside here and do something for this. But this needs to be inside here. Okay, I got the same thing back. Yeah, that's not gonna make a difference. I need to do something different. This ain't gonna work. I can create the loop, but this. I can't put that inside here. That function. Can I? I don't think I can. No. Because once I do that, then it takes it away. I can't. Yeah, I need to put this and that other thing. I'm gonna have to put it down here somehow. Alright, I gotta fit it in here because it's the only way. to integer conversion passing string AK character. Oh, that's why I had to do it the way I was doing it earlier. Oh, crap. Because the plain text has to be a character. Fuck. Like, I'm gonna... sends a character, returns a character. Can I just have it do a string? Like, screw this. I don't know. Probably not. God dang it. God dang. If I gotta do this in strings or characters. God, it's gonna be so fucking hard. What was the number 8? Integer n. Incompatible pointer to integer conversion passing string AK characters to parameter of type. Oh, man, I can't. This ain't gonna work. Okay, I have to find a way to do this in characters. Okay, if it rotates. I need to put the print function in there though, otherwise, because I can't work within that. Unless I just send all the text in there first and then check for each character in the plain text. Okay, maybe I could take this out. For every character, send it through here. And then put that down here. The if. Okay, let's try that. Let's bring this down here. screw it. Oh, good enough, I guess. God dang it. Whatever. Ideally, this would work, but I don't know if it will. There's no way this is gonna work. $53. Use of identifier plain text. Oh. What was plain text again? Plain text is the first input, which is C. That's right, I'm setting one variable through here, and then returning it. Oh crap, I don't even know if you've been there the whole time, dude. I just looked at the... I'm pretty sure you can use up arrow in the terminal to go back to the previous command instead of writing make manual every time. The compiler doesn't care what is inside ifs. It just sees that if both fail, the function doesn't return anything. Let me see. I don't know what I'm doing wrong with this, but yeah. What is it? What? Pepper?
No.
No.
Pepper.
What? What?
Pepper.
Pepper?
No, pepper. No, pepper. Oh, take my pepper.
You need to put whatever is in the else in it too. That is why it gives an error. I mean, it's inside the yellow thing. I mean, should I get rid of this? Let me see. Still not working. I don't know. Thought else was supposed to be out. Like, I don't know. Okay, I have to have these. And then I thought, or I guess I need else if. Oh crap, I need to reword all of this actually now I think about it. Because I just moved this down. Man. Let's see. Well, I thought that separated it all. You need a body for else. Thanks. Really? I mean, I don't know. Damn, this thing hates me. I swear, dude. Oh, wait. Oh, I need to put that. Anyways. I can't. Return. Okay, no, it's not taking that. Non-void function. Rotate should return a value. I mean, return what it brought in. Return C. Else. I don't even know if this is gonna work, honestly. Caesar, I'll just do one. It didn't return nothing. It just returned returns. Crap. Return returns 3 times. I didn't get nothing back. Oh man. This is tough. God dang. I guess I'll see what. It is really important to enforce a code style for yourself on the early stages. You will eventually build muscle memory, and that helps avoiding errors like this. Yeah, dude, this is, I mean, this one's like, I mean, trying to wrap my head around like the concept of this is like, because you're turning, it wants you to, it's this thing, you gotta turn the letters into, you know, the, how do you say it, the numbers they're associated with in the computer, the, you know what I mean? That word, I don't know however you say it, but I gotta turn them to their numbers, rotate them, and then turn them back to their, and it's just, I don't know why I got a return of 3 though. Or I got a return of 3 because there's 3 letters. Oh yeah, crap. And then, okay, I see what. Oh, that's not gonna work either because then it's gonna print this out for every letter. Didn't give me back anything anyways. Else return C. Let me check at least if it's returning. Well, it returns back the numbers at least. Not really the way I want to, but I gotta do and such. I'm just not returning the letters back correctly. I gotta relook at this. I don't really know how to do this. Is hard to figure out. Like, I gotta turn. It's like if it's alphabetical letter, I gotta turn it into an integer, and then do the math problem, and then turn it back into a character. I don't know, dude. It's a trip. If your code is readable to yourself, it is much easier to focus on actually solving the problem. Yeah. Well, this is where I'm mainly stuck at right here. Like, I obviously got to fix this so it's not returning every time. But, what I think I already know what I could do. If this is, I need to make it to where it prints it out. Let's see, because I have it. I need to do this differently somehow. Or associate a letter to it. Wonder if I can do something like just put dang, I gotta figure out how to make this part not repeat. Cause I need this to repeat in here. But I don't need this part to repeat. Let me see. That's the only thing. I need this to keep putting the characters in here. So I need to put print ciphertext. What if I do like up here and then put just the letters here? Oh, what if I do this? Hold on. What if I do dang it. Print. So how do you spell Ciphertext. Oh, it's a lowercase. I don't know how picky this thing is. Print ciphertext with the space to where it's supposed to. And then I think all I gotta do is that. And then below that, I can do one of these down here. And that should get it to print out correctly. Caesar. One. Oh, I forgot to. God dang it. Update it. Oh, crap. Alright, sweet. Okay, got that part figured out. Now all I gotta do is figure out how to do this part. It's yeah, no, yeah, so I got that. I got that. That's good. All I need is to figure out how to do this. And I'm kind of wondering if this is the hardest part. Let's see. Okay. I modify main in such a way it converts to an integer. Well, I already did that, right? Yeah, I did that a long time ago. Okay. Integer, you might find. And then use plain text, then implement a function called rotate that takes the character as input and also integer as input and also an integer. Rotates that character by that many positions of its letters. Let's see.
In Caesar, your task is with 0, and we're going to add k numbers from
Maybe
it.
I did too much.
7 lowercase b by the number.
Hold on, what if I can I? Was it like a? Can I add it to like a number like that directly? $98. Okay, and then if I take it away, wait, no, wait, +1, and character. Can I do that? No. It just prints 98. I don't know how to turn it back into a character. There. Okay, that's what I needed to do. Ugh. You rebuilt it after fixing it, but forgot to run. No, I ran the print. I got the print function right. I just had to figure this out. Getting the letter to a number back to a letter. Now I gotta get this over to... Okay. So... I need to do... And... Okay, hold on. How to do it. And character, change it back to a character is new number. New letter equals character. Right? Is that how I did it? Maybe if I wait, new number. Why is that still showing like that? Oh, I need to do... No, not that way. The other way. Let's see. Oh, there's probably like a easier way to do this, and I'm probably going the long way. Well, hopefully it works. Oh no. Oh no! Number. Okay. Dang it. They didn't return nothing back. It's messing up somewhere in here. Because I can get the numbers to go through, but I can't get the letters to go through and come back. The letters are returning none. Let's see. C01. What? Oh. I'm spelling it wrong. What, 1, 2, 3. I get 1, 2, 3 back. But enter A, B, C. Yeah, no. God dang it. You can just cast when creating new letter. No need for extra line. That's what I was thinking, but I'm still like, I'm obviously overthinking it. Look at the asterisks for the letters, and then think about what values the new letters can become in your code. Well, okay, like, it would be easy if I could just add, you know, the number to it. But what it wants me to do is, if it's at the end of the alphabet, then it wants me to loop it back. And the only way to loop it back is to use this weird little formula they got. So that's kind of what I don't know. Okay, the C's a letter. And then I gotta keep the uppers and the lower cases. Okay, wait. I haven't tried uppercase. I wonder if it's any different. Let's see. Yeah, the only thing I returned 3. So yeah, I'm messing up right here. Probably doing too much, honestly. I mean, in reality, I shouldn't be doing this A stuff. This should be C, because that's my return. And then I'm just doing that to try to force it into an integer. I'm gonna have to do that a better way. But I think I can do it like this anyways. I don't think I need to turn it into an integer. I think I could just do it like this. That. 26. It's like. And character name number. Yeah, let's take this away. And then I'll just put the character part in here. Because that looks ridiculous. Character. But if you turn it into a character... Wait. No, it did. When I did this, it turned it back into a letter. That's how I got B. What do I got up here? Character. Let me see. I didn't get nothing back. Oh, I typed that wrong. God dang it. Let's see. A, B. What the heck did I just do? Cipher. I didn't even put cipher that time. Your code space won't stop soon. Stop and then reconnect to your code space to keep working. What? Oh, hell. Try printing out new number and see what it gives you. That's a good idea, honestly. I don't know why I just got that. Why does it keep saying it goes